Yeah. Okay. I had also I mean, that's what it really is. Yeah. Two questions about I'll start. Oh, yeah. I got the last spot, right? Oh, that's right. Oh, yeah.
It's 8:01. Hi, should we start? Are we okay? Can everybody hear me? All right. Well, my name is Raymond Jin. I am a assistant professor in divisions of oncology and gastroenterology, and I want to extend a warm welcome to everybody to our first annual gastroesophageal cancer symposium. Before I start, I'd really like to thank organizing committee members, everybody here. I'd like to recognize two special people. Tez Akamaga is my research technician. He helped organize the website, the registration page. And then Chad Benson, he's outside. So he was my right-hand man through everything. So if you see Tez and Chad, please thank them in person. And of course, all our sponsors here. So I guess I was going to just run through it, but let me introduce a spokesperson for No Stomach for Cancer. She's going to say a few words.
Good morning, everyone. My name is Stacy Martin. I am a CDH1 mutation award winner, I guess. It's not really an award you want to win, but I had a total gastrectomy 6 years ago. So I am a patient survivor. I'm also on the board of No Stomach for Cancer. Throughout my whole journey, it's been an integral part of my education and support. I came to my first symposium at the University of Chicago in 2019, and that's the first time I met other people who are living without a stomach. And the support that this community provides is really unmatched. So I just really wanted to say thank you guys for partnering with us and hosting this. I hope you learn a lot today. If you have any questions, we have a table outside. There's a lot of literature and materials that we've provided as well. So welcome and thank you and have a great day.
Okay, thank you, Stacy. Now, the reason we're here and of the impact of gastroesophageal cancer. So how to start this, and I think this paper here, the study came out of one of the preeminent medical journals, American Medical Association, very recently highlighted these special early onset GI cancers. And these are cancers that occur in patients that are younger than age 50. They are the fastest growing early onset cancers, and they affect patients not just here in the United States, but worldwide. And gastric and esophageal cancers comprise a large proportion of these early onset gastric cancers. This summary of the main paper here shown on the left really shows some of these risk factors for early onset GI cancers. And what stood out to me is this word associated. And as a physician scientist, that really means we don't understand, okay? And really it's a lack of understanding of pathogenesis of this disease on the basic science side, but also clinically, how we screen, how we diagnose, how we treat. So compounded with that is our lack of funding for gastric and esophageal cancers. This is a recent publication looking at NCI funding, National Cancer Institute of our United States NIH, largest funder of cancer research in the world. And they really looked at what cancers are overfunded, underfunded. Metrics are not just number of cancers, but also kind of disability that those cancers cause and death. So you can see the top of the graph on the left here, breast, lung, brain, overfunded by those metrics. On the bottom, esophageal, and the very bottom, gastric. Another metric to kind of put this in perspective is the absolute number of grants by NCI, broken down by different cancers. And you can see breast cancers per year gets about 2,000 grants from the NCI, where esophageal and stomach about 100 each. And these grants are kind of the lifeblood that keeps labs like mine going to be able to do research on gastroesophageal cancer. So that's kind of a bleak picture, but that's not kind of the message that I want to impart. And I really want to impart a message of hope. And I'm hopeful because of everybody in this room. I'm not talking to an empty room. I'm talking with people who are passionate. We have like-minded beliefs that we can find a cure for this disease. And that's kind of the message for the symposium, a message of hope. Our goals today for the symposium are threefold here: advance knowledge collaboration, highlight emerging diagnostics, treatments, enhance patient care and support. Essentially, we're trying to unite basic science, clinical practice, patient support, because together we can not only push the science forward, but we can really transform the lives patients and families live with these diseases. So here's the agenda. So session 1 is going to be all about early detection, disease prevention. Session 2 is going to be about new treatments and research. At lunchtime, hoping that you would join us, we're going to have a meet and greet with Siteman researchers. Labs from mine, Dr. Jose Seance and Dr. Jeff Brown will discuss what research is and what we do here at Siteman. And then session 3 is going to be the patient experience at Siteman Cancer Center. It's going to be really highlighted by our tribute to Justin Hardy, who is basically the guiding inspiration for this symposium. And with that, here's some more sponsors. I'd like to really start the first session, early detection and disease prevention, and introduce our first speaker, Dr. Jose Seance. He's an assistant professor in the Division of Gastroenterology. He is a physician scientist. And I've known Jose, we've gone to medical school together, we've trained in the same labs, and he's going to talk about early detection of stomach cancer in the United States when guidelines provide little guidance. So please help me introduce Jose.
Morning. Thanks, Ray, for the introduction. I really want to thank Ray and the organizers for the opportunity to speak with you today. And as Ray mentioned, I'm a physician scientist, clinically trained in gastroenterology, but really my focus is stomach cancer. And what I wanted to briefly discuss today are some of the guidelines or the current state of screening guidelines here in the US. What are the obstacles, the limitations, and what's on the horizon? So before I start, I want to just kind of set the table, and I realize that the cliff notes to my talk are probably, you have them on your desk, but I want to set the table and place stomach cancer in a global and domestic context. And for those of you who are not aware, stomach cancer is the 5th leading cause of cancer-related deaths worldwide, with over almost 1 million cases diagnosed last year alone. And although stomach cancer incidence has been declining globally over the past 50 to 100 years, it's still a huge global problem. Shown here is a map of the prevalence of stomach cancer worldwide, and we can see certain regions with the highest incidence, in particular, the Far East, so China, Japan, Korea, Eastern Europe, and Central and South America, particularly along the Andes Mountains. So I would argue that it's important to know these global patterns of stomach cancer because in an increasingly globalized society, we as oncologists, as gastroenterologists, as physicians, are going to encounter patients from these areas. So we need to maintain a high index of suspicion. But why are these hotspots for stomach cancer? Why are these global hotspots? Well, for the past 40 years, we've known that the biggest risk factor for developing stomach cancer is chronic infection with the stomach-adapted bacterium known as Helicobacter pylori, or H. pylori. And turns out that the countries with the highest infection rates with this bug are the ones that also happen to have the highest incidence of stomach cancer. Now, later in the talk, or later in the day, Jeff Brown will be discussing how H. pylori can lead to chronic changes in the stomach and eventually lead to stomach cancer. And I'm not going to discuss the hereditary form of stomach cancer, which our keynote speaker, Dr. Guilford, will discuss. But I did want to mention that H. pylori is a bug that has basically lived with humans as long as we've been roaming this earth. And I want to highlight a fascinating article in Science roughly a decade ago, where they looked at the stomach of the Iceman. So for those of you who aren't aware, the Iceman was an early human who lived roughly 15,000 years ago. And he was shot in the back with an arrow and died in the Italian Alps. So his body was well preserved in the snow and ice of the Alps. So when researchers uncovered his body tens of thousands of years later, they were actually able to isolate, let me see this. Oh, there it goes. They were able to isolate DNA of H. pylori from his stomach, suggesting that H. pylori has been with us really since the dawn of humanity. Now that's stomach cancer in a global context, but how about here in the US? Well, while stomach cancer is far less common in the US than it is, for example, in the Far East, it's unfortunately often a terminal diagnosis when we do detect it. Last year alone, there were over 30,000 new cases of stomach cancer, resulting in over 10,000 deaths. And the 5-year survival rate is dismal at roughly 38%, meaning that the majority of patients diagnosed today with stomach cancer won't be alive in 5 years. And while that's sobering, I think there is reason for hope. Like with many other cancers, if we can detect stomach cancer at its earliest or localized stages, we can really significantly improve overall survival. But the problem is that here in the US, stomach cancer is often detected at late or advanced stages when treatment options are limited. And so if there's one thing that I've learned as both a gastroenterologist and a researcher studying stomach cancer for the past decade or so, it's that if we're going to improve overall survival, we need to focus our efforts on enhanced and earlier detection methods. So how do we go about doing that? Well, in my mind, this can be achieved in 3 main ways, and I'm going to highlight these and talk more about these for the remainder of the talk. But first, we need to improve and implement more targeted screening strategies. Second, we need to increase stomach cancer awareness through symposia like this one, but more importantly, as Ray mentioned, increasing funding for clinical and basic science studies. So at the end of the day, we fall down to money as being the major driver. And then finally, we need to move away from this one-size-fits-all approach and more towards a personalized approach to diagnostics and treatment. So obviously easier said than done, but I wanted to highlight how we here at WashU are making some advances towards meeting these objectives. So before I go into this, I do want to stress that stomach cancer is a preventable cancer. Like many other cancers of the GI tract, it develops over many years of chronic inflammation, usually as a result of H. pylori infection, And it progresses in a stepwise fashion through these precancerous stages, which I won't go into. But we as gastroenterologists can detect these stages endoscopically, and it allows us to kind of identify patients who are at an increased risk of developing stomach cancer. So again, in summary, the earlier that we suspect and detect it, the better off our patients will be. Problem is that we don't have sufficient data here in the US to really guide us. And so I think that we can learn quite a bit from countries in the Far East, which have to deal with stomach cancer and where stomach cancer is a big problem. So I wanted to highlight a study out of Japan published this year. And what they did is they took patients who were either 40 or over, and they decided to scope them, so do an upper endoscopy, either if they develop symptoms or simply screen the general population. So regardless of symptoms, they would undergo an upper endoscopy. And what they found is that if they waited for patients to develop symptoms before they presented to their gastroenterologist, often these patients would, when they did detect stomach cancer, it was advanced stages, so stages 3 and 4. Over 90% of the cancers that they detected were these advanced stages where treatment options are limited. However, if they actually took patients who, regardless of symptoms, and simply screened them, they completely flipped the script. And now over 80% of the patients who had stomach cancer had it at an early stage, so stage 1 and 2, when you can actually resect it and treat it. Well, how about here in the US? According to the most recent guidelines from the American College of Gastroenterology, which were published just this year, they actually recommend against routine screening for stomach cancer. And when they talk about targeted screening, which I'll discuss in a second, they can't really provide any clear guidance on targeted screening approaches. So it should come as no surprise that the majority of stomach cancers diagnosed in the US are diagnosed at late stages, which essentially mirrors what was happening in that Japanese study. So who should get scoped here in the US for stomach cancer? Again, the data in this country are pretty limited, and because of that, there's no clear stomach cancer screening guidelines here in the US. But I think we've started to learn, and there's been increasing studies that perhaps we should take a more targeted approach to screening for stomach cancer. And so I would argue that we should consider screening in those with a family history of stomach cancer. So first-degree relative, mother, father, or sibling. And we should also take into account the patient's background. As I mentioned earlier, patients who are first-generation immigrants from some of those regions that I discussed earlier, East Asia, Eastern Europe, and Central and South America, should be considered higher risk for developing stomach cancer. Now, in addition to broadening our screening options, I think that we need to overall increase stomach cancer awareness. And what does that mean? Well, as Ray just mentioned, stomach cancer is consistently underfunded in this country. And again, to rehash, I gave him this slide just to be clear. To rehash what Ray said, it doesn't take a PhD to realize that stomach cancer, highlighted here in yellow, is dead last in terms of cancer funding, really regardless of the metrics that you use. And again, stomach cancer screening is not offered and is not recommended in the US, and it falls down to money. It's not considered to be cost effective, which is a pet peeve term of mine. And then finally, if we're going to raise stomach cancer awareness, we need more studies. We need more funding for basic and clinical research studies that are going to provide adequate guidance for screening in this country. And we're starting to do that here in the US. So I just wanted to highlight we were fortunate enough to get some funds from the Foundation for Barnes-Jewish Hospital a couple years ago to start this Gastric Cancer Research Innovation Fund. And this took a multifocal approach to understanding stomach cancer and to building more personalized approaches to diagnosis and treatment. And so this was a collaborative effort. It was led by Taryn Bigley, who's an immunologist, and myself. And we've been fortunate enough just recently to receive additional funding, again from the Foundation for Barnes-Jewish Hospital, to expand these studies not only to stomach cancer, but also for the early detection of pancreatic cancer in a program known as PREVENT. And so what does this funding allow us to do here at WashU? Well, as I mentioned earlier, if we want to enhance our ability to detect stomach cancer, we have to find better ways of detecting some of the precancerous stages that develop. And one of the biggest limitations that we face as gastroenterologists is that we visually inspect the lining of the stomach, but we often miss things. There are things that we can't detect by eye, and often these suspicious lesions might get missed. If we do detect them, it might be completely incidental or random. And so in the end, we're limited by our visual inspection. So to address this, in collaboration with a bioengineer and a close friend of mine from med school, Leo Shmulevich, we turned to thermal imaging. Using a highly sensitive camera, we're able to detect small changes in temperature and blood flow. And the idea is that we can detect literal hotspots in the stomach that we wouldn't detect by eye. Now, we're currently trying to adapt this imaging camera to an endoscope so that in real time we can see these hotspots and we could take more targeted biopsies of these suspicious lesions that otherwise would be missed. Now that's detection, but how about treatment? So again, in collaboration with Taryn's lab, we've actually been able to isolate cells from the tumors of patients with stomach cancer and then grow these cells into many sort of stomachs, three-dimensional stomachs in the lab. And the idea is that we can try to see how these organoids respond to therapy. So you can imagine that we would know before we're starting a patient on chemotherapy, which may or may not work and would only subject that patient to toxicity, we would know if that patient's cells are likely to respond to it before we start the therapy. In essence, tailoring therapy to the patient. So the hope is that we can continue to make advances, but I just wanted to end on a cautionary note and also a call to action. And so, as I've mentioned, stomach cancer has taken the lives of countless Americans, many of whom we grew up with or who our parents grew up with. And yes, John Wayne did die of stomach cancer. He overcame lung cancer, but he did die from stomach cancer. And while there's been a slow and steady decline in stomach cancer among American men in this country over the past 40 to 50 years, there's been an alarming rise in stomach cancer among white women, particularly white women under the age of 50. And this is data from Constanza Camargo's group at the NCI. And the reasons for this aren't entirely clear. In addition, as Ray mentioned, there's been a steady decline in late onset gastric cancer, so gastric cancer after the age of 50. But over the past couple of decades, there's been this uptick in early onset stomach cancer. We don't have great explanations for this. And I would argue we need more studies. So the call to action here is that we need to keep stomach cancer on our collective radars. Because at the end of the day, we're not doing this as researchers and as clinicians. We're not doing this for funding or grants. We're doing it really for the patients that we treat and the families and friends that are impacted by this disease. And so as Ray mentioned, I wanted to just highlight Justin Hardy, who was one of WashU's own. He played on their basketball team, and he, his battle with stomach cancer inspired countless others. And so I know Coach Junkin is here. I don't know if I pronounced his name correctly, but his basketball coach is here, and he'll be talking about Justin and the Hardy Strong Foundation, which was started by his family. So in conclusion, I just wanted to briefly summarize. Stomach cancer is, hopefully I've convinced you that stomach cancer is a leading cause of cancer-related deaths, and that we need to focus our screening efforts in a more targeted way and focusing on certain populations in order to increase detection. Finally, if we're going to impact overall survival, we need to raise awareness through symposia like this and through increased funding. And so before I end, I just want to acknowledge members of my lab, obviously the Gastric Cancer Research and Innovation Fund and PREVENT, and Foundation for Barnes-Jewish Hospital, and some funding from the NIH. Thank you.
So we're gonna have a question and answer session at the end of this first session. So if everybody can hold their questions to the end, all the speakers, if okay, come up and we can field questions for about 15, 20 minutes. So next, I would like to introduce our keynote speaker. This is Dr. Parry Guilford. He's the research director of the Center for Clinical Research, Cancer Research at the University of Otago, and he's also the research director for Pacific Edge Biotechnology. And his talk is going to update us on hereditary diffuse gastric cancer syndrome. So please join me in welcoming Dr. Guilford.
Well, thank you very much for the introduction and the invitation to be here. It's a great pleasure to be here, although it is 2:30 in the morning where I'm from. So if I look a bit bedraggled, that's my excuse on this occasion. So again, thank you very much for having me here, and I'm looking forward to giving you an update on what we understand of HDGC, and an update on the clinical management of HDGC, and what we're doing for research to try and improve the care of patients with germline CDH1 and ctNNA1 mutations. So a quick summary for you. Parts of this talk get a little bit complex and, man in the lab kind of stuff, but every few slides I'll try and summarize what I've been going on about, so hopefully we can all keep roughly on the same page as I go through these slides. So as you all know, HCGC is a rare cancer syndrome with about 5 to 10 new cases per 100,000 births. And it's caused by CDH1 mutations and also ctNNA1 mutations. CDH1 encodes a protein called ecadherin, which, if I can make this thing go, whoops, yeah. Put that back to there. Right. So the protein encoded by CDH1 is called ecadherin, and it's what's called a cell adhesion protein. So what it does, this big thing here is a cell and a neighboring cell, and ecadherin is a molecule which branches across between adjacent cells and holds those cells together. And on the inside of the cell, it's connected to a complex of proteins called the catenins or catenins, including the alpha-catenin, and they get joined on to the cell's structure. So all this is called the cytoskeleton. So all the features of a cell which give it its shape and its capacity to move and change. So really, ecadherin is just a bridge between neighboring cells, linking the structure of one cell to the structure of an adjacent cell to enable a tissue to be solid and firm and kind of behave itself. The most striking hallmark of HCGC is the presence of multifocal intramucosal gastric signet ring cell carcinomas. So what these are I'll show you a photograph later on, very small signet ring cells, so small abnormal looking cells we find in the stomach, and they occur and often in quite large numbers. We've seen individuals in New Zealand with over 400 individual foci of signet ring cell carcinoma, and I've heard of a person from Houston who had over 800 independent foci in their stomachs. The lifetime risk of developing advanced diffuse gastric cancer in carriers of CDH1 mutations is really quite variable. So it varies estimates vary from 10 to 70%, and depends on the study you look at to get an answer for what the actual penetrance is. And I'll explain why that is so variable in a slide or two. There's also about a 40% risk of women with a CDH1 mutation developing lobular breast cancer, and I'll briefly cover management of that later on as well. And it can finally be associated occasionally with cleft lip palate and certain eyelid malformations, but those are fairly rare. So just again to help us kind of get all on the same page, this is the structure of a stomach, and so this bit here is blown up from a small piece here. So this is the surface of the stomach. This is the side that your food arrives on. And there are millions and millions of these small glands across the entire stomach. So these glands have a job of producing enzymes and acid to help digest your food. But they have a fairly branched structure, and when a cancer develops, it'll start somewhere in this region in the middle here, and it will slowly grow, and until it breaches this muscle layer down here, it seemed to be fairly treatable if you can remove the stomach or remove the lesion when it's still confined to this area. It is considered to be a curable cancer. So that's where it all starts. So it's based on abnormalities in cells in these glands, and there are millions and millions of different glands in the entire stomach. So this is how we think HDGC develops. It starts off with one of these glands when the second copy of CDH1 gets inactivated. So as you know, you inherit 2 copies of CDH1 from your parents. If you have a mutation in one, that's no longer working. And then the second copy does all the work all through your development. And then at some point in your life, you can have that second copy knocked out just in one of those glands. And if that happens, you now have no copies of CDH1 which are active, and so there is no more of that protein E-cadherin, and so the cells start to behave abnormally. And what happens is when that second copy is lost in one of these glands, the cells don't always stay in place. They've lost that adhesion to neighboring cells, and they will then divide and move out of that epithelial plane into this area called the lamina propria. And from there, it'll grow and form a signet ring cell carcinoma. So these are simply just, really early stage cancers. They call them signet ring cells because if you look under a microscope, you can kind of see the cell is quite round, and the nucleus is pushed over to one side. So there's a kind of dark blob on one side, and the rest is full of a mucin. And so it kind of looks like a signet ring cell under a microscope. So as the cancer develops, you get these lesions forming. And so this is what I mentioned at the start, the hallmark of HDGC is lots of these early stage signet ring cell carcinomas, typified by these big, fat, round signet ring cells. The key thing about these is that they are really just normal cells in the wrong place. Sure, they look a bit unusual, but they are really just cells which they've come out of that normal epithelial plane and they've found themselves in the wrong environment, and they've grown a bit, but they really aren't too abnormal. They are still largely normal cells, but they just aren't quite where they should normally be. But then in time, some of these lesions, and we don't know exactly how this occurs, but some of these early stage lesions can develop and become more aggressive. They look more aggressive, they change their shape, and they start to move quite rapidly into the underlying layers and can lead to disseminated disease. So there's a really tricky switch occurring, which we really would love to know more about, between this early stage, which is quite indolent, simply cells in the wrong place, to an aggressive phase where things are starting to get more clinically significant. So I mentioned at the start the estimates of penetrance, or the risk in a family for developing advanced diffuse gastric cancer is really, or the estimates are very variable. So when we first started to look at this in New Zealand Maori families, we estimated that it was about a 70% risk. So 7 out of 10 people who had a mutation in CDH1 were going on to develop advanced diffuse gastric cancer sometime in their lifetime, normally before they were 45. More recent studies have showed similar figures, around up to around 70%. But then the later studies, the risk has dropped down to 30, 35%, and then most recently a study from the NIH showed for some families the risk was as low as about 7%. So we've seen this really strange variation in numbers, and so a lot of people would scratch their heads saying, well, how could it be so wrong at the start and so right now, or wrong now and right then? And the answer is simply it's all to do with it's called ascertainment bias. So it's in this figure here, I'm trying to show the spectrum of the disease, where in the darkest color in the middle, that's where there's the most severe penetrant disease, and then there are versions of the same cancer which aren't so quite severe. And if you sample from the outside of this kind of spectrum, you'll see not so much cancer. But if you get the cases in the middle, you'll see well, what you'll see will be a severe form of the disease. So, of course, when you start to look at families with HCGC, the ones you see first of all are the ones with the most striking penetrance. So the ones we saw were families, Maori families, where there were dozens of people who had died of diffuse gastric cancer. And so they're the really obvious ones. The first ones they saw in Europe, the first ones they saw in the US, same thing. They were just really obvious, incredibly severe cases or family histories of diffuse type gastric cancer. So those are the first estimates. So not surprisingly, they had a very high risk estimate. But as you go along, you start to broaden your scanning, and you're starting to look a bit harder to try and find new families. And those families won't have as much disease, and so the penetrance figures you get when you study them seem to be lower. So now we kind of look at the whole thing, and we realize, well, some families have very high penetrance. Say 70% is real for some families. For other families, it's much lower, could be 10%. But the difficulty we have is that we cannot predict an individual's risk. So if you come from a family with high penetrance or one from low penetrance, we cannot say for sure that you do or don't have the risk that your family has shown in the past. So it's a really difficult area, and we have to be very cautious about making recommendations about individual risk. So why is this risk of advanced diffuse gastric cancer so variable? Well, two possible areas to look at. One is the number of early lesions is also very variable. So I mentioned before, we've seen as many as 400 in New Zealand. But the odd person doesn't have any at all. Although I suspect if you look really hard in a person's stomach, you probably would find them. But there's huge variation there. And so, of course, it makes sense that if someone has a lot of lesions, they have higher risk. Fewer lesions, less risk. We don't know why there is such variation in the number of lesions between individuals. It could be due to things like inflammation, H. pylori infection, varying states of tissue damage and repair, perhaps heavy metal exposure. We've got some recent data suggesting that cadmium is perhaps a risk factor for increasing the chances of getting these early stage lesions. But but certainly there's great variation there, and that will lead to variation in an individual's likelihood of getting advanced disease. But what's, I think, also really interesting is that there's a great variation in the risk of progression of early lesions. So these T1A, early signet ring cell carcinomas, some sit there indolently, don't go anywhere, others will progress. And we don't know why that is yet. We don't know what controls that variation, but it's clear that other genes are going to be important. So other genes other than CDH1 and CDNA1, like we call them modified genes, modify the risk of those original mutations. And so we don't know what they are yet, as I say, but it's likely that they are involved in things like immune surveillance. So as an early cancer develops, the immune system normally has a job of cruising around trying to find abnormal cells and destroying those abnormal cells. So it's quite possible that in some individuals that immune surveillance is very efficient, very effective, and those cells are destroyed and you don't get, excuse me, advanced cancer developing. But for other people, perhaps they don't have such a strong immune surveillance effect, and those cancers can develop and progress. So we suspect in time we'll find that there are variants and different genes involved in immune function which will modify an individual's risk. But as of now, we still don't know what they are. The other really big question which always comes up with HCGC is what is its true tumor spectrum? So of course it started off being just diffuse gastric cancer, and then it quickly became apparent that there was also lobular breast cancer in these families as well. And so in fact now HCGC now really should be called diffuse gastric and lobular breast cancer syndrome. I tend not to bother just because it's too long. But so if I say HCGC, it's the same as diffuse gastric and lobular breast cancer syndrome. What is pretty clear, though, is that there are no other cancers elevated in HCGC. So there is not any great urgency to screen for other types of cancer. Where it gets a little bit complicated, I think, is that I think it's possible that germline CDH1 mutations may affect the look of or the behavior of some types of sporadic cancer. And so, for example, a pancreatic cancer may be developing a sporadic cancer. Pancreatic cancer may be developing slowly. but if it's combined with a germline CDH1 mutation, that may change its rate of progression, it may change the way it looks. So there's a chance that what are rare cancers could be, their appearance could be altered by the presence of a CDH1 mutation, but I don't think CDH1 is driving the formation of any cancers other than diffuse gastric cancer and lobular breast cancer. Another big question that people will always ask me is, so if E-cadherin is a protein which is expressed in all epithelial tissues, so that's all the most of your internal organs expressing E-cadherin, why do we just see diffuse gastric cancer and lobular breast cancer in families with these mutations? Well, I still don't know the answer to that question, but it's likely to be something like some compensation in other tissues for E-cadherin loss. So E-cadherin is one of a family of fairly similar proteins, and we suspect that in tissues other than gastric and breast, then other cadherins can be turned on to compensate for the loss of E-cadherin. So that's one theory. It could also be due to differences in immune surveillance. So perhaps immune surveillance is not as good in stomach and breast as it is in other tissues. Or it might be something to do with how stable that second copy of CDH1 is. So, I mentioned you've got your one from mum, one from your dad. The second one has to get knocked down or turned off somehow for the disease to develop. So perhaps in some tissues other than gastric and breast, that second copy is more stably expressed. It's stronger and it holds on there and it keeps things normal. These are all things we still have to understand. So to summarize the first few points there, one is that individual risk for advanced EGC is highly variable between families and within families, and we currently cannot predict an individual's risk. Family history does provide some guidance, but you shouldn't rely on it. So if you have a really low family history of diffuse gastric cancer, that makes you think, well, yeah, my risks are probably lower, but you cannot simply rely on that alone. A lot of people also tell me they don't know their family history. They're not in touch with their family. And so I think if you're in doubt what your family history is, I think you should work on a lifetime risk of around about 40% to give you a reasonable estimate of what your risk might be. DGC and lobular breast cancer are the only known cancers with higher risk. And I don't think there's any need for additional surveillance of other organs, but people should be really diligent in following national surveillance guidelines for their care. And then finally, for this first summary, take care of yourself. It's really obvious. Watch your diet, don't smoke, exercise lots. Smoking, vaping, you really shouldn't do either of those things because they're probably gives you a high dose of cadmium, which, as I mentioned earlier, I think we're quite concerned that cadmium may increase risk. So keep away from some of those things and just lead a good, healthy lifestyle. Right. So we think there are around about, I don't know, it's very hard to know for sure now how many HDGC families there are around the world, but we're talking in the thousands now. There's a database called ClinVar where there's 735 different mutations are listed on there. So there's probably at least, I think, 2,000 families around the world with mutations in this gene. Most of these mutations are, in fact, all of them are called truncating, which means they just knock out the function of the gene entirely. So they're not activating the mutation, the gene, they're knocking the gene's function out. There are very few, if any, missense mutations which are pathogenic, and there are no major hotspots. So you can have mutations across the entire gene, and they will still be have the same effect of destroying the function of that gene. There is one really interesting large founder effect, which refers to a very, very old mutation, and it's been seen in Portugal, where initially they saw 4 or 5 families in Portugal who seemed to be unrelated in northern Portugal. They thought they were unrelated. They found they had the same mutation when they sequenced them, their DNA. And it turns out they were able to kind of take it all back and found they had a common ancestor dating back to the 16th century. Who had that mutation that's now spread across large parts of Portugal and also Western Europe as well. And there is very little correlation between, if any correlation, between the location of the mutation, whether it occurs at the start of the gene or the middle of the gene or the end of the gene, and and how the disease is expressed in people. So if you look at your own mutation and it's different to somebody else's, chances are it has no real effect. They're just mutations which knock out the function of the gene. ctNNA1, the second gene involved in HDGC, there's still quite a few mutations reported in ClinVar, but not so many papers have been, families have been described in literature. Only about 15 or 16 that I've seen recently. And so we still don't know nearly as much about ctNNA1 as we do about CDH1-driven cancers. There's a suggestion that the risk of DGC is a little bit lower in ctNNA1 carriers, but it's still really pretty comparable. So for now, I think we just assume that ctNNA1 will mirror the behavior of CDH1. Right, now some really exciting pathology. I know when people love put up the pink slides of pathology, but this is a bit about pathology and a wee bit more about the life history. I touched on it before, but I'll go into a bit more detail on the life history of what we understand about how this disease develops. We think the primary defect in HDGC is what's called impaired cell polarity and spindle orientation. And what that means is, as I mentioned at the start, is that when cells divide, so this is what's called the basement membrane, the cells that the membrane that cells sit on, and here's a couple of cells joined together by E-cadherin. When they normally divide, they divide in that same plane. Okay, so you keep things neatly in a single layer of cells. That's the normal situation. When you lose E-cadherin, or alpha-catenin, so the ctNNA1 protein, those cells no longer hold on to each other. They lose their sense of direction. They don't know which way is up or which way is down. And so when they divide, they will cause cells to go in the wrong direction, either up or down. And that means cells just end up in the wrong place. So here's an example. This is actually from one of our mouse models, but here's an example of that. Here's a normal gland around here, and here is a cell dividing out of the plane. It's going just in the wrong place. And here's another example of that, of those organoid things we heard a little bit before about, and a cross-section through an organoid, and these red cells are cells which have lost E-cadherin expression, and you see they're kind of pushing out of the normal neat plane, the kind of green plane. You see these cells without E-cadherin just pushing into the wrong place. So the key point here is, as I mentioned a moment ago, these early cells which form those signet ring cell carcinomas, the early stage lesions, they're really normal. They aren't aggressive cancer cells as such. They are cells which have just found themselves in the wrong place. And that's why we're pretty confident that many of the early stage cancers that we see are not clinically threatening. This is a really intriguing slide that we came up with a while ago. And let's just go through it. So what this is the number. This is from one of our big Maori families in New Zealand. So they're all related. They all have the same mutation. And they all, and about, I think it's about 15 or 20 of them, they had a total gastrectomy, and we counted the number of early stage lesions in their stomachs across the entire stomach. So you see up, one as high as 500 up there, but most of them below 300, but still lots and lots of these small foci of cancer in their stomachs. And we plotted that against age. And you know what you would expect to see? You would expect to see it going like this, the graph like this, wouldn't you? So, as these cancers develop, you would think they would accumulate, they would stay, and the numbers would increase over time. That's not what you see. It's really flat, almost kind of going down. So it just doesn't make sense. We assumed that if a signet ring cell carcinoma would form, it would stay, it would live, and eventually it might grow. And as more developed, those numbers would increase. And so you would expect with age to get more of these lesions occurring, but you don't see that. And that, to me, suggests that many of these lesions are transient. They come, they grow for a little while, and then they die. And we don't know why that might be, but it might depend on the true cell of origin. Was it from a stem cell? Was it from a progenitor cell? And that might determine whether it lives or dies. But clearly, a number of these early lesions will not last. They will just flourish for a small time and then they'll disappear again. But why it's difficult for us is that the progression to a more aggressive disease is unpredictable. I cannot for sure point to one and say, aha, that's the one which is going to turn nasty, or that one will never turn nasty. But we do know that most of them are indolent initially, and many are transient and will just be lost. But as I say, we got this concern that sometimes they will go from the nice, big fat round signet ring cells to a more aggressive look. So, the cells get really unusual shapes. The nuclei gets a bit strange looking. So we get that more aggressive motile shape, and we just don't really understand what switches it over. It might be, as I mentioned a moment ago, depending on the cell of origin. Is it a true stem cell or progenitor cell, where the stem cells you think would last forever? It could be some kind of signaling from the neighboring stromal cells, the fibroblasts, the muscle. It could be differences in immune surveillance, or it might be just simply suggest the need for additional mutations required to turn it from being an indolent lesion to an aggressive lesion. But as of yet, we haven't found those mutations, although quite a few people do have additional P53 mutations in their more advanced tumors. So perhaps it's one of the genes that does help push it along. So some key points from that section there. A family's exact mutation tells us very little about risk. So they behave roughly all the same. So if you have a mutation different to the person beside you, chances are your disease will behave the same. Most early stage lesions are just normal cells in the wrong place. So they're indolent carcinomas. They are not in themselves threatening. However, there are poorly understood triggers which can make some of them aggressive. So the management of HTGC is, initially it was really just very, very strong recommendation. If you have a CDH1 mutation, have a prophylactic total gastrectomy sometime in your 20s. And if you did not want to do that, then it was recommended that you had surveillance with lots of random biopsies taken. And if an early lesion was found, then you would be recommended to go and have a total gastrectomy. And in some ways, all that was about, if someone had surveillance, it was all about just trying to get some proof of disease so they could justify going ahead to have a gastrectomy. So it was, at that time, we just thought all these early lesions were all aggressive, and therefore, if anyone was found, then that individual should have a total gastrectomy. Today, it's kind of softened quite a lot. So the NCCN guidelines, they say that carriers should be offered either surveillance or gastrectomy, and this decision should be based on multidisciplinary discussion, taking into account patient preference. So, easing back from the just get a gastrectomy. It's the same with the IGCLC guidelines, which they've been making guidelines since 1999. We haven't got the latest guidelines yet. They're still in preparation, but we're pretty sure that what they'll show is, again, more of a balance between gastrectomy and surveillance for people who have the mutations in these genes. And there will be probably a greater emphasis on targeted biopsies rather than random biopsies. So trying to find evidence of lesions which look like they may be more aggressive. So this role for surveillance is going to get, I think, really important, where rather than trying to find any signet ring cell carcinoma, any early stage lesion, we'll be trying to find one which shows evidence of aggressive behavior. We see that a little bit in this slide here. So this is a classic, up here you can see kind of like a pale lesion up here. And when you look at the cancer underneath it, this is a classic signet ring cell carcinoma, not doing very much at all, a classic indolent looking lesion. Down here, we've got a case where on endoscopy, you see a more unusual surface. There's more erosive lesion occurring there. And when you look underneath the cancer, it's one of the more aggressive types. So we're starting to get insight, and this is work being led by the group in the Netherlands, Charlotte van der Post and her colleagues, and they're really starting to get a good insight into how the look of a lesion with an endoscope correlates with the actual disease underneath it all. So that just kind of summarize that, the effort is really very much about trying to see lesions which are going to be really aggressive and do definitely require gastrectomy, whereas others where they may be more indolent and you can perhaps leave people alone for a bit longer. So this is trying to just kind of summarize that. So the balance is changing. So it used to be all about prophylactic gastrectomy. Surveillance of people really weren't very keen. Lots of random biopsies and targeted biopsies, to now where we're moving to a state where, surveillance should, very much be considered by individuals who have a mutation in one of these genes. And the emphasis there will be on targeted biopsies rather than random biopsies. But people, of course, should still consider, and for many, it's the right decision to do, is to go straight for a prophylactic gastrectomy. Just one slide on, I know it's a gastric cancer meeting, but we can't talk about HCGC and ignore breast cancer. So the breast cancer risk is really very well managed by surveillance, although women can opt for a prophylactic mastectomy. And the surveillance consists of clinical breast exam every year, MRI from about 30 years of age, or ultrasound if you haven't got access or don't want to have an MRI, and mammograms from 40 years. So to summarize those points, around decision making, I think for people who have mutations in CDH1, I think it's reasonable that carriers should now consider surveillance as being a reasonable option, but it must be carried out in an expert centre, a centre which is really familiar with HCGC and sees a lot of these people. So they have to be able to get good at recognising the abnormal lesions. If 1 or 2 indolent type early lesions are found on biopsy, it does not justify immediate surgery. So you don't go, Eureka, we've got cancer, off you go to have your stomach out. If the pathology of those early lesions looks indolent, then the people can keep the stomachs for a bit longer if they wish to. They might be best to have more frequent endoscopy, but it is not a reason to go straight to surgery if you find 1 or 2 small indolent lesions. But if those lesions look aggressive, their histology looks aggressive, or there's lots of them, or they're really big, then yeah, go straight and have your stomach removed. A very, very important thing for carriers to think about is their role in the decision-making process. It's so important that people who carry mutations in this gene, are really in charge of making the call whether they have a gastrectomy or not. The decision often comes down to an individual's appetite for risk. So if you have a mutation in CDH1 or CDNA1 and it's really worrying you, you don't feel relaxed in your life. You feel every bit of stomach pain, thinks, oh no, here's a cancer growing now. This is no fun. I don't want to wait. I'm too scared to wait for my next endoscopy. It's just like no good. Well, then if that's how you feel, then you have a gastrectomy without doubt. You just go straight for it. It's the right thing to do. But if you are a little bit more, prone to taking risks, then you go, oh, well, I understand my risks of getting advanced disease are quite low. I'm okay with that. I've told someone the other day, I have a CDH1 carrier in my hometown who's a fireman, and he's still got a stomach. He gets surveillance. And when I explained to him the risks that he was facing by keeping his stomach, he kind of laughed. He said, look, mate, I run into flaming buildings every day. I'm not. I don't care about this slightly elevated risk of diffuse gastric cancer. So it comes down to individuals, but no one is wrong in their decision. If someone wants to have a gastrectomy, that is a great thing to do, and they should go and do it. But if someone wants to try and hold on for a bit longer, perhaps to delay surgery until they've through a certain life stage, then that's absolutely fine too, as long as they're getting the surveillance in an expert centre who does a really good job of that surveillance. Finally, my final note is a note of warning, be cautious. One thing we've seen in New Zealand is, we've been looking at families now for, 30 years, and we're now into a new generation of kids coming through. For when we first found the mutations in the first family, everyone was, running down to have surgery. They'd seen their mother die, they'd seen brothers and sisters die, they had all had dozens of cousins who had died, and so it was all around them, this death from this disease. And so the chance to have a gastrectomy and get on with their life was amazing. They all took it really fast. We've got this new generation now who haven't seen death, or very little death. And so their view on the whole thing is a bit different. Sure, they know the stories. Sure, they get told what they should go and have a gastrectomy, but they can look at it and go, oh, I'm fine, and none of my mates have died, and this is don't quite get it. Well, I do get it, but I don't feel the urgency, and so it's difficult. So we're finding now that the young ones are kind of a bit lackadaisical and not so excited about going to get their stomachs removed, and that's something we have to kind of really work with. We very, very sadly we lost a young man just last week, 35 years of age, who declined to be tested. His mother had a gastrectomy and she was fine, but he had thought, no, I have no interest in this, and he did not get tested, and he developed diffuse gastric cancer and passed away last week. So it can still happen, and I think as we go along and manage families well through surgery and good surveillance, we tend to kind of forget it is dangerous. We have to be careful. We have to be vigilant. So if you do carry a mutation, you just got to make sure you either go for a gastrectomy or make sure you get really good surveillance. Right, so what are we doing in the lab to try and reduce the risk of disease or advanced disease for people? We're trying to develop drugs for the chemoprevention of HDGC, which is the intention to delay or provide an alternative to gastrectomy. And the approach is to try and target weaknesses or vulnerabilities in CDH1 mutant cells, and then to get some drugs to destroy those cells based on what those vulnerabilities might be. So as a tumor, here's a normal gland, here's one with an early stage cancer, the more indolent type, here's a more aggressive one here. What we want to try and do is target these early stage lesions before they have a chance to transition to that more aggressive type. So the question we first ask ourselves is HDGC actually amenable to chemoprevention? Well, we think it is for a number of reasons. One, it's most of these lesions are really small, under a millimeter in diameter. So and they have not much of a stromal barrier, which means there's not lots of other cells sitting there blocking the way for treatments to get in and immune cells to get in there. They don't have what's called a hypoxic core, so the middle, they're so small, the middle of the tumors, they've still got a good supply of oxygen to it all, which means those cells tend to be a bit more responsive to treatment than the cells which have a kind of a hypoxic core to them. They all have the same mutation. There's been no time for other mutations to occur, so they're all really, really similar. It's not a heterogeneous population. And as I mentioned a number of times, they are still, fairly indolent, and so there's low clinical urgency. Initially at least. So what we started off doing was developing various cell lines and preclinical models of cells with CDH1 and cells without CDH1. And we also developed these things called organoids. We heard about those earlier, these little stomachs, which can be used to kind of mimic the disease. And so here's an example. I showed this one earlier on, but this is a cross-section through a gastric organoid from our mouse model. So just think of like a tennis ball just cut in half. The green is the ECAD heron being produced by that normal organoid. And then down here, we've knocked out the CDH1 gene and turned on a red dye at the same time. And what you see is when the ECAD heron is gone, as I showed you earlier, these cells which lost ECAD heron start to kind of go in the wrong direction. They go that way or they go this way, and it's just lost their sense of which way is up and which way is down. So very, very useful model. And we've used these models to do RNAi screens. We've done lots of drug screens. We've done lots of sequencing to try and understand how these two cell types differ. One's with ECAD heron expressed and without ECAD heron. How do they differ? And if they differ, what can we use to kind of target that weakness? And what we saw, and I won't go into too much detail on the slide, but what we saw not only is the CDH1 mutant cells have abnormal cell adhesion, but their organization of the cytoskeleton is abnormal, and they've got really disrupted interactions with the surrounding extracellular matrix. So the stuff that the cells sit in, that is a matrix which signals into the cells quite a lot to tell them how to behave. That interaction between the matrix and the cell itself is really unusual, sending unusual survival signals into the inside of the cell. So we see here quite a few things that we could possibly target. And we also see evidence for altered immune surveillance. So again, we've got a few different ideas of what we can use to attack these early lesions. So very briefly, what we're focusing on three areas. One is a thing called the DDR2 SARC AKT FAC axis. So this is really just a whole pile of genes and proteins which interact with that matrix around the cells. We think those are really, really useful targets to go for. We know that the membrane is around the cell is not well organized in the cadherin negative cells. And so so cholesterol, single lipid synthesis pathways are also useful targets for us. And the immune surveillance is abnormal. So we're currently looking at drugs which are called the immunotherapy type drugs, which help us increase the surveillance of the immune system on these early cells. And we're taking these three different approaches and putting them across our mouse model. So we've developed, it's taken us years to make this mouse model. And what it is a mouse where we can give it a drug to induce the cancer and induce the deletion of CDH1 in those mice, and that will induce the cancer form, so make this cancer start to form. And that gives us a really, really good model for testing drugs to then take on to human clinical trials. I'll give you a couple, a little bit more detail on that mouse. This is a mouse stomach here, and this is the tumor down in the antrum of the stomach, a big gastric cancer there. This is a section through the stomach. The brown color there shows in a normal stomach, lots of E-cadherin and brown there. And when you have knockout of the CDH1 gene, also with p53 sometimes as well, you find loss of E-cadherin in these lesions. Here's one of the tumors developing. It's classic kind of advanced cancer here with lots of fibroblasts produced, lots of collagen produced. So it really does recapitulate human disease really well. So we're very happy that we have a model which is extremely useful for testing drugs on. And it gets cancer, really quite fast. So they get in situ cancers, little, really tiny lesions within 4 weeks. Stage T1 in about 2 months, and stage 3 in 9 months. So it's CDH1 alone. But if we add in an extra p53 mutation, we can get tumors, stage 3 tumors, in 3 months. Now, this sounds a little bit weird to you guys, but it's really important to us because it means we can do experiments in a reasonable time frame. A lot of these mouse models take a long time to develop cancer. You're waiting a year to get cancer. We can get cancer developing in 3 months, so we can test our drugs in fairly short experiments. And when funding is tight for research, that's very, very important. We can get our costs way down, and we get way better data because our model is aggressive. And also, we think by working on an aggressive model, we've got best chance of getting a drug which will be useful in humans. So, key points to summarize that section. We looked at cell line models with and without CDH1 mutations, and we've found a number of vulnerabilities in the CDH1 mutant cells, which you can then target with drugs, either single drugs alone, or we're working on lots of drug combinations too. And we've developed this fancy engineered mouse, which is a really good model for the disease. I'll give you a couple of examples of promising drugs that we're looking at. So these are AKT inhibitors, which both are in clinical use, although we can't get hold of the mirinsertib very easily yet, but certainly capivasertib is in clinical use. So let's look at how it's gone in the mice. So this is mirinsertib. In mice, the cancers were induced for 2 weeks, and then they gave them drug for 4 weeks, and then we looked at their stomachs. What we saw compared to the control mice was about a halving of the number of tumors that were present, of T1A tumors that were present. And when you look at the size of those tumors, they were really, really small tumors compared to the wild type tumors. So clearly this AKT inhibitor, mirinsertib, is doing a really good job at putting the brakes on and killing a lot of these early stage cancers. The second drug, capivasertib, it's the same story, not as impressive figures. It's about a 50%, about a 40% knockdown in number of PT1As, but they are smaller. And so again, this other AKT inhibitor is doing a pretty good job at holding the cancer as well, but although not quite as impressive as this. But it tells us that we're on the right track, that these AKT inhibitors are really useful, and they'll form the basis of many of our proposed treatments in the coming few years. How to test them into humans is a big deal, and so we are very keen to get away from our mice as soon as possible. As soon as we get proof of principle that that a drug is useful in mice, we're going to move on to human studies as soon as we possibly can, funding allowing. And we'll be doing those studies in collaboration with clinicians around the place, but particularly with Jeremy Davis in Baltimore at University of Maryland. But the way to study these cancers is it's really quite difficult to study the effect of chemoprevention because we cannot see these cancers very easily. And so what we're going to have to do is for our first studies are going to have to be ones in the stage 1 trial design where we get people who have a mutation in the CDH1 who wish to have a gastrectomy. They've already made up their minds they want to have their stomachs removed. And we will give them surveillance, and then they have a positive biopsy, then they will go on to get drug treatment for a period of time before they give us their stomachs. So they're destined to have their surgery done, and we will give them drug treatment in a window prior to their surgery. Then we can get their entire stomachs, and we can have a good look at their stomachs under the microscope and see if there are any cancers there. Can we see a sign of those cancer cells dying? Is the drug getting in there? Can we see inhibition on all the right pathways in those samples? So it's a way for us to look at those stomachs and get a sense for how well the drug is working and do that in a very detailed way. And then once we get confidence that our drug is done well in this stage 1 trial, then we move into the more exciting studies where we'll be getting people who intend to try and hold on to their stomachs for longer. And it'll be the same kind of idea. People will receive and will have surveillance, and they'll receive drug, and that will cycle on for as long as we feel confident the drug is doing what it should be doing. But if the person loses interest and it's too difficult, then of course they can move to gastrectomy. So it's a stage development for this shift from lab models into human clinical trials, but we think this is the only way we can do it. Until we find a new way to visualize the tumors, we have to do it in this more conservative manner. One great concern that we've always had with this is that we're going to give people some reasonably serious drugs, and we know that compliance will fall off if we're giving people drugs frequently, which are really hard to take. So we're not doing many people favors if they can hold their stomachs, but they feel awful. So what we want to do is try and deliver drugs straight to the stomach and not systemically through the whole body. And if we do that effectively, then we can really reduce the side effects that people will experience. And the way we've approached that problem is with amazing work from our chemist, Jess Fairhall and Alan Gamble. They've made a stomach delivery system for us, which is a mucoadhesive polymer, kind of like, a bit like Gaviscon. I think it's very similar to Gaviscon. So this is gloopy stuff which sticks to the lining of your stomach. But what Jess has done is she's taken that polymer, which sticks to the stomach lining, and used a acid labile linker to link on our drug of interest. So it might be the AKT inhibitors, which is building at the moment. So what that means is our drug is attached to this sticky stuff which sticks to the stomach lining by a chemical linker which degrades under acid conditions. So in the stomach, the acid will go right out. I can break that linkage, and it will release the drug right on the stomach surface. If the mix, the gloopy mix and the drug passes through to the rest of your GI tract, the drug does not come off the polymer, it stays inactive, and you get way less uptake of drug into other organs. So we've done one look at this with one drug so far, called dasatinib, and we saw about a 70% reduction of drug concentration in organs other than the stomach. So we think we're onto a really good method to give a good dose of drug to the stomach and leaving the other organs with much lower doses. So what we envisage in time will be a kind of the way to care for people with CDH1 mutations through surveillance will be for them to come in annually for their normal endoscopy, and then at the end of that endoscopy and the usual biopsies being taken, we would spray on to the lining of the stomach this mucoadhesive polymer attached to our drug of interest. It might be an AKT inhibitor, and also we've got methylene blue will be attached to that as well, and so will be a visible dye getting sprayed onto the stomach surface. So that's all kind of a normal process to be done. And so what we think we'll be able to get is like a routine where people come in every year, endoscopy, look around, try and find any lesions, take some biopsies. When before the endoscopist pulls out of it, he or she will spray the stomach lining with this drug linked to this gloopy polymer, which will stick to the surface of the stomach, and the drug will be released and kill any remaining early stage lesions. So to summarize those final points and my last points, AKT inhibitors can block tumor development in a really aggressive mouse model of HDGC. Clinical trials are getting really close. I'm going to Baltimore on Sunday to talk to Jeremy Davis from the University of Maryland about getting our first trial started using one of these AKT inhibitors. We're working really hard and have got a proof of principle of this new way to deliver drugs straight to the stomach, so we'll get way fewer drug side effects in time. And we see future surveillance being a combination of routine endoscopy combined with a routine application of this drug to the stomach lining. So finally, just to thank everyone. As you all know, I don't do any work. I sit in my office and worry about things, and these are the people who do all the work in the lab and in our health clinics around the country. The Mario family we worked with from the very start, Maybell and Erin and Pauline Harawera. And of course, I must thank Karen Chalcombe-Scriber. I know many of you knew her, and she is deeply missed, and I personally very much wish she was with us still. So thank you for your attention. I'll be taking questions later, I think. Yeah, thank you.
Thank you, Dr. Guilford. I'd like to introduce our next speaker, Dr. Jeffrey Brown, Assistant Professor in the Division of Gastroenterology, another physician scientist. He's going to talk about these precancerous metaplasias now.
Well, thank you, Ray, the organizers, No Stomach for Cancer, for putting this on. My only gripe is that you put me after a wonderful talk from Parry, our keynote speaker, and you asked me to talk about stuff underneath the microscope that most people in this room haven't looked at since high school when they looked at onion skins and what have you. But either way, I'm going to try my best, and hopefully you can follow along. All right. So no relevant financial disclosures. So unlike Parry's talk, who would focus on diffuse type cancers, the metaplasias that I'll discuss on that evolve as a precursor to cancer really fall more in this intestinal type of gastric cancer. And the reason is because intestinal type is much more closely correlated with H. pylori, which causes a very prolonged period of chronic inflammation over the course of decades that allows these lesions to evolve. And the sequence of events, Jose had briefly talked about this, is something called the Correa cascade. So this is what a normal stomach looks like. I won't get into all the details of it. But once you get infected, the initial stages, you get a chronic gastritis, which itis just means inflammation. So you get an invasion of a lot of immune systems immune cells that just cause inflammation. But if this continues over a long period of time, then the stomach will eventually atrophy. And atrophy, just like as muscles atrophy or anything else, is a loss of certain things. In the stomach, this is generally seen by loss of the acid-secreting parietal cells. And generally, this over here is a pretty reversible process. There's some question whether gastric atrophy can truly go back to normal. But if you treat H. pylori, get rid of the bug, you can probably go back to normal stomach here. At this point, though, if the inflammation in some people continues, then you actually change the stomach and you go into an intestinal metaplasia. And I'll explain exactly what metaplasia is, but it's similar to what Parry had said. It's normal cells in the wrong place. And this is a precursor lesion that is important because as I'll try to argue at the end, there's certain types of these metaplasias that have an exceedingly high risk to progress to cancer. And if we can identify those people, then we identify the people that we should probably survey. And there are certain types of intestinal metaplasia that are pretty benign that have a lower risk. So I'll stop here with most of my stuff. I'll just say that this is the precursor lesion to dysplasia and eventually cancer, which hopefully we can identify people here so we can identify these at an early stage when they're curable, not when it's too late. So what is metaplasia? So this is definition of metaplasia. It's a change in which a mature cell type traditionally found in an organ is replaced by a mature normally or cell type normally found somewhere else. And I underline mature and normally because this is what discriminates it from dysplasia and cancer. Because people don't normally have cancer elsewhere in the body. You can have these other intestinal-like cells elsewhere in the body, and then they move to the stomach. And that's what really metaplasia is. So I'll point out this later, but you can see all these little round cells, these little goblet cells, these mucus secreting cells. These are normally found in the intestine and don't have any business being in the stomach or in the esophagus and Barrett's esophagus. This is what they call with metaplasia. And metaplasia is not just seen in the stomach. This is seen in a lot of other things. If someone chronically smokes, you can have metaplasias of the lungs. I think the easiest one that we can see is metaplasia of the esophagus. This is with chronic acid and likely bile acid reflux because the change is so dramatic. So usually you have a squamous epithelium, which is what covers your skin. And then this changes to a more columnar thing, which lines the GI tract or your lips or anus and that kind of stuff. But you can see the dramatic change. So this is metaplasia. This is what it's supposed to look like. Similarly, this gets cell types that are typically found in the intestine, goblet cells, and the mucus secreting cells. Well, the same thing happens in the stomach here. And the reason why I really like this slide is that this shows that all metaplasias aren't the same. This is what a normal stomach looks like on a biopsy. This is a type of metaplasia that looks more homogeneous. It still has little goblet cells and stuff, but is different from this set of metaplasia, which this I'll show at the end is more of the high risk thing. And just to put this in order, here's inflammation. Over here was a gastric cancer. So these are probably a precursor lesion over to that. So just to kind of go into, not all metaplasias are the same. And this is important because this, I think we should figure out, if we can diagnose this, we can tell who needs to be surveyed and who probably can be exited from surveillance. So this is a very complicated slide. I'll go through it very slowly, but I'll just, this essentially shows that there are 3 types of metaplasia. Complete, which is the low risk type. Then it switches to incomplete, which is a much higher risk. So I'll kind of go over the features of these and I'll show pictures and I'll explain it very carefully. I think you'll get it by the end. So complete, you generally have organized glands. They're nice, linear, they look calm, they're not wild appearing. The goblet cells all look the same. These are the mucus secreting cells that actually, I'll show that are the big feature of intestinal metaplasia. They shouldn't be in the stomach normally. And then you have the absorptive cells that have a nice brush border. This is what absorbs all the nutrients in the small bowel. And then you have some Panna cells, which are bottom of the crypts. But these are all features of the small bowel. So the small bowel is a very low risk for ever developing cancer. We don't offer surveillance to look at the small bowel, the region between the stomach and the colon. However, everybody in the United States, everybody over the age of 45 gets offered a colonoscopy. The reason is colons develop cancer. And just the same as here, this incomplete type metaplasia mimics the colon. It has goblet cells of variable size. The absorptive cells start getting these mucins in it that they shouldn't have. And there's very few Panna cells. So essentially, this is the low risk type. Looks like the small bowel, and just like the small bowel doesn't get cancer very often, this confers about a 4 times increased risk and looks like the colon. The problem is discriminating between these 2 types because they look the same with normal stains. You actually need special stains to figure out if they have type 2 or the very high risk type 3 things. And to do this, you actually have to look at the type of mucins they make. So type 2 is characterized by sialic acid. This is a sugar that's got an acidic group on it. And then that acidic sugar switches to a sulfate, which is what confers the highest risk here. And I'll show you that this is a common feature of all foregut metaplasias, that the switch to a sulfation is actually an incredibly important thing and puts you at much higher risk to develop cancer. So what does this actually look like? So this is the low risk type. This is the one that looks like the small bowel. You have a lot of homogeneous blue cells here. So blue is staining mucins that are sialic acid, essentially. So you see all these are this, but you see the other cells in between them don't have any of these mucins. This is what changes in incomplete metaplasia, where you see all these cells around you. You still have these little round goblet cells, the mucus ones, but all the other cells start to express these mucins. This is type 2, this is intermediate risk. What the switch is to high risk is when you start expressing sulfation, which is done by this brown dye here, high iron diamine, which binds sulfate. But you can see that the blue is largely switched to this brown pigment here. This is the highest risk. And this is not just in the stomach that changes its risk. Throughout the esophagus, stomach, and pancreas, we have found that this switch is what really makes the highest risk to develop cancer. And this is the population we need to identify so that we survey them and hopefully catch cancer at a very early stage when it's curable. And so the one problem is we no longer actually have a way to identify this. Because diamine is incredibly toxic. It has been taken out of all commercial laboratories. So right now we can say whether it looks like the small bowel or whether it looks like the colon, which is higher risk, but we can't say whether they have the last step right before dysplasia in cancer. So we, in my lab and also in collaboration with Kaushik Das, we have an antibody that actually we believe now can do this. And that's obviously a non-toxic solution. And I'll show you that it's not, pretty much all these foregut metaplasias express this right before they develop cancer, essentially. Barrett's esophagus is 95% sensitive and specific. Pancreatic, whether it's a cyst or that, it's incredibly sensitive right at the highest grade things. The one thing is this antibody, before we knew what it bound, it didn't look like it worked very well in the stomach. But the reason is now that we know that it exclusively binds sulfate and will not bind sialic acid, we're now testing whether this 35% here, the 65% we missed is because that was type 2 and not type 3, not the high risk. This should only detect the high risks metaplasias. So the reason I bring this up is that if you look at this esophagus, stomach, and pancreas, if you have these sulfated mucins expressed, we survey all these people every 2 years. That way we can find when they get high-grade dysplasia and ablate them. Pancreas, we've actually run a phase 2 multi-center clinical trial showing that if you express these sulfated mucins, you should just have your pancreas taken out. You have essentially either carcinoma in situ, which is cancer that hasn't spread yet, or you have high-grade dysplasia. However, stomachs, we just sit on this because A, we don't have a commercially available test because diamine's toxic has been taken out of the all commercial laboratories. And B, I don't think surveillance, we don't do as much as we really should be because there's a lot of reasons, but I think we can do better. And the other thing is I'm not showing something profoundly brand new. Here's an immunofluorescence from 1968 showing the expression of sulfated mucins right next to gastric cancer. It's just that this has been largely ignored. It's in the guidelines as, what the highest risk, but we don't test for it. We have no way to test for it commercially. So hopefully this is part of our PREVENT trial. One of the aims is actually pretty much validating that DOS1 antibody is a non-toxic alternative to identify the highest risk people that should be surveyed to find gastric cancer at a time where it's curable and not when it's too late. Versus now, in the pathologists will say there's metaplasia, but there's nothing we can do because insurance companies won't fund surveillance or anything like that. But if we can say this is not just metaplasia, this is type 3 intestinal metaplasia, the one that is the highest risk. Hopefully we can get those people screened or surveyed. And the other thing is we also might now have treatments. So Jim Goldenring's lab, this was just published like a month or two ago, used a MEK inhibitor and is actually able to downgrade the histological grade of intestinal metaplasia. Because I said before at the beginning that once it gets metaplasia, you have replaced normal stomach cells with cells that have no business being there that should be in the intestine. This is kind of generally believed to be a permanent transformation. With this, they've actually been able to downgrade this histology and get rid of some of the metaplasia. So potentially, the ones with the highest risk, this is a phase 1 trial. They haven't correlated this with patient outcomes or anything. They've just shown that under the microscope, these stomachs look better with just 2 weeks of MEK inhibitor. And that's pretty much what I got here. I'd like to thank my lab who do everything, Shabo, Shwimi, and Gabe, collaborators, Kaushik Das, who brought this original antibody to me, and I do all my translational work with him. Kay Lee, who's a pathologist that I work with. She's at Hopkins now, moving to SLU pretty soon, and she is what I'm trying to validate the antibody and high iron diamine with, and funding. And thank you all for your attention.
So now I'd like to introduce our last and final speaker of the session, Dr. Vladimir Kushner. He is professor of medicine, division of gastroenterology. He is director of gastric endoscopy, interventional endoscopy, and the interventional endoscopy fellowship program. So please welcome Dr. Kushner.
Thank you, and thanks for having me. So this is going to be a complete 180. Number one, we're going to talk, this is going to be a very clinically oriented talk. And number two, we're really going to be talking mainly about the esophagus and specifically Barrett's esophagus. And I think a lot of the concepts that Dr. Brown introduced as far as intestinal metaplasia and progression of that to dysplasia and cancer apply here as well. So we'll talk about the basics of Barrett's esophagus, then discuss what endoscopic therapy options we have today, and some of these do apply to early gastric cancer as well. And then we'll talk about who to treat and when. So basics of Barrett's. So Barrett's is intestinal metaplasia of the esophagus. So just like in the stomach, when you have something chronically irritating the esophagus, you can trigger molecular pathways that make the lining change from squamous mucosa, which is basically just like your skin, to columnar mucosa, which looks like the small intestine and has goblet cells, which are these little mucus-producing cells, which in somebody who has chronic reflux can actually be protective and decrease the risk of them getting esophagitis, strictures, and other complications. So if you live to the age of 40, Barrett's esophagus may be a helpful adaptive mechanism. If you live to the age of 70, though, accumulation of that intestinal metaplasia being exposed to gastric acid and other toxins can progress to esophageal cancer. So why should we care or treat Barrett's esophagus? Well, about up to 7% of the US population is affected by Barrett's. This has increased recently because of increase in processed food, increase in obesity and reflux. And we know that Barrett's is really the only precursor to esophageal adenocarcinoma and increases the risk 30 to 40-fold over the general population. And we also know that if we get rid of it before it turns to cancer, we can prevent esophageal cancer. So that's a total win. And unlike gastric cancer, esophageal cancer has been going up very rapidly, especially adenocarcinoma over the past several decades. Again, the hypothesis is that it's largely driven by the obesity epidemic, as well as consumption of processed foods and just changes in lifestyle. So esophageal cancer is a major problem, and unfortunately, despite advancements in chemotherapy and surgery, we really haven't budged survival much. So how do we find Barrett's esophagus? Well, in 2025, still the way to screen for Barrett's esophagus is doing an endoscopy, obviously resource intensive, and not everyone can have one. But when we do an endoscopy, Barrett's esophagus looks like this. So it's this, does the pointer work? So it's this pink, this is the top bottom of the stomach. So you can see the folds that you saw in all the pictures earlier. This is the esophageal lining, that tissue that's basically like the skin on your hand. And this is Barrett's. So it looks like these pink salmon colored tongues coming up into the esophagus. So this is that intestinal metaplasia. So this is what we look for, and this is how we know there's Barrett's esophagus. How do we figure out if it's bad Barrett's or benign Barrett's? We take biopsies. The traditional protocol is we just take a lot of pinch biopsies throughout, and the more you look and the more biopsies you take, the more likely you are to find dysplasia. And again, more likely you are to find something you can treat and to prevent cancer. These are the things that you can find on biopsies. So just for reference, this is what the normal esophagus looks like. This is Barrett's. So again, you see that intestinal metaplasia. You can see a very different structure of the cells here. You can see these little goblet cells. That's what really defines intestinal metaplasia in the esophagus. And then it can start going toward dysplasia. So this is low-grade dysplasia, maybe something to worry about. These cells are starting to look a little irregular. You can see here dark, kind of these there's more purple. Generally on biopsies, the more purple you see, the worse it is. And here you see a little more purple, but low-grade dysplasia can also be seen in inflammation in the esophagus and not diagnostic of something that will progress to cancer. Then you have high-grade dysplasia, which is basically, which in Asia, for example, is referred to as carcinoma in situ. This is cells growing out of control, glands forming where they shouldn't, but they're limited to the superficial lining of the esophagus. So high-grade dysplasia, if we can just get rid of the top lining of the esophagus that faces the food, we can treat it and prevent cancer. And finally, you get invasive adenocarcinoma, again, irregular growth of glands where they shouldn't be. So what is the risk of Barrett's progressing to esophageal cancer? Well, the good news is non-dysplastic Barrett's, which is what about 90% of the people with Barrett's esophagus are diagnosed with, has less than 0.5% per year chance of progressing to cancer. Nobody would really argue that we need to treat that because frankly, your chance of dying in a car accident is probably about equal to that. Low-grade dysplasia is a more controversial area. Studies are kind of all over the place still. The risk of progression is anywhere from 0.5% to 7% per year to high-grade dysplasia or cancer. And finally, high-grade dysplasia, there's really no argument about treating. The risk of progressing to esophageal adenocarcinoma is at least 6% per year. So in somebody who is at all fit, it's something that should be treated with ablation. So what can we do with medical management to prevent Barrett's from progressing to cancer? Well, anti-reflux surgery is great for treating symptoms, but doing a surgery to treat reflux does not decrease your risk of esophageal cancer. Medications may help. So aspirin and other nonsteroidal anti-inflammatory medications may slightly decrease the risk of progression to esophageal adenocarcinoma in someone with Barrett's. But they're not currently recommended solely for esophageal cancer prevention because of the risk of complications. And finally, esomeprazole. So proton pump inhibitors are very effective at decreasing the risk of progression to esophageal adenocarcinoma and very safe medication. So anyone with Barrett's esophagus really should be on a proton pump inhibitor because that decreases the exposure to gastric juice and acid and decreases the risk of the Barrett's progressing to cancer. So how can we treat it? Well, again, Barrett's is a mucosal disease. It affects just the surface lining of the esophagus. So it's perfect for us doing something with a flexible endoscope. So it only goes 1 to 4 millimeters in depth and is not found below the muscularis mucosa. So it's in just the very, very lining of the esophagus. So we can treat it just like we treat a colon polyp by removing it. Except Barrett's usually is flat and involves a larger area. So cutting it all out is not practical and frankly, fairly risky. So what do we do to treat it? What else can we treat? So we can also treat early esophageal cancer. So we know that the risk of lymph node metastasis in esophageal cancer that's just limited to the superficial lining is basically 0. It's less than 2% if it's limited to kind of the top, if it doesn't go into the submucosa. But once it gets into the submucosa, so past the superficial lining of the esophagus into toward the lymphatic vessels, the risk is greater than 20%. So we can treat early esophageal cancer endoscopically. This also applies to early gastric cancer. We can treat early gastric cancer that hasn't gotten below this muscularis mucosa level. We can treat that endoscopically and avoid surgery in a lot of patients. So to remove Barrett's with larger areas that don't have any nodules or nothing that looks too worrisome, we can basically burn it off. And if it heals in a non-acid environment, it reverts back to normal lining. The standard approach that we use here is radiofrequency ablation. It's a balloon or a catheter. You can see here this electrical coil on it. It inflates and you apply an electrical current to the esophagus and you remove the bad tissue. And then once it heals, it basically turns back to a normal esophagus. So this is what the procedure looks like. You have an endoscopy. We place this catheter in, inflate it, burn the esophagus. Most people have some chest pain because burning your esophagus is not going to feel like a bed of roses after. And then it goes from looking like this, so you can see very extensive Barrett's esophagus, to normal esophageal lining. This procedure was evaluated now 15 years ago in a very large multi-center randomized controlled trial, so the highest level of evidence that we have, and definitively proved that ablating the Barrett's, number one, you can get rid of it with endoscopic therapy, but more importantly, you can dramatically decrease the risk of progression. So you can see for high-grade dysplasia in the study over 2 years, 19% of patients progressed to cancer versus just 2.4% of the patients who were treated with radiofrequency ablation. So very effective treatment to decrease risk of cancer in patients with dysplastic Barrett's. Overall, very safe. Most patients have chest pain after, but strictures, so scar tissue in the esophagus that makes it hard to swallow, are the most common complication, happening in about 6%. More serious complications like bleeding and chest pain requiring hospitalization can happen, but are exceedingly rare. Now, treating Barrett's can be challenging because like anything, it's not everything's created equal. So patients with a lot of Barrett's, so more than 3 centimeters, typically very difficult to treat endoscopically. We just have to burn it over and over and over again to get it all to go away. So it requires more ablation and obviously more burdensome for the patient. More importantly, these patients who have masses or nodules in the esophagus. So these are always, you have to make sure that this is not cancer. You can't just burn over this. You have to remove it and send it to a pathologist to make sure that it's not growing too deep. So you have to inspect the esophagus very carefully. And if you find something like this, you have to resect it. And I'll go over the endoscopic resection techniques in a second here. And then you can ablate the rest of the Barrett's esophagus. So how do we resect it? Well, the most common technique is something called endoscopic mucosal resection. Basically, we try and do what we do during a colonoscopy and remove these nodules with a loop snare. Today, we mainly do it by deploying a rubber band. So you can think of kind of how they tie off an extra finger when a baby's born with it, or how they sterilize animals on a farm. You put a rubber band around it, and then it makes it a polyp, and then you can chop it off with a loop snare. So this is what it looks like in a video. So you can see here a patient with Barrett's. And we're going to come up on, and there's a nodule right there. So you can see the subtle raised area that's worrisome for a little bit of cancer. And then we deploy a rubber band. And you can see the loop snare coming out here. And you can see resected here. And you basically go, the other technique is you can lift it with a little bit of blue water. And again, remove the tissue with a loop snare. And you can see here resecting a very large area of normal esophageal tissue, getting some more there. And this allows us to send the tissue for a pathologic examination to make sure it's not growing into the submucosa, make sure we're appropriately risk stratifying the patient so that if they do have invasive disease, they go for surgery or chemotherapy and radiation. The other technique that we use, and this is used in gastric cancer as well, is endoscopic submucosal dissection. So this is a more complex method where we actually peel the polyp or the mass off of the lining of the stomach. Again, what we do is we lift it with a little bit of salt water and then use an endoscopic knife to cut the tissue off. And this allows us to remove larger pieces of tissue than what you can put a rubber band around. So you can take 3, 4, 5 centimeters tumors off with this technique. This is an example of doing this with an esophageal squamous cell cancer. So you can see here, there's mass in the esophagus. We mark it out with electrocautery, and then you can see lifting it with a little bit of blue water. And then using the electrosurgical knife to basically cut it, peel it off. Kind of the way I describe it to patients is it's like we're peeling an orange. We're taking the peel off of the orange and leaving everything underneath. So you can see here dissecting. This is a submucosal tissue, connective tissue. And the goal is obviously to stay away from the muscle layer and not go all the way through the wall of the esophagus or the stomach. And now you can see here, there's the final product. So both of these techniques are usually combined with ablation for Barrett's esophagus because you need to get rid of all the Barrett's. These techniques, the main differences are, number one, EMR is much easier than ESD and takes a lot less time. But with ESD, you can get en bloc resection, so removing the whole tumor in one piece 90% of the time. And you can get an R0 resection, meaning clean margins, over 70% of the time. Complication rates with ESD are a bit higher because it's a longer, more complex procedure, but overall both very safe and much safer than surgery, as we'll see in a minute. Other things that you can do for dysplastic Barrett's is freeze it. So similar to what dermatologists do for skin cancer or OBGYNs do for early cervical cancer. We have several techniques for actually freezing Barrett's esophagus. One of them is a cryo balloon. So it's a little balloon that you inflate in the esophagus, and you can see a little bit of Barrett's right there. And we freeze it with nitrous oxide. So similar to what you do to a wart. And this leads to, again, the tissue sloughing off and getting replaced with normal esophageal lining. And this actually compares pretty well to radiofrequency ablation. The other technique that we can use for treating Barrett's, but also for palliating esophageal cancer, is spray cryotherapy. So this is a different way of delivering cold. So this is liquid nitrogen. And this is actually sprayed through the scope. So this gets very cold. The endoscope actually freezes as you do this. And this can penetrate very deeply. So we use it sometimes for esophageal cancers in patients who can't swallow to debulk it once they've exhausted their options with radiation. And spray cryotherapy works pretty well. It palliates patients with esophageal cancer and allows a lot of them to avoid a stent or avoid a feeding tube for quite some time. So how are the long-term outcomes with endoscopic treatment for Barrett's? Well, in short, very good. About 90–95% of patients remain in remission years later, but the Barrett's can come back. So the rate of recurrent high-grade dysplasia or cancer after we endoscopically eradicate the Barrett's is about 5%. So that means these patients are coming for annual endoscopies kind of as long as they're healthy enough to have a scope. So last part of my talk is who do we treat and when? So again, we go back to the slide of kind of the risk of cancer progression. Low-grade dysplasia is the controversial area, and that's because inflammation can look like low-grade dysplasia. So 85% of patients who are initially diagnosed with low-grade dysplasia on a biopsy are reverted to non-dysplastic Barrett's and have a very low risk of progression. But those, when an expert pathologist looks at it again, says, yes, there's low-grade dysplasia, are at high risk for progression and should be treated. And here, kind of similar data, so you can see ablation of low-grade dysplasia that's confirmed leads to 11% absolute reduction in progression to high-grade dysplasia or cancer. The other more interesting area, and the area that makes me lose sleep at night, is what to do with early esophageal cancer that invades the submucosa. So we know that esophageal cancer, and this applies to gastric cancer as well, once it gets deeply into the submucosa, so toward the muscle layer of the GI tract, the risk of it spreading to lymph nodes goes up significantly, 25% or more. And we also know that poorly differentiated tumors, larger tumors, and deeper submucosal invasion increase that risk. However, we also know that superficial submucosal invasion probably has a very low risk of lymph node metastasis. So this is where getting an en bloc resection with ESD is very important, and very careful pathologic examination is important when we're seeing these patients, because nobody wants to have their stomach removed and even worse than that, have your esophagus removed, because both of those are very morbid operations. And if we can save even a few patients from having that surgery with endoscopic therapy, it is very beneficial. So this is why ESD is really going to be becoming more and more of the technique for removing these early lesions. And just comparing outcomes to surgery for esophageal cancer. So for T1A, this is limited to the very superficial lining of the esophagus. You can see endoscopic therapy is much fewer complications, equal survival, much shorter hospital stay, if at all. A lot of these patients can have an outpatient procedure. For T1B esophageal cancer, so again, the data that we have is that endoscopic resection is actually pretty close to esophagectomy for outcomes. Now, these are very carefully selected patients, but surgery for deeply invasive esophageal cancer doesn't have the best outcomes in times, because these patients tend to recur because of the anatomic location of the esophagus. So endoscopic therapy for early esophageal cancer and early gastric cancer is something that we're definitely doing more and more of, and I think is going to grow into the future, and makes early detection that was talked about earlier in the prior talks very important, because if we can detect these things early, we can either prevent them or resect them endoscopically and avoid morbid surgeries like gastrectomy or esophagectomy. Thank you.
So would all the speakers from the first session be able to stick around, come up front, and we can take maybe 15–20 minutes of questions, or is that okay? Okay, so I'll ask the first question, and this goes to everyone. So as our screening techniques kind of improve for other GI cancers, like I'll just colon cancer as an example, we're doing more sophisticated, I guess, blood tests, trying to detect circulating tumor cells, circulating tumor DNA. what progress have we made in, kind of these new technologies in upper GI cancers, and especially for these, hereditary diffuse, they tend to be kind of, I guess, freely moving. So, maybe not just in the blood, gastric juices. Can you guys speak on that?
I can start on the
Oh,
esophagus.
okay, go ahead.
So
Glad.
esophageal cancer, so screening uptake has still not been that high because for esophageal cancer screening, for Barrett's, you kind of have to have an upper endoscopy. That's been the paradigm up until now. However, today we do have several technologies that are now FDA approved and rolling out, which are actually little capsules that are attached to a string that you swallow and then get dragged back out, and you look for either methylation signatures or basically cytologic markers of Barrett's esophagus and esophageal cancer. And this is something that is much lower cost than endoscopy and also can be done in a primary care doctor's office or on a screening van like we do for prostate cancer or breast cancer screening. So potentially it's going to really broaden the number of patients we can, in a cost-effective way, screen for Barrett's and by inference esophageal cancer. That's something that, is here now, although not widely adopted.
For HDGC, really no progress in that area. I think the lesions are too small for circulating tumor DNA to be effective. There is some interest in that approach and trying to sample those directly, but it's multifocal disease. It's really tough to do that thoroughly. So unfortunately, for now, we haven't really got progress with that approach.
I'll just say, I'm not aware of much progress on the side of stomach cancer related, not related to hereditary. But what I would say is that H. pylori screening is something that I think is still poorly done. We do a very bad job of screening for it as gastroenterologists. It's almost embarrassing. And we do a very bad job of making sure that when we do treat it, that it's been eradicated. There have been multiple studies showing that actually primary care physicians do a better job of managing or detecting eradication than gastroenterologists. And so I think it's just to quote David Graham, who was sort of the guru of H. pylori and is at Baylor. He often said that the problem with H. pylori is that we treat it as a gastric disease, not as an infectious disease. And as a result, gastroenterologists managed it and not infectious disease doctors. So I think we probably need to do a better job of screening and getting rid of it when we do detect it.
Yeah, I'll just make a comment. Well, I'll talk about it. But yeah, so like I said in my last slide, is that at least the stuff I'm studying involving these sulfate abuses, this is not something new. I think it's just a consequence of just not having adequate funding for gastric cancer awareness and just, I'm pursuing something that was known in 1968. I just have an easier way to detect it now and a way we can make it high throughput in any histological lab to do it. It's just that I think the funding is holding us back, or we don't have as much awareness about everything as the stuff we do. We know what to do and just need to do it. So
There's a Zoom question, so we'll pull it up on the screen and you guys can we'll just have you guys answer that. I'll read it once we get it put up on the screen here. Sorry, I guess you can unmute yourself. Volume, no volume. You want to just type it real quick? Sorry. DJ, can we see the chat as well? Is that okay? I don't think. So yeah, sorry. I guess please just type into the chat message, and Dr. Guilford is just I'll read it, or, I mean, everybody can see it, so.
Okay, question about potential gene therapy. I look forward to hearing, Gavin, what that might be. I mean, obviously, gene therapy is the way to ultimately make this problem go away with HTGC. As far as I'm aware, it's still in its infancy, and so nothing is really even close. But I'd love to hear what Gavin's been doing in that area. So I'll look forward to your email, Gavin.
So I guess oh. Dr. Caffrey.
Forensic surgeon at the University of Missouri, we have that. Thank you. Okay, go for my question is for you. You elaborated very well on the discussion with patients on gastrectomies and on shock that is, like, I can imagine. How do you find it invasive cancer sending data on the prophylactic gastrectomies on the specimens? I mean, how many patients get upstage basically?
Very, very rarely. Very, very rarely. People have prophylactic gastrectomy. I mean, it's almost unheard of if they have their surgery in their 20s. Very, very rarely is upstaged.
Thank you.
Thanks for all these nice talks. Dr. Guilford, I had a question for you. With the local therapy that you're talking about, the techniques that you show wouldn't differentiate between the drug that binds to the surface of the cells and the drug that gets into the tissue. Do you know how deep the drug has to get? Do you know that your drug can be absorbed superficially and that you could tell that difference?
Yeah, we don't need to get deep. It's only a matter of a few millimeters. And we've looked with one drug so far, and that was a drug called Siteman, and that did get down to where we would need it to get to. So I guess it will vary from drug to drug, but certainly if the drugs have the right charge structure, then they do get into the stomach and can diffuse into the right depth. So there's some, I can't give you the details of the charge structure, but our chemists are very careful with which drugs they consider to be ones which are amenable to this approach.
But if they do get absorbed, then what doesn't get absorbed in the stomach, because the residence time in the stomach will be relatively short, then it's going to be absorbed in the small bowel. And
no, but it won't. I mean, most drug will be taken, will be released over a period of hours into the stomach surface. But any drug which remains bound to the mucin and goes into the bowel is inactive. So the drug is inactive while it's still bound to the mucin, to the mucoadhesive compound.
Everything that gets acid released will stay in the stomach.
Oh, no, I mean, some will go, but I think we'll be able to tune that process a little bit by we can tune the rate of release of drug from the mucoadhesive polymer that can be tuned, and so it can come off over whatever number of hours we want it to happen to reduce the likelihood of it just being released into the stomach as a whole and lost into the bowel. So we won't get perfect uptake only in the stomach, but the one experiment we've done so far in a mouse study was we had a 70% reduction in dasatinib and other organs compared to the stomach. Yeah, exactly, yeah.
Okay, I think we'll close out the first session. So let's give the speakers a round of applause. We'll take a 10-minute coffee break and be back here. Thank you.
Zoom audio check. 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 Zoom audio check.
Testing, testing.
acid that, you know, irritate. Yeah. I mean, Oh.
So, so I think we'll go ahead and get started in the interest of time, and as people trickle in, that's fine. There was just a change in the schedule. So Dr. Panny got stuck in surgery. So we're going to go ahead and move forward with Ray Jin. And so Ray Jin, obviously you all know him and he helped organize this. I was just going to briefly introduce him because I've known Ray for quite some time. So Ray did his MD PhD training here at WashU. And then as he mentioned earlier, we were postdocs together. Ray's in the division of gastroenterology and oncology. He's a practicing clinical oncologist who really manages patients with esophageal and gastric cancer as his main focus. So today, Ray is going to be talking about some systemic treatments for gastroesophageal cancers. So please join me in welcoming Raymond Jin.
Thank you so much. So, yeah, as Jose said, I'm Raymond Jin. I'm a upper GI oncologist here at Siteman. We heard Dr. Kushner talk about some of these endoscopic treatments. We're going to hear Dr. Brand and Dr. Pani talk about surgical treatments. And then Dr. Vlasic, he'll talk about radiation treatments coming up. But I wanted to talk about systemic treatments for gastroesophageal cancers. So systemic treatments are what oncologists like me administer. These are usually IV medications, but can be pills. They kind of get absorbed and really penetrate your entire body and attack cancer wherever it is. So I am an upper GI oncologist. I treat esophageal cancers, gastric cancers, but also everything in between these GEJ adenocarcinomas. And from my perspective, in terms of treatment, there are two basic groups. No problem. Two basic groups here that the first group is patients that we're intending to cure. These are not stage 4 patients. These are earlier stage patients. And then patients that are stage 4 that we can't cure, we kind of treat them palliatively. And that means we're trying to improve their quality of life and quantity of life. In 2025, there's a lot of diseases we can't cure. I tell all my patients this, like type 2 diabetes, high blood pressure. We manage it and we kind of deal with it as a chronic disease. So in terms of both of these baskets, there's basically been essentially practice changing advancements in the last year or two. And there are 4 big studies that I would like to really talk you guys through. And hopefully, as we continue the symposium every year, we can update this, but this is the 2025 update. So the first study, and these studies are kind of acronyms, if you will, but they don't really stand for anything, unfortunately. But the first study is called ESOPEC, and it applies to esophageal cancers, specifically esophageal adenocarcinomas. And the actual study was published in basically the premier journal for us physicians called the New England Journal of Medicine. It was published in January of 2025. And this is the title, Perioperative Chemotherapy or Preoperative Chemoradiotherapy for Esophageal Cancers. And what it sought to do, this is what we call a study schema. So it sought to really compare the old standard of care, which we call CROSS, and that is really chemo and radiation. So this is 41.4 gray of radiation combined with chemotherapy called paclitaxel carboplatin, given once a week, 5 weeks. And then 4 to 5 weeks afterwards, these patients proceed to surgery. So that was the old standard of care. So with the study, randomized patients to that or what they're testing, which is this new chemotherapy regimen. It's called FLOT. That is an acronym. It does stand for something. It stands for 5-FU, oxaliplatin, docetaxel. It's given as a 2-week cycle. So 4 cycles equals 8 weeks. You get 4 of those. You wait the same 4 to 6 weeks. You proceed to surgery. And then after surgery, you get 4 more cycles. So this is what we call a perioperative chemotherapy approach. So they're looked at many outcomes. And one of the first outcomes that I like to point out is this outcome. So this is a pretty busy table, but let's just focus on this red box. It's called pathologic complete response. And what that means is after surgery, when the surgeons take out all the cancer and the lymph nodes, they looked for what we call viable tumor. So if there is no viable tumor, that's what we call a complete pathologic response. That is the best that we can hope for. So patients who underwent that perioperative chemotherapy, 16.7% of them had no evidence of cancer at the time of surgery. So you can almost think that those patients didn't really need surgery. Compare that with the old standard of care CROSS for esophageal adenocarcinomas, pass CR rates about 10%. Okay. So now let's look at some other survival metrics. And as physicians, we like to look at these metrics in what we call, these are Kaplan-Meier survival curves. So the patients, we start off with 100% of patients that are randomized to the FLOT or that cross regimen, about 220 in each group. And then over time, as an event happens, and I'll talk what those mean, this curve falls, okay? So this top curve here, the event that we're looking at is death, and we call this overall survival. And you can see that the FLOT curve in red is atop that blue curve, which is that pre-op chemoradiotherapy or cross. If we look at not death as in the end event, but recurrence of that cancer, that's this graph down here. That's what we call progression-free survival. And it looks very similar. Basically, that flat curve in red is atop that blue chemoradiotherapy curve. So these are our kind of definitive, I won't show the statistics here, but this is definitive, relative definitive evidence that perioperative FLOT may be superior to chemoradiotherapy. We're going to have a discussion afterwards with our surgeons and our radiation oncologists about whether this is what it is, and we'll talk about more about that, the details. So that's so I can't say it's definitive. That's not the right word. But so ESOPEC kind of established, I think that's a better word, perioperative FLOT as a possible gold standard to treat esophageal cancers. Now, this perioperative FLOT has already been used gastroesophageal junction and gastric. So this potentially unifies how we treat curative upper GI cancers. So this other study called Matterhorn asked the important question, can we improve upon that perioperative FLOT? And this study, again, published in our premier journal here just a couple of weeks ago in July, titled Perioperative Durvalumab in Gastric Gastroesophageal Junction Cancer. And what this study really did was take that perioperative FLOT I talked about, basically 4 cycles of FLOT, surgery, 4 cycles afterwards, and see if we can improve upon that by adding this drug called durvalumab. What durvalumab is an immunotherapy. It increases your immune system's ability to recognize and fight off that cancer. And immunotherapy, chemotherapy combinations have been approved and have been proven to be efficacious in stage 4 gastroesophageal cancers, but never in kind of this curative setting. So this was the first major study to show this. So let me show you the data. They randomized basically 1,000 patients, so about 500 and 500. And again, this is another Kaplan-Meier survival curve. And this is what we call the endpoints here is death and recurrence of disease. And you can see that the durvalumab curve here in this, I guess, dark green is atop of that, just placebo plus flat curve in gray. And again, here are the statistics, statistically significant improvement in that metric with the addition of durvalumab. Now, if we just isolate death as the outcome and look at overall survival, we see a very similar trend that durvalumab plus FLOT is superior to just that FLOT chemotherapy alone. And I mentioned that PathCR metric. You can see that addition of this immunotherapy called durvalumab to FLOT perioperative chemotherapy increases that PathCR rate to about 19.2%. Again, those are patients that at time of surgery, there's no viable cancer in any of the tumor specimens that the surgeons remove. And then with just FLOT alone, it's about 7.2%. So it's about 2.6-fold increase in that PathCR rate. So this is kind of the 2 major studies that recently come out and change how we treat, cure, and try to cure gastroesophageal cancers. But now I'd like to share some, I think, even more, I guess, exciting data in kind of this palliative realm in which we can't cure. Again, this is kind of, we try to improve quality of life and quantity of life. And anybody who's been in my clinic, I explained that this is biomarker driven now in 2025. And some of the key biomarkers that we test for include HER2, MMR status, which is mismatch repair. We test for this PDL1 and this new biomarker called Claudin 18.2. And the reason we test for these biomarkers is now there's treatments that we can act upon if they're positive for these biomarkers. So Claudin 18.2 has emerged as a biomarker because there's a drug. And the two trials that proved that it was efficacious are called Spotlight and Glow. I'm just going to highlight one of them. They're sister trials that looked at different chemo combinations, but we'll just look at the Spotlight trial. And the drug that targets Claudin 18.2 is called zolbetuximab. And this is again, another big phase 3 trial that looked at combining this Claudin 18.2 targeting drug with chemotherapy, and the chemotherapy here is FOLFOX, which is 5-FU, and oxaliplatin. And what is Claudin 18.2? As Dr. Guilford has already talked about, the normal cells in your stomach like to grow in sheets. And Claudin 18.2 is part of what we call junctional complexes. They kind of hold these cells in the normal stomach together. As the normal stomach transitions to becoming cancer, these cells no longer like to grow in normal sheets. They like to invade here. And these junctions are broken up. They become exposed to the surface. And this Claudin 18.2 can now be bound by targeting agents. Okay, so this is the brown here shows normal Claudin 18.2 in the normal stomach. And then these are Claudin 18.2 in two different types of gastric cancers, intestinal type and diffuse type. So what did this trial do? Randomized about 550 patients, again, about 280 into each of these. One of the groups got FOLFOX, again, 5-FU oxaliplatin and placebo, and the other group got this FOLFOX chemotherapy with zolbetuximab, which targets that Claudin 18.2 protein in those gastric cancer cells. So we'll skip that and just look at this, again, Kaplan-Meier survival curve. And their primary outcome was progression-free survival, which means no recurrence of that cancer, keeping that cancer in, I guess we can think about it in remission here. So you can see that addition of zolbetuximab to FOLFOX chemotherapy improved statistically that progression-free survival from about 8.6 months to 10.6 months. So this is statistically significant and clinically significant. So that is why we test for Claudin 18.2 now. Now let me talk about the final trial. This is called Destiny Gastric 04. It's kind of a mouthful, but what it really established is a second-line therapy for another biomarker we test for, HER2 positivity. So we've known for a while that HER2-positive gastric cancers we should treat with Herceptin and chemotherapy, but we've never known what to do after that fails. So there was no real continuing targeting of HER2 when that first line fails. Until very recently, with the advent of this new drug called trastuzumab deruxtecan. And this is a new type of drug. It's what we call antibody drug conjugate, or ADC. And what it does is it combines a certain type of chemotherapy with a HER2 antibody, actually 3 of these, so it can directly deliver that chemotherapy to HER2 positive gastric cancer cells. So this Destiny Gastric 04 trial really compared the previous standard of care is this kind of weak chemo, ramucirumab with paclitaxel, with this single agent drug, trastuzumab deruxtecan, that ADC to HER2. And this is in patients with HER2 positive gastric cancers who progressed on frontline therapy again. And you can see the 2 Kaplan-Meier survival curves for 2 different metrics. Overall survival here, superior with that trastuzumab deruxtecan in the gold curve over the old standard of care chemotherapy in the blue curve, improves overall survival from 11 months to almost 15 months. And then that progression-free survival metric, which is the cancer is held kind of in remission. It improves that, this drug, trastuzumab deruxtecan, from 5.6 to 6.7 months. So I think this is what I would like to kind of impart. So in these two curative and palliative baskets, we have essentially practice-changing advancements that have come out in the last 1 or 2 years. There's, whoops, sorry, let me bring that back. So we're talking about perioperative FLOT here. We're adding durvalumab to that in the curative setting. We're testing for Claudin 18.2. We're targeting that with zolbetuximab. And now we have a new drug for HER2-positive gastric cancers in the second-line setting. So first conclusion is that systemic treatments are improving survival for gastroesophageal cancers. I mean, this is just a fact. All those studies, that have been shown to be statistically significant. So this is a fact. But where there is still great need is, I've shown you those survival curves. Those are median overall survival. So 50% of the patients do better on those curves, 50 worse. We don't really understand, and we can't predict which patients are going to respond and not. Okay, so we need better patient biomarkers, better criteria for patient selection. And this is another area where we need to understand. So we're testing for these biomarkers. If a patient is positive for multiple of them, we don't really know the proper sequence. Which one should we give first? Which one should we give second? Is there a scientific or a clinical reason we should do one before the other? Should we combine them? We don't know this. And then as you can see from all of those Kaplan-Meier survival curves, they eventually fall. They never flatten out. So all of those treatments eventually fail. And what was sorely needed is we don't understand why these cancers eventually develop what we call mechanisms of resistance, why those drugs no longer work. So I think just to end, novel systemic treatment approaches remain a need and a priority for gastroesophageal cancers. So with that, I can take questions. I think we don't have a Q&A session at the end, so I can open up questions for a couple of minutes. Jeff?
Yeah, so I'll just one.
Yeah.
So it almost seems like, with ECAD being lost, causing diffuse gastric cancer, Claudin 18 has the opposite effect. So my question was, you had likened ECAD to Claudin 18, but it almost seems like they have the opposite effects, where loss of ECAD causes or predisposes someone to develop diffuse gastric cancer, but you are blocking Claudin 18.2 to help people with gastric cancer. So it almost seems like Claudin 18.2 is a bad player, but ECAD's a good player.
Right. So that's an interesting point. So, what Dr. Guilford talked about in CDH1, those are mutations that cause loss of function of the protein. Claudin 18.2 is normally expressed in all gastric cells. And why it's effective and why it changes is because those cells, they lose kind of that adhesion requirement, okay? And those tight junctions actually become exposed. So it's not actually a functional gain of function, loss of function. It's just mechanistically they become exposed. That antibody zolbetuximab can bind and we can target it. So it is what we call antigens. It's a cancer antigen, and what's nice about it is it's not expressed in any other organs, okay? There's low levels, probably in the biliary tract and maybe in the bone, but very few other organs. So there's not a lot of off-target effects. So a lot of different companies are trying to target this Claudin 18.2 with ADCs, cellular therapies. It's a hot topic of research and interest right now.
I grabbed the microphone, so I guess I'll ask. But
Go ahead, Jose.
So along those lines with Claudin 18, do you know how early it gets sort of, you can detect it, and can you detect it in these precancerous stages, and should we be targeting it earlier, or does it only get expressed once a patient has actually developed cancer?
No, that's a good point. So what's interesting about 18.2, or I guess Claudin 18, Claudin 18 has two isoforms, 0.1, 0.2. Doesn't really matter, but like I said before, it is an inherent gastric identity protein. Okay, so in RNA-seq or anything, we see Claudin 18.2. That's a gastric signature. In IM, I don't know about kind of these gastric metaplasias, SPEM or pyloric metaplasia, but we know in IM, once you kind of lose your gastric signature and adopt that intestinal signature, you lose Claudin 18.2. So, so that's a very interesting point. And then in these cancers, why it comes back that emerge out of these IMs, I think it's because there's a lot of lineage plasticity in these cancers. They start expressing intestinal markers, but also normal gastric markers. So they kind of possibly re-express that as well.
Thank you. Really, really good talk.
Guilford.
Is anyone developing antibody drug conjugates against Claudin 18.2?
Yes, there's a lot of companies that are targeting 18.2. A lot, some of the people here with booths outside, I'm not allowed to kind of say names, but there are a lot of ADCs in works. There's bispecific antibodies that try to target Claudin 18.2 and bring in CD3 positive T cells. There's CAR Ts that are being so those are chimeric T cells that have been engineered to recognize Claudin 18.2. So those are all kind of in the works. Yes. So again, an exciting area. But I do want to point out again that it's only about 30%, maybe 40% of gastric cancers are going to be Claudin 18.2 positive. Okay.
Treatment going for the other types of cancer that you were talking about? Is there any other treatments that you guys are doing for that type of other types of cancer?
Yeah, so I probably should have broken down this palliative, but we have different baskets, like I said. So there's this Claudin 18.2 basket that we target with Claudin 18.2 drugs. There's a HER2 basket that we target with HER2 drugs. There's another basket called PD-L1. So we're using certain immunotherapies like pembrolizumab and nivolumab that we can combine with chemotherapy. But that's it. Those are what we call actionable biomarkers. A lot of patients, each of those are probably between 10 to 20%. There's some overlap, but a lot of patients are going to be biomarker negative. And for those patients, unfortunately, we just are using kind of FOLFOX or variants of that kind of chemotherapy, and really no real advancements for them. Yeah, I mean, chemotherapy is the backbone for all these treatments, and in itself is pretty effective. But obviously, it's kind of been around for a while, and it's toxic. Hard to tolerate. And that's why we need to find better treatments and hopefully a future where we can kind of turn down these chemotherapies and rely on more what we call targeted therapies that are more effective, less toxic. We're on our way, but a lot of progress can be made. Okay, so okay, thank you. Okay, well now it's my pleasure to introduce our next speaker, Dr. Whitney Brand. She's an assistant professor. in the Department of Surgery, and she's really going to talk about new or surgical treatments for esophageal cancer. So help me in welcoming Dr. Whitney Brand.
Hi, everyone. Thanks for having me here today. So I'm going to talk a little bit about esophageal cancer and how we manage that surgically. And just an overview, I'll give a little brief about the anatomy of the esophagus and then the things we think about surgically, the approach, and how we're going to recreate the esophagus. And then I'll talk about some of the data more recently and some older data about complications and newer technologies. So esophageal cancer is fairly common. In 2025, there were reported 22,000 cases, and there were over 16,000 deaths. So it's common and hard for patients. And if you look at the anatomy of the esophagus, it's here on the left. We tend to think of the length of the esophagus and divide it by upper esophagus, kind of middle esophagus, and lower esophagus, and then GE junction or gastroesophageal cancer. So they kind of span that. And the reason that matters is because, and what I'm going to focus on in most of this talk is the distal and mid-esophageal tumors. And that's because once you start getting higher, you have to kind of manage those a little bit differently. But the majority of this talk is going to be on middle and lower esophageal cancer. On the right, here's a picture that you may have seen already today, but this is just showing kind of the depth of the tumor invasion. And the reason I bring that up is because when it hasn't invaded the esophageal wall very, very deeply, then you can use endoscopic therapies. And that's great for patients because they can avoid the surgery I'm about to tell you about. Once it gets a little bit deeper or there are lymph nodes that are positive, then we have to start thinking about doing an esophagectomy. So I'll talk to you about those. Here, like on the left, you already heard about this, but early stage has some pretty nifty esophageal endoscopic resections. On the right, when things are more locally advanced and we have to do an esophagectomy, this is kind of a gist of what it might look like. We take out the esophagus and a portion of the stomach in most cases, and then you use the stomach preferably to recreate a tube like the esophagus and reconnect it to the proximal esophagus where there is no tumor. So there are a couple different ways we can do that operation. The fancy ways that we call them are transhiatal and transthoracic. That means you go across the whole chest and into the neck for transhiatal, and then transthoracic is in the abdomen and chest. Which conduit to use? How are we going to recreate the esophagus? The stomach is preferred, but sometimes we can't use the stomach. We'll talk about that, and we use colon or small intestine. And then how are you going to do the operation? Open or minimally invasive with a robot technology, which is what we use here. So I'll first start by talking about the transthoracic esophagectomy. This is a midline incision. You can see on the top for the abdomen, and then a right thoracotomy, meaning right chest incision. And if you're doing this open, the incision on the right kind of wraps around to the back. The abdominal portion is getting the stomach kind of mobilized, and we're just trying to prepare that stomach and take out if there's any little piece of tumor that's in the stomach that's supposed to come out as well. But the whole point in this abdominal part is getting the stomach ready to use for the chest and taking out the very distal end of the esophagus. Once you get into the chest, this is an example. You can really see the whole esophagus. You can see the lymph nodes around it. You cut it, and then you reconnect the two together after you make a tube. So that's the general gist of the transthoracic. The transhiatal esophagectomy is a different approach with a similar kind of concept. Instead of going through the chest, you make an incision in the neck where you find the upper esophagus. And then the surgeon actually bluntly kind of goes around the esophagus from the abdomen. So they do that whole chest part with their hands and I feel. The connection is pretty much the same, but it's just in a different spot, slightly higher, because you have to be able to mobilize the esophagus. And then this is just a picture of kind of how we cut the stomach and this new tube that's created that we'll bring up to do the connection. Now, there's been a randomized control trial. This is now over 20 years old. And so it's not, but it's considered dogma now. And it was for mid to distal esophageal adenocarcinoma, like I'm talking about. And they split patients up into getting one of the two techniques. And not surprisingly, the numbers on the bottom I'll kind of point out is that when you went through the chest, patients had more lung complications, and that's not surprising because there's more pain. This was back in 2002, so there was very little minimally invasive techniques being used. It was all open. The differences in other outcomes were not really different. The number of lymph nodes resected was higher in the chest group, and that's because you can actually see the lymph nodes you're taking out. They looked at overall survival and disease-free survival, meaning did the cancer come back? And those outcomes were not different. But there was a slight favor towards doing the operation through the chest, and that really was thought to be attributed to the number of lymph nodes taken out. So really, at the end of the day, the operation is not much different from a cancer standpoint. And if you can get good lymph nodes, then that's all that matters. So the different conduits we use, the gastric, I mentioned, the stomach is the preferred. Usually we make this tube, and this is kind of how it looks. It's usually about 4 centimeters wide. We measure it in the operating room. And the perfusion, the blood supply, actually you have to cut some of the blood vessels to the stomach in order to move it up into the chest. And so it comes from the blood supply down here and then also over here. And then the tip up here is actually perfused by some of these vessels. So it can be up to 5 to 7 centimeters, depending on where you have to make your connection in the chest or in the neck. And there are a bunch of different ways we can make this connection. The most common that we use here is with this stapler called an EEA. We actually sew a special anvil in the proximal esophagus where we have cut. And then you take the stapler through the part that's going to come out into the tube, and then reconnect them. And then we end up having cutting up more of that gastric conduit. So this is 95% of our anastomosis, and allows you to kind of use the conduit, make it a little straighter, and cut off some of the stomach that might not be have as great of a blood supply. This technique on the bottom is the Ornger technique. It is very commonly used, especially in minimally invasive resection. And it's a straight stapler, and then you sew the front wall. So it's just a different way, but this is the one we use right now when we do open esophagectomies. And we kind of prefer it because you can cut off some of that conduit. Now, other conduits, so sometimes the stomach is not a good option to use, and that's if the patient has a previous stomach surgery, then it's not going to be useful for that. If their tumor is in the stomach and you're not going to be able to get a good margin, meaning they're scared that if you use some of the stomach, there's still going to be cancer there, then you have to use something else. But when you do use the colon, it becomes a little more complex. So first you have to bring the colon up and connect it. And then there ends up being more connections because the colon's connected to the esophagus. Now you have to connect the colon to something else. And the colon has to go back to each other. So it makes it a lot more complex to recover from, and it's a longer operation. Usually we do these here in collaboration with our colorectal surgeons. So it's a dual surgeon operation at least. So it's just a little more complicated for patients. There's another thing called the jejunal conduit. This is a small intestine that can be used. At WashU, we don't use this all that much. Some centers actually prefer to use this instead of colon. It just depends on the institution and their comfort. Here, we usually use it for very high esophageal malignancies. This is a picture here where the piece of small intestine is actually hooked up to the esophagus in the neck, and then a artery is reconnected to an artery in the neck to help that have the blood supply. That, if you can imagine, that also creates a lot of extra work and is very specialized. In any case, the completed reconstruction looks something like this. So the connection between the esophagus that's remaining and the new, usually gastric conduit, is in the chest. And then there's a valve that sits at the end of the stomach called the pylorus that sits right in between the chest and the abdomen that helps prevent some reflux. But really, the stomach works differently than the esophagus. Instead of contracting food down, it kind of is just a tube that sits there and allows food to drain down. So it's a little different for patients to eat. Things aren't getting pushed down. It just drains by gravity, and things can come back up from the abdomen, causing reflux. Usually here, how we take care of these patients, they have their normal postoperative recovery. They're started on a liquid diet early in their postoperative management. Some may or may not have a feeding tube. It depends on the surgeon. And they're usually discharged if everything goes well within a few days. I think I'm going slightly over, so if you want me to slow down. So this is a big operation, as you can kind of see. It's a little complex. Your stomach is not meant to live in the chest. So your body doesn't really like that conformation very, very much. And it is associated with a lot of morbidity or complications. This is a more recent study out of 14 countries and 24 high volume centers. So people who are doing the operations very commonly. It's over 2,700 resections, the majority of which got a complete resection, got all the tumor out. And the majority were done through the chest and had a stomach used as a conduit. But you can see that 59% of patients had some sort of complication. And there's a decent amount of patients here on the right that had more than one complication. One of the feared complications we always talk about as surgeons are leaking. So that means that the connection you made between the stomach and the esophagus kind of falls apart. And it's really important to us. This is, again, now like over 10 years, an older study, so it's a little outdated based on the new techniques, but we always worry about which patients are going to have that problem and preventing it. This study looked at over 7,500 patients who got the operation. About 10% had a leak, and the mortality of the leak was slightly higher than if they did not have a leak. And patients with heart failure, high blood pressure, and kidney problems were more likely to have a leak. These can be managed in different ways. Sometimes a leak is not, we just keep the patient without anything to eat and drain things. And if you had a neck incision, sometimes we can open the neck and that's all they need. So it's not very, they don't have to go back to the operating room, or it's not very morbid. Other times when it's leaking a little less and not well controlled, we have to put a covered stent in the esophagus temporarily to kind of seal that. Sometimes we put a little tube through your nose that drains that through a vacuum. That's a little more advanced in certain different ways. And in extreme cases, but luckily it's rare, we have to actually take out that piece of stomach if it's not survivable anymore, if it's not living well. More recently, we've been doing minimally invasive esophagectomies. What this means, instead of having big incisions, you have small incisions, and we use the camera. This is a randomized controlled trial that was done about 5 years ago of 112 patients that either got a robotic esophagectomy or an open esophagectomy. And they had similar ages and divisions between the groups. The majority were adenocarcinoma. 80% had chemoradiation, as that was the standard back in the time the study was being done. And RAMI, which means robotic complications, were less, so 59% versus open, which was recorded as 80%. And of course, there was lower pain because the incisions were smaller and less heart problems after the surgery, but the long and other short-term outcomes were very similar. This last piece of data I'll show is that the high volume centers tend to do more. And if you can imagine, this is a complex operation. So the more a certain center does, the better patients do. And that's not just the surgeon doing more, it has to do with that, but also the nurses, everyone in the hospital kind of is aware of the pathway and kind of knows how to manage these patients, which can be a little more complex. So I'll conclude there. Just going to say esophagectomy should be performed with a mortality less than 5%. That's the goal, but the morbidity still is high. And there is decreasing morbidity now with increased utilization of these minimally invasive techniques. And it's something we're still perfecting. Thank you very much.
Thank you. Thank you, Dr. Brand, for this great overview. I have a question related to the talk from Dr. Jin. What is your preference on the perioperative treatment? I mean, the flood has more side effects.
Yeah.
Do you tailor it, or do you have a standard?
So, and we are going to talk about this a little bit later. So from our standpoint, the radiation is harder to operate when patients have had preoperative radiation. It actually makes things stick a lot. And even, we've seen this in lung cancer cases as well, which we commonly do, but things after just chemotherapy are not as stuck together. So it makes that part more complicated, just doing the dissection of the esophagus. The other thing we worry about is if you radiate part of the stomach that you're going to use to make your connection, the blood supply might not be as good. And we're already kind of stretched thin on blood supply. And you can see that that leak rate is like 10% nationwide. So we're worried that if there's a little bit of radiation to the healthy tissue we're trying to put back together, that can cause leaks, because we're anxious about avoiding those. So those are the things in our mind that we're kind of cognizant of. And you're right, the FLOT technique that Dr. Jin talked about sometimes has patients, it's a little more challenging for them to deal with than the full Fox regimen, which was in cross. But our radiation oncologists have been good here too about not going up too high where we think we're going to make the connection and kind of staying close when we used to do cross frequently. But those are kind of the perspectives of most surgeons nationwide, I would say, have a similar feelings about it.
Question.
Where is the sphincter valve located?
Yeah. So there's a muscle at the end of the stomach. You mean after an esophagectomy? What's that? Yeah. So there's a muscle at the end of the stomach that's normally there to kind of, once your stomach digests food, it kind of opens up and lets things go into the small intestine. That muscle we use is still there. We don't take that part out. And sometimes it can be too tight for patients right after the operation. So I didn't talk about this, but during the operation, we do some maneuvers to kind of loosen that so they don't get things just sitting in the stomach because it's not draining well. So that's either stretched sometimes with a balloon or we inject Botox, which relaxes the muscle. But that muscle also helps prevent a little bit of reflux. So it's kind of, you're trying to get it right in the middle. And it usually works pretty well for patients, but sometimes right at the beginning, patients need to have that stretched. Mm-hmm. Yeah, no problem.
So our next speaker is going to join us virtually. Let's see if we can pull him up. And it's Dr. Vlasic, radiation oncology, and he's going to talk about radiation treatments in gastroesophageal cancer. So let's give a hand with for Dr. Vlasic.
Thanks, Ramon. Can you guys all hear me okay and see my slides?
Yeah, we can hear you.
Okay, great. So my name is Greg Vlasic. I'm a radiation oncologist here, associate professor in the department, and I apologize that I'm not able to join in person, but I'd like to today talk about radiation therapy with gastroesophageal cancer. And so just kind of some brief objectives of our short talk today. I want to give a brief history of radiation treatment when involving the distal esophagus and gastroesophageal junction cancers with a focus on locally advanced disease. And then go into some details of our current radiation approach, then discuss the current state of radiation therapy and multidisciplinary care as it relates to locally advanced disease, and then discuss some future directions when it comes to radiation treatments in this space. So for those of you who may not have some familiarity with radiation treatment, I just wanted to kind of give a brief overview of what it is exactly, unless someone's been through it or knows somebody close to them that has. It often can be some kind of nebulous concept here. So really, radiation treatment is the use of high energy photons or X-rays to target tumor, whether it's gross tumor or microscopic disease. And you kind of think of it like an X-ray or CT scan on steroids as far as energy, but with the important caveat that we're focusing it on a specific part of the body that we're intentionally trying to treat. It's a focal therapy where higher doses is again intentionally targeting a specific anatomic location. So in some ways you can think of it as similar to surgery in that we're sort of focused in one part of the body as opposed to systemic therapy, which goes everywhere. In the majority of cases, it's something that's delivered externally, and the picture that you see here is a linear accelerator where the arm swings around the radiation focused area is emitted from that linear accelerator head. Another thing to kind of keep in mind with radiation treatment and why it's important to think about is that normal tissue and organs that are in the path of the radiation can be impacted by the treatment as well. But there's no effect on normal tissue or organs that are outside the path of the beam. So if we're treating a rectal cancer, there's no exposure or risk to the lung or the heart, so to speak. Less commonly, radiation treatment does involve the use of radioactive isotopes, which are implanted either temporarily or permanently and delivered internally. So that's more of a procedure type of approach, but I'm not going to go into that today. And it's also, a pretty small portion of what we do for gastroesophageal tumors. And so, specific to us in the radiation field, I kind of want to first start by making the distinction between distal esophagus, GE junction versus gastric tumors. And so here's just a schematic of the anatomy of the stomach. And, this area here, the distal esophagus, GE junction, and the very proximal stomach, there's a clearly defined role for radiation therapy and the curative management in this case. But when we're thinking about, the more distal stomach, the body, and up to the pylorus, there's really a very limited role for radiation therapy and curative management. So I'm not going to be really, discussing that just because we don't really play a major part in, truly curative treatment of this disease. And so, kind of thinking about just the history of radiation treatment in the treatment of GE junction and distal esophageal tumors. So, when thinking about it in the context of people who are surgical candidates versus people who are not surgical candidates. So with surgery, when we've looked at doing radiation therapy alone after surgery or before surgery, we found that there was no real, survival benefit over the surgery alone. And so radiation treatment on its own didn't seem to have any impact on how well we did with people who could get esophagectomies. When we started thinking about adding, a combination of chemo and radiation together, so first in the post-surgical setting, and this is where there's some overlap with true gastric cancer and where we have, potentially some role in curative management, though in practice, not really, we don't really use this approach very much at all, is results from this intergroup 0116 trial from the 90s, which looked at surgery alone for locally advanced gastric or GE junction adenocarcinomas. Compare that to chemoradiation, which was sandwiched between chemotherapy after surgery. And so there was some benefit to do that approach. But again, it's not a treatment paradigm that's really something that we do anymore. And then in the preoperative setting, when we looked at doing chemo and radiation before esophagectomy, initial studies were trended towards a benefit, but it was still not really a clear, practice across the board. And it didn't really become the clear standard of care until the CROSS trial, which I'll talk about shortly. When thinking about non-surgical candidates, chemoradiation is really the definitive treatment option in that setting. Initially a study back from the 80s compared radiation alone to chemo and radiation and showed superior outcomes with the combination of treatment. Even at 5 years with radiation alone, there were no survivors. And so, chemoradiation is really the only option for people who can't get surgery to potentially have curative treatment. And then, but when we try to improve on that in general, specifically looking at whether we could escalate radiation dose to try to improve the outcomes with chemoradiation, so far that has not shown to have any benefit. And so we've kind of had the same approach as far as the radiation dose, and to some extent the chemotherapy for quite some time. And so since the CROSS trial really informs a lot of what we do on the radiation side, I just wanted to go into some more detail about this since I don't think we've really covered this just yet. So this was a study that was conducted in the 2000s, and it was comparing surgery alone to chemo and radiation followed by surgery. And so in the chemoradiation group, radiation that was delivered was 41.4 gray, which is our unit of radiation therapy over 23 separate treatments. And then chemotherapy was weekly carboplatin and paclitaxel, which essentially is for radiosensitization. And so what they found was in this study that chemoradiation didn't significantly impact the ability to get surgery. So 94% or greater of patients in both arms went on to get the surgical resection. And it didn't appear to be associated with higher postoperative mortality. And it was 4% in both groups. Chemoradiation before surgery showed an improvement in overall survival, pretty significant in this study. So 49 months with chemoradiation versus 24 months without. And achieving a negative margin was significantly improved with the addition of chemoradiation. And Dr. Janet's kind of talked about the concept of complete pathologic response. And so, how much of the tumor that's seen at diagnosis is pathologically gone at the time of surgery. And so in this study, 29% had a complete pathologic response. When they looked specifically at adenocarcinomas, it was a little less at 23%, but still, a pretty decent number. And then the chemoradiation had reduced local or regional recurrence, so recurrence in the esophagus or within the lymph nodes nearby over surgery alone. And I'd say one distinction that I'd like to point out is that the radiation dose that they used in the study is specifically because these patients went on to get surgery. In our clinical practice, we tend to give a little bit more, in the definitive treatment range, since it's not a whole lot different than the 41.4 gray. And it also allows us, it doesn't put us in a situation where if for some reason the patient can't get surgery, that we've undertreated them for potentially curative treatment. So before, if it's preoperative or if it's definitive, then we generally will treat to 50 gray, so a little bit higher than the trial here. So, so then, the current role of radiation therapy in surgical candidates, it's for preoperative chemoradiation based on the cross trial. And then for non-surgical candidates, it's definitive chemoradiation. But with the asterisk that will kind of, come back to this as far as, surgical candidates based on those studies that Dr. Jenna discussed. So kind of talking about as far as how we design the radiation treatment and what the process is like. So radiation treatment fields are based on where we know the tumor is and where we think microscopic disease is hiding. And so, gross tumor is delineated by CT, PET, or endoscopic ultrasound. This is just a snapshot of a PET scan. You can see that uptake in the center part of the chest there, identifying a tumor. And when we design a radiation treatment based off of a CT scan that we use for planning, we expand around the gross tumors in the radial direction, so left, right, anterior, posterior, as well as above and below the esophagus. And so, with the radial margins, they're relatively modest to account for possible microscopic expansion beyond the confines of the esophagus or the lymph node. But kind of unique to how we, on the radiation side, manage expansions of treatment volumes with esophagus cancer because there's a higher likelihood of submucosal spread. And this is based on older pathologic studies on surgical specimens that we treat a longer length above and below the primary tumors. And so that's something on the sagittal section here, you can kind of appreciate, I don't know if I have a pointer, but that above that red outline where the tumor is, you can see there's some extension above and below more than it would be to the left and right. And so, to Dr. Brandt's point, that does also kind of potentially complicate surgical management, since the goal is to do the anastomosis, the connection outside of the prior radiation field. And so, as I mentioned earlier, traditional radiation is done with photons, so X-ray treatments, but it does result in what we call lower dose spill into other areas of the chest and upper abdomen. you may or may not have heard of proton radiation, which is a newer technique that has a different physical property that significantly reduces this spill. Essentially, X-rays don't have any mass, and so they kind of, traverse the body without much change. But protons do have mass, and so we can design it so that the radiation essentially stops deep within the body. And this figure here kind of shows that spill area. So all that sort of dark blue are lower doses of radiation therapy that are sort of necessary, or we kind of accept just based on the physical properties of the X-ray. Whereas the on that left side, the PBT, which is the protons, where the proton beam enters, there's radiation dose, but past that, in this case, you can see in the heart, there's really effectively no radiation dose there. There's been some institutional studies that suggested a potential advantage to protons for reducing side effect risk and improving survival, both in the preoperative and the definitive setting. And there's currently a large multi-center trial, the NRG GI 006 study, more directly comparing these two treatment modalities. And so from this graph on the figure with the squares, that shows the radiation dose with the protons, the triangles with the X-rays. And you can see that the square relative to the triangle with the same color, those are organs that are seeing much less radiation treatment. So and then, as far as side effects from radiation therapy, during the treatment, folks can get fatigue, some pain or difficulty swallowing, since the lining of the esophagus can get pretty irritated from the radiation treatment, and then skin reaction too. And then some late side effects, things that we kind of think about when we treat this type of tumors: inflammation of the lung nearby, which can cause some cough, shortness of breath. If there's enough lung that's treated, there could be potentially more serious side effects. There can be, especially for folks that don't get surgery, some scarring or stricture of the esophagus. And so we treat the underlying tumor, which often causes pain or difficulty with swallowing, but we may end up causing similar issues just from the radiation itself. And then there's also the concern of damage to the heart. Coronary artery disease and pericarditis are some of the more common possible side effects there. So, to kind of go back to the role of radiation therapy. So, in the 2025 edition, I think, obviously takes into account some of these seminal studies that were published earlier this year, that Dr. Jin had mentioned. And so, I think now we're starting to really appreciate and learn how best to integrate radiation treatment in the treatment of these patients. And so, generally speaking, for healthier patients who we think can tolerate more aggressive chemotherapy, then the FLOT with or without immunotherapy is generally the preferred approach. For patients who may not be able to tolerate that, then we still would consider preoperative chemoradiation. But we're starting to appreciate, and we'll talk more about this sort of the group discussion later, is that in the postoperative setting after FLOT and surgery, if there are risk factors for local or regional recurrence, is there a role for radiation treatment afterwards? I'd say overall it becomes quite a bit more complicated from our perspective, and so that's a kind of open question. And then one thing, I don't know if we talked much about the difference in histologies, but the thing that I'd point out as far as radiation goes is that esophagus tumors can be adenocarcinoma, which are similar to gastric, or squamous cell carcinoma. So the different histologies are important. For squamous cell cancer, those studies above are specifically for adenocarcinoma. So preoperative chemoradiation is still the standard approach. The cross trial showed about 50% complete pathologic response in this histology. And so, and we do occasionally see squamous cell histologies in the distal esophagus close to the stomach too. So, so it does still kind of factor in. And then for non-surgical candidates, still definitive chemoradiation. And then just quickly, future directions is really determining the role of protons. Is it really something that is going to provide better outcomes. Since it's a limited resource, it's expensive, and so we want to be sure that it's something that is truly of significant benefit. And then can we use different radiation schedules or boost techniques to improve outcomes, particularly for non-surgical candidates? And this is something where we try to do more radiation dose per treatment to see if we can shorten the course of radiation and improve the outcomes. And then integration of immunotherapy with radiation. We know that radiation treatment can, increase immunogenicity, but it can also impact the immune system function directly by affecting immune cells because they're sensitive to radiation. So can we integrate those two? So, and with that, I'm all done. Thank you.
Okay, this is the right one. Thank you. Hi, everyone. My name is Rohina Penny. I'm a surgical oncologist and hepatobiliary surgeon, and gastric cancer and GE junction tumors is one of the areas I focus on. One thing to emphasize here before we start is, as you can see from the lineup and different speakers, we all work very closely to each other. So the thoracic surgeons, myself, medical oncology, radiation oncologists, we all discuss every single case before we come up with a plan. So it's important to pay close attention to some of the things we talk about, but eventually it's not just one person making the decision, which is a place that you want to be at whenever it comes to complex and rare cancers like gastric cancer. So in my talk today, I will cover a little bit of details about the surgical procedures. I'll emphasize a little bit on the staging because for gastric and GE junction tumors, the staging involves a surgical procedure, which is staging laparoscopy. And I'll talk about why it's important to consider. Second thing, which is very important, is markers of high quality surgery. How would you choose where to go for your surgery for something that is a rare cancer in the United States? And some considerations on choosing the surgeon type for the kind of procedure that you would need. So staging laparoscopy, which is something it's a surgery that you have to complete most of the times once a tumor is diagnosed prior to starting your chemotherapy. And it's not ideal because sometimes we think that, a week or two of delay recovering from this procedure would be so critical for us to not delay the chemo and just proceed with it, which is actually not that helpful in the big picture because the most important piece you're trying to capture at the time of diagnosis is the accurate stage of cancer. And it's very important with the new clinical trials, new discoveries, immunotherapy, when to decide on radiation, and what type of surgery to perform afterwards. I think all of that information can be captured from this one outpatient procedure. So it tells us where the tumor has traveled outside of the stomach, and preferentially the gastric cancer travels inside the abdominal wall. And you see small spots which you can't really pick up on the CT scan. And if those are positive, then the treatment regimen for you would be different. So whenever this is encouraged, there is a huge reason why we try to emphasize and incorporate that as early as we can before starting chemotherapy. So that's a key thing to remember. Secondly, when I talk about categories of gastric cancer, there are three different broad categories that are relevant. That's how I talk to my patients. It makes it very easy for them to understand why we do certain things. Instead of the 4 stages, just break it down into an early stage tumor, which is typically a small tumor. You can't really see it on a CT scan. And with advances like Dr. Kushner and some of the GI folks presented earlier, we can remove those tumors endoscopically. And if they have favorable biology, which means the final pathology tells us it was a good resection, favorable subtype of tumor, we don't even need to go out after lymph nodes or perform any big surgery. If you can comply with the surveillance protocol, which is endoscopy, which is a very important thing to consider. It's new data coming out in the last 4 or 5 years, largely extrapolated from Japan and Korea, where the incidence of gastric cancer is high. So we can eliminate the need for a surgeon. And me as a surgeon saying that tells you that I am supportive of something that can avoid a big operation if it helps the patients. So that is a new area which you're going to hear, you already heard about from Dr. Kushner, but something to talk about when the diagnosis is made. Second class, which is the most common one where you see us, is the middle stage tumors, where we don't have distant metastases, but the tumor looks like it's visible on the scan. You have maybe a positive PET scan finding, but these are the patients where staging laparoscopy tells us whether there is metastases within the abdomen or not. And those are the patients where we start with chemo, immunotherapy, and then consider surgery afterwards. The third category is the advanced or metastatic. Now, I put both of them together because it used to be metastatic stage 4, no surgery for a very, very long time, but that has also evolved in the field of gastric cancer. If the tumor is large, it's involving critical structures, we still need to start with the chemotherapy, confirm metastatic disease. If there is nothing visible on the PET scan, we still do a diagnostic lab if it's all advanced and confined. But one thing to consider is this important area, which is new, cytoreductive surgery, which is carefully considered in certain patients, especially at centers like high volume centers where you have medical oncologists and team members who can select those patients for the correct operation. I'll go into a little bit of detail on each subtype that I just mentioned. So the early stage tumors where surgery can be potentially eliminated is a tumor which is confined to the inner layer of the stomach. And as you can see, if it's very small and confined, it can be endoscopically removed. And if it heals and there's no concern for positive margin, that procedure is considered sufficient. If there are positive margins or lymph nodes, we can always go after removing them surgically. And you must have seen this picture in the earlier presentation. This is how they remove the tumors, go just into the deeper layer and take it out with a negative margin. And we don't have a randomized control trial in the US, but we have a lot of data from other countries where the follow-up in these patients has been successful. The middle stage is where the tumors are advanced around the blood vessels. And I'm showing this other picture here with the green areas around the stomach. These are referring to the lymph nodes. Gastric cancer preferentially goes to the lymph nodes. So part of the surgery is removing all of these lymph nodes to know which ones were positive. The treatment is typically a combination of chemo, surgery, and the end goal is cure, which is why it's important to remember that even if you're hearing that it's spread to the lymph nodes, that doesn't mean that we're not aiming for cure. And the last one is metastatic disease, which is we start with the systemic chemotherapy, which slows the progression. It's not considered a cure, but for selected patients who have really good response, we can consider cytoreductive surgeries. I'm sure you have already seen this before, but after the initial diagnosis, just remember these are the things you have to go through before the treatment should be started. And very important to get cross-sectional imaging, whichever one is recommended by your medical oncologist, endoscopy for diagnosis, and also an ultrasound and a staging laparoscopy, which ideally should be performed by the surgeon who will be doing your procedure so they can prepare for the surgery, whether to choose small incision surgery or traditional open approach. And I mean, you're seeing a trend that I'm emphasizing this procedure. It's important to remember it's an outpatient surgery. You go home the same day, very quick recovery. So it does not cause much delay. And I think if it helps you plan the surgery through small incisions or debulking approach, it's best to consider it. This is a warning slide for those who don't like pictures of surgery, but I'm sorry, I'm a surgeon. I have to show some of those. So close your eyes if you're scared. Okay, so this is what I mean. You can see these little dots on the inside of the abdomen, which are not visible on the CT or on the PET scan. So this is what we are looking for when we are trying to perform the diagnostic laparoscopy procedure. Here's some more extensive examples. And another important thing is ascites. When there's fluid built up in your abdomen, that's also not a good sign. So we have to collect that to confirm there's no tumor in that fluid. Okay, you can open your eyes now. So this is a picture just telling you things can be good. There could be no metastatic disease on this diagnostic laparoscopy, but it could be bad news. But don't consider it that something that, oh, what if they find positive cancer on the diagnostic lab, I won't get surgery. That's not true. If you don't get surgery immediately, you still will be considered for clinical trials. And by having that access to those metastatic spots in the abdomen, we can provide a lot of good quality tissue for the medical oncologist to look for biomarkers that can help you help us identify any markers that we can use to put you on a clinical trial. So it is a good and bad news in that moment, but it helps us eventually to come up with a better plan for you. And the second section I want to emphasize on is the quality of the procedure. And this is where the training and being at a Siteman Cancer Center or a high volume center is important. You will see in all the information that they handed over to you, it's still a rare cancer in the US, which is a good thing. We want it to be a rare tumor. There are not a lot of places that specialize in gastric cancer, and primarily because there are not enough patients to be seen in one center. So there are selected areas in various regions in the country that specialize, and we are one of them because we see a lot of volume in states around here. So quality metrics for surgery is not a thing commonly people talk about or look at because a lot of patients want to get surgery closer to home, but just want to mention a few things which if you're seen by a surgical oncologist who specializes in this disease, they're going to come up with a really good plan for your surgery. And the areas that we look for are margin negativity. We want to make sure the tumor margin is negative. And how do we know that? We will confirm that in the operating room. We have access to pathologists who can perform frozen sections right away. We also understand when we will have discrepancies on the final pathology. Lymph nodes, which is a metric which is very important. And there are certain numbers you want to be removed and visualized by the pathologist. And also postoperative complications. And most importantly, these days, minimally invasive approach is underutilized in gastric cancer, but a lot of these surgeries can be done with small incisions and robotic procedures. A little bit detail on the margin. Totally depends on where the tumor is located and how aggressive we can be. As you can see here, this black tells you how much of the stomach would be removed, but there are several different types of procedures. So it all depends on where the tumor is. The key is for the surgeon to plan what resection will get them a negative margin. Lymph node sampling is another area. 16 lymph nodes is the minimum amount that is required by NCCN for us to complete the staging. But a lot of times with these robotic procedures we've seen, we have such a good visualization that we get a lot of lymph nodes in that area, which are supposed to come out because it's part of the specimen. But then our pathologists are very good about looking at them and confirming that we have a clear answer on how many lymph nodes were positive, which is going to help us decide what chemo, what immunotherapy to choose during the adjuvant phase, which is after surgery. And this is just a picture of a total gastrectomy, which is the most aggressive procedure that I showed previously in the pictures. And you can see the stomach, which used to be here, is now gone, and you have a new connection. This anastomosis, or the new connection between the esophagus and the jejunum, is a very high-risk connection. So it's good to choose a place where they do a lot of these so they're comfortable not only performing the procedure through minimally invasive approaches, but also they're comfortable managing if anything goes wrong, which is more important thing for the recovery and making sure you can get to chemotherapy in the window that we want you to get back to chemo. And this is what I was talking about earlier, minimally invasive approach. This is typically the robot. We use the robotic assistants to perform the surgery. The surgeon is the one doing the procedure, so it's not this device that's going to do it. But we use it and gives us like much finer and better visualization and finer dissection to get all those lymph nodes in areas that are not feasible with an open approach. Okay, another warning. Okay, so this picture actually shows you what the lymph node dissection looks like. So it's just giving you an idea where we staple the stomach. Here's the distal part of the stomach. We have to clean every blood vessel which sits in that area to make sure we get all the lymph nodes. How do we count lymph nodes? Because everything comes out as one big piece. So surgeons help the pathologist by identifying areas closer to the tumor and ask them to look for specific areas where the lymph nodes could be positive. But you can see all of this area is fat where the lymph nodes are hidden. So we have to specify where to look for those lymph nodes. And this is just one new technique I wanted to talk about. When I mentioned we don't have to always do aggressive surgery, a lot of lymph nodes. With robot and small incision surgery, you can actually see where the lymph nodes are positive for the tumor by injecting a dye into the tumor if it's an early stage. So we don't really have to do a big resection or a reconstruction. We can easily identify the positive lymph node. And just like we have done this in many other cancer types, we get to the answer very quickly with sampling just a few lymph nodes around the area of the tumor. Okay. Yeah, and this is what I was talking about, margin positivity. So when the endoscopists identify the tumor and say, for example, they've done endoscopic resection and we are going after the second time, it's good to have that communication between the GI team and us so we can plan on how aggressive we need to be with our margin resection. And you can see this is a normal stomach that has to come out just to make sure there's nothing spreading submucosally that you'll find out on the final pathology once you're in the operating room. But here you can see previous clips by the GI team where we ended up removing with a clean margin, and the patient did well. It was a final pathology had a negative margin. And avoiding the big midline incision, small incision surgery. This is a patient of mine. You can see all these ports are very small. There's less pain. You have to make one incision to remove the stomach out. And that once it's healed, it typically hides really well. So this is like a year after surgery. Patients do really, really well. The pain control is not an issue, less discomfort, fewer complications from an infection standpoint because the incision is not big, and they recover really well. And I highly, highly encourage patients, if there's someone here with family history of a CDH1 mutation where patients need a prophylactic gastrectomy when there's no cancer, to consider something small incision because those patients are typically younger, and it's best to avoid infections and hernias from a big incision. Okay, photos are done. You can open your eyes. How to choose a surgeon. Now, this all goes back to who is the surgeon that you're comfortable with, but it's important that a few more things are considered when you're making that choice. Their expertise is important. Their experience is very important, but relationship, I usually consider that as one of the areas that only the patient can tell how you relate to the surgeon, whether they have the experience, expertise, and all of that. And don't forget, logistics is hard for the main operation that needs to be done at a high volume center, but that also is important to have a surgeon locally that you're comfortable with who can help you with the post-op small complications, but in addition to a surgeon who's going to be doing your surgery, which is going to be away from home. So these days, the training processes have evolved for surgeons and for medical oncologists. Everyone specializes in certain areas. So surgical oncology is a training that trains patients really well for gastric cancer surgery. It's important to know, or at least these days everyone can Google your surgeon. Google your surgeon, ask ChatGPT whether they have a presence nationally, and do they know how these guidelines are evolving. And why is that important? It's because if things are evolving in Japan and our patient fits into the same category, we shouldn't be hiding or not being aware of those new discoveries, and we should apply those to our patients. Experience, you can easily ask them or search on the website for the cancer center. It typically depends on the center because it's a rare disease. So it's not like you do one every day. The volume is just not that much, but just the comfort level and how much resections in the institutions have performed. I think that's the kind of thing you should ask questions related to that when you're seeing your surgeon for the first time. And also ask them a little bit more about the margins, or what are the things they will be looking for, what to expect on pathology. That just tells you how much they have thought about it or how much are they aware of the guidelines. Relationship is going to be the key. So how you relate to the surgeon. And most of us are really good at doing a really good job explaining, but we're also fortunate to have our team members like nurse practitioners, physician assistants, who you can reach anytime, even if you can't get a hold of a surgeon or a medical oncologist, and they would address a lot of your concerns. And finding a tertiary care center or a big center where there is a cancer center ideally affiliated with the hospital gives you the best access to clinical trials and most high-end procedures that are out there now. But I mean, it's important to figure out a way to coordinate your care between your local team and a cancer center where you're going to be getting your surgery. Now, remember, all surgeons have complications, so there's data out there where you can see if surgeons have certain complications or from procedures. So the most important thing is, yes, there will be a complication, but do they have the capabilities to manage it? So if you're in a small hospital, the GI team might not be comfortable going in to stent across a leak or something, but there are procedures that we can do at a tertiary care center where we can manage those complications without the need for another big operation. And a lot of those things can be managed endoscopically. Okay, I just have to end with this. It's an English proverb, which I'm sure you guys will understand why I'm saying. For a surgeon, look for 3 characteristics. Okay, I'll be happy to take any questions. Thank you for your attention.
Since we're running a little bit behind, is it okay we hold questions at the end? We'll have our discussion. You'll be around, Dr. Pani, right? Okay. And then I guess our last speaker for this session is one of my partners in medical oncology, Dr. Patrick Grierson. He's assistant professor, Division of Oncology. He's going to talk about clinical trials here.
So the button is Hey, good afternoon. I'll be relatively brief. We're a little bit behind, but so a lot of these slides are a little bit more high level. They're not real nitty gritty. I wanted to give kind of a good experience to all the patients and family, in the audience. So generally speaking, a quick overview of clinical trials, partially what trials we have and a little bit more of what are trials and how do they come about. So let me see, do I sit down? How do I advance? Is it down or over?
Interesting.
Click. There we go. This is a real big kind of 101 slide, just get everyone on the same page. So kind of cancer drugs one-on-one, right? Oftentimes when we talk about treatment for cancers, we use the term chemo very loosely, but there's some more technical verbiage to kind of go over. So chemotherapy specifically are cancer drugs. They kill cancer cells. They're generally toxic drugs. Many have been around since the 60s or later. There's many of them. I won't get into all of them, but generally speaking, they're drugs that work broadly and kill cancer cells. They're tailored to different kinds of cancers, but as a whole, they're broad drugs that kill cancer cells. Then we get into what's called immunotherapy. These are drugs that work by kind of turning on your own immune system. So your immune system is no longer blind to the cancer, and your immune system can seek out and kill the cancer. So it helps your body fight your own cancer with you and for you. In contrast to chemotherapy, when we talk about gastric and esophageal cancers, the immunotherapy drugs we have at present, there's 10 or so are FDA approved. The first approval was only in 2019. So we're only talking about 6 years since the first approval of an immunotherapy drug for gastric and esophageal cancers. That really speaks to how young the field is and why right now we're on a very kind of exponential uptick in the science and the clinical implementation of the science. So this is a very new emerging field. Targeted therapy, we've already touched on a little bit. These are drugs that target a protein or a marker on the cancer and kind of turn off the cancer or thereabouts in some particular way. A marker is HER2, another is the CLDN 18.2 or Claudin, another is VEGF. They all have their kind of cognate drug that hits that target and blocks the cancer from growing in some capacity. The final thing, which is much more on the cusp, is cellular therapy, also called CAR T cells. It stands for chimeric antigen receptor T cells. I'll get on, there's a slide later on this, but these are generally cells that are more or less usually the patient's own immune cells that have been taken out of their body, genetically modified in the lab, kind of revved up, so to speak, and put back in you to kill your cancer on hyperdrive. These also can be done kind of off the shelf with a generic drug, but oftentimes it's your own cancer cells that we're tweaking. So how are new drugs developed? One quick slide here. Research and clinical trials is how this happens. So research starts in the lab with preclinical research. We would call it bench research. Cancer cells in a petri dish or animal models, usually mice in this day and age. This is really where new ideas are come up, new ideas are tested, and real new breakthroughs are made, and scientific advances are really made, at least conceptually. Then once we have something through the lab or coming to clinic, then we do a clinical trial. Clinical trials are in 3 phases. There's phase 1 clinical trial. This really means first in human, right? First in man, first in human. The goal is to establish how safe is the drug? What side effects does it cause? Is there any sign of that it maybe works? And what do we think is probably the good dose that's going to be feasible here? Once a drug graduates phase 1, then it moves to what's called phase 2. So this drug has been tested for safety. We know what the side effects look like. We generally know that it has some effectiveness. And now we're trying to get more of an objective assessment of really how effective do we think this drug is. If a drug clears phase 2, we get into phase 3. Phase 3 is where the drug is pretty much put head to head against the current state of the art. So if we have the current state of the art, treatment, whatever it needs, whatever it is, when we have a new drug that gets to phase 3, we're oftentimes comparing it side by side and saying really exactly how good is this new drug? Is it kind of better than the best? Is it good enough to become a new FDA labeled drug? From the lab through phase 1 through 3 is usually about a good 10 years or so. This takes a lot of time and a tremendous amount of resources and money. So, and we're stuck again. Here we go. So this is another kind of schematic. This is not to be kind of scrutinized, but generally speaking, in the lab, someone comes up with a concept in their mind. They do some experiments that seems to kind of hold weight. They test it in animals, usually mice. When they combine drugs 1 and 2, they find that drug 1 plus drug 2 shrinks tumors a lot more than either one and a lot more than no drug. That's a real kind of simple assessment of how do we think these things are working in the lab. And then we move that into a clinical trial. This is a generic clinical trial schema where we're kind of showing in kind of a schematic format how we're going to use the drug with a standard chemo cocktail. We'll prescribe the dose levels that we're going to do with the drug. And then we have kind of a program of how we're going to enroll patients and get biopsies. What's really important to keep in mind is that all of this is more or less over years a circle, right? It comes and goes and comes and goes, meaning that when patients are on a clinical trial, we are often getting biopsies when they start and then a biopsy a couple months later. The reason is based on this science up here, we're pretty sure we think we know how the drug is going to work in the person, but it doesn't always materialize. So during the trial and at the end of the trial, we get a tumor biopsy that frequently goes back to the lab and we can assess, did it really do what we thought it was going to do? Did the drug do what we thought it was going to achieve? And if not, perhaps how and why? And once we get that how and why, that leads to version 2.0. And now we have a new drug and we cycle it back through. So this is kind of the cyclical nature of clinical trials in general. Let me see, here we go. So the last couple of slides are just some select trials at Siteman. Somewhat high level slides here, but generally giving you kind of an overview. So the first thing to kind of state about clinical trials is trials are always positioned at a particular point, right? So if we look at someone's journey, so to speak, they're diagnosed here. Hopefully we're going to surgery. If they don't go to surgery or after surgery, the cancer may come back or spread. These are all different frameworks. These are all different scenarios. So we have clinical trials, each of these green boxes, at different places depending on where we are and what we need to achieve. So for a lot of these cancers, we start off with radiation or chemotherapy before surgery. So we have a trial here by one of the radiation oncologists where we're doing a modified radiation plan with chemo before surgery. Also, like the radiation oncologist mentioned a few minutes ago, is there's 2 different natures of radiation. There's proton and photon radiation. We have a clinical trial where we're testing proton versus photon radiation to determine which one is better, what are the side effects, and what are the outcomes. If patients clear surgery, hopefully we never see the cancer again. But if we do see it again, now we're talking about metastatic or stage 4 cancer. If someone is receiving their first chemo program, we call that first-line treatment. It's their first program they're seeing. We have several first-line clinical trials, one of which I'll go into next is homegrown entirely in terms of its scientific discovery. Another one comes from a pharmaceutical collaborator, Henlius, that's using another chemotherapy combination with that HER2 targeting. If a patient receives one of these and then their cancer still grows and spreads, now we have other second-line clinical trial options. These are all positioned in a specific point for good scientific and kind of medical rationale as to why you should get A before B, for example. If we still have more cancer growth, then we can get into third-line, second-line plus trials. Some of these I'll touch base in a little bit here. A lot of these trials are chemotherapy-based, but the second-line plus trials that we have specifically that I'll delve into are some of what's called CAR T-cell studies. They're more advanced, they're more scientific, and I'll touch base on that. So one of the trials I'll kind of jump into specifically, and you can kind of see how, if it goes, kind of the thought is that Dr. Jin mentioned, more than once about our chemotherapy programs, the chemotherapy called FLOT, and we do what's called perioperative chemotherapy. Peri means around. So the standard approach in this current era is that patients may get the FLOT chemotherapy for 2 months and then surgery and then 2 more months of chemo. Other patients, for various reasons, may get more of a chemo radiation alone and then surgery and then you're done. This is generally a very standard paradigm. One of the challenges that we see in the field is after undergoing surgery, patients are not doing quite as well as they were when you met them. So chemotherapy is challenging. As many of you know, the surgery is challenging. And although we intend to give people 2 more months of chemo on the backside, nowhere near 100% of people are actually able to get that. Maybe 30 to 60% are actually getting it. So one clinical trial concept that's kind of come up between one of our radiation oncologists is to do a total upfront program. We call it total neoadjuvant, or TNT. So a clinical trial that we're going to be launching in a couple months here is going to be starting off with 5 days of high intensity focused radiation on the tumor in the stomach, and then doing all of the FLOT chemotherapy ahead of time, and then doing surgery, and now you're done. So the concept of this is to more or less rearrange the parts of what's been done for many, many years, using the same tools, but putting them in the front, in the thought that if we do it all at the beginning, we'll have more people that complete all of the planned chemotherapy without having complications and having to cancel it. And we may actually have better cancer control by hitting it with radiation and the super high potency chemo that we use. This is kind of a concept of what I would call a high-level clinical trial. We're not using new drugs. We're just simply kind of rearranging the pieces with a good kind of rationale to improve success rates. This trial is much more the opposite, which is trying to identify a new drug that might increase success rates in these cancers. So this is not so much rearranging the tools. This is more, can we find a new drug that can lead to somewhat of a soft breakthrough, so to speak. So this is a clinical trial that was pioneered. The science of it is entirely by one of our scientists here, Dr. Kian Lim. And what this is a clinical trial where we're using standard chemotherapy called FOLFOX, an immunotherapy called nivolumab or pembrolizumab, and an oral drug called CA-4948. This is for people that have stage 4 or metastatic esophageal or gastric cancers. And this is the laboratory research that was done here, where this is a survival plot of mice in the lab. So if you look over time, from day 0 to 70, all the mice start off living and now they're no longer living. This is what happens when you leave them alone with their cancer or give them some of the standard treatment options. When you combine that standard treatment option with a newly discovered drug, now the survival curve is more this red line. So this is some pretty exciting research we've done here in some of these gastrointestinal cancers as such. With that, we've launched a clinical trial that's really actually only going on here at Siteman. in esophageal and gastric cancers that are stage 4 metastatic, where we're doing more or less this. So we're giving patients the standard chemotherapy called FOLFOX, combining it with the immunotherapy called nivolumab to kind of rev up the immune system. And we're adding on an oral drug called CA4948. This is a drug that's going to help the immune system see the cancer and fight the cancer. And it also helps weaken the cancer so the chemotherapy can kill it better. So it's hitting it in a two-pronged manner. And what we're doing is we're giving patients escalating doses of this drug and treating them with it, getting biopsies and following their scans. This specific clinical trial is still ongoing. It's not yet published. We've been doing it for about 2.5 years. And so far, the comparator statement is that for most patients that get this treatment can usually hold patients' cancer at bay for somewhere on the order of 6 to 9 months or so before it grows. We've had patients where the cancer has not grown for 2 years on this trial, and it had actually gone into remission for a time, which is quite remarkable. We need to treat more patients in that capacity, but so far this is looking exciting, at least to our eyes. But again, this is considered a phase 1 trial because it's considered first in human, okay? If this continues to go well, it may become phase 2, phase 3 in the future. The next slide is on CAR T cells. I won't really go into the nitty-gritties, but just to kind of get a flavor of what these are. They're getting a lot of press and a lot of news these days for good reason. So CAR T cells are essentially genetically modified cells that usually are your own. So what happens is we have a patient and we do a large blood draw to remove some of their immune cells. We send it to a lab and they're genetically modified to seek out a cancer with high kind of aggressiveness, so to speak. In the lab, these cancers are multiplied to the millions. And then we have them shipped back and infused into the patient. And now the patient is receiving their own kind of native cells that have been kind of amplified and activated to seek out their cancer. And the goal is that these cells in the patient will seek out and kill their own cancer. So this is a concept that's been going on for about 15 years or so in leukemias and lymphomas. It's very, very new in solid tumors. None of these are FDA approved for gastric and esophageal, but these are exciting things. The way that these are done is the cells are essentially programmed to seek out a specific target on the cancer. So there has to be kind of a target or a bullseye on the cancer that the cells are geared to attack. One of them is an oncogene called KRAS. So KRAS is a notorious kind of gas pedal that fuels cancer growth. One clinical trial called NT112 is using these cells and modifying them to attack KRAS. Another one is modifying them to attack what's called HER2. Another one is modifying them to look at other various surface markers on the cancer called mesothelin or EGFR. These are not pioneered or developed at Siteman. These are large pharmaceutical companies that were one participating site. So this is kind of an exciting thing that's kind of on the cusp. We do have some of these that are available, but they're not FDA approved, but you'll hear probably much more about them in the future. So one quick summary slide, I think we're short on time, is generally speaking kind of some high points, take-home messages for clinical trials is they are a developmental process in which we develop new anti-cancer drugs. It's a slow, methodical, scientifically driven process. We view it as a process to provide patients early access to late-breaking new drugs, right? Because a lot of drugs might take 5 to 6 years to go from phase 1 to phase 3. Many patients have already been on it for 5 years once it gets FDA approved. So they were benefited by having that drug 5 years ago. They're generally orchestrated at large universities and cancer centers. You're not going to find these much in small, single operation community cancer centers. And again, they're positioned strategically at different steps along the cancer journey. Are you newly diagnosed pre-surgery? Are you post-surgery? Or are you dealing with a stage 4 metastatic cancer? And is it your first, second, or third line? Clinical trials are also very strict in terms of patients that we can enroll in them. We need patients to be of a certain good kind of physical performance status, as we call it. They have to have the right cancer type. They may need the right molecular marker. They have to have good kidney function, liver function, heart function, et cetera. So there's a very stringent process of scrutinizing someone before we can put them on a trial. So I say that in the sense that oftentimes we're disappointed that we can't offer someone a trial, but it's all in the name of safety and appropriateness that they're likely to benefit in a safe manner. That's the whole overarching theme here. And lastly, your oncologist always has this in their back of their mind. Every step along the journey, we're always weighing what are the standard FDA-approved options? What are the clinical trials? Is it likely to be helpful, risky, and how's that going to go for this patient? And that's kind of how we decide if we should or shouldn't offer one at a particular time. So that's really it. It was kind of high level, not real nitty gritty. Hope it was helpful. I think we can take questions.
I think we're going to go to our discussion. If I know we're about like 2-3 minutes from lunchtime, if we can do like a maybe 5-10 minute discussion, that'd be great. Can Dr. Pani, you want to come down here and maybe we can put Dr. Vlasic back up? But I think one of the discussion points, and we've kind of talked about, is this changing landscape of how we treat esophageal cancers. Perioperative chemotherapy is now, possibly the standard. It's shifting away from that chemoradiation. So can we go on to the next slide? So here are some kind of discussion points, and I don't know if Dr. Vlasic is on, but maybe he can talk about dosage of radiation. This cross trial that was the comparator only used about 41.4 gray. Can you talk about, what we actually do in the clinic and how does that kind of change that data? Might not be on. So I guess if he's not on, I'm just going to keep this moving then. I talked about the path CR rate. So that is just one measure. And Dr. Clifford Robinson and Dr. Pam Sampson really made a point that that's not the end all be all, that in addition to cutting out the tumor.
Hey, Dr. Jen.
Oh, hi.
Yeah, sorry. I was waiting to get unmuted.
Oh, okay. Yeah, please, Dr. Vlasic. We can't see you, but we can hear you. So you want to talk real quick about kind of the dosages?
Yeah, sure. So, in the preoperative setting, sorry, I'm going to mute my side. The cross trial, they had, and I kind of alluded a little bit to this in my talk previously, but their dose was 41.4 gray, which is a lower dose than we would normally do in the definitive setting, with the thinking that these patients are going on to surgery. So, it's less about complete tumor ablation than it is about, cleaning up the surgical field and allowing for, a margin-free resection. But other studies that looked at radiation treatment in the preoperative setting have had variable radiation doses, with different dose and fractionations. But we typically will just sort of land on our definitive dose, whether in the preoperative or in the definitive setting at 50 gray, so slightly higher than the cross regimen, because that's where we can get better local and regional control in case they don't go on to surgery. As I sort of mentioned a bit in my talk too, we looked at whether we can escalate the dose of radiation therapy primarily in the non-surgical setting, and we haven't seen any additional benefit, but more toxicities in that space. And so we're still kind of deciding as a field whether that's something that is really meaningful or not in this disease site. But those are kind of where where radiation sort of kind of fits in as far as the dose and fractionation.
So I think we talked about this slightly earlier, and nationwide for esophagectomy, there's been a push to do more minimally invasive surgery. As you saw, the outcomes are just
the long-term outcomes are the same, but the perioperative pulmonary complications are certainly less, and there's less morbidity for the patient. A lot of surgeons nationwide have tried to work within their institutions even before the ESOBEC trial came out to avoid preoperative radiation in those patients, in part because making the conduit is slightly different, open versus robotic or minimally invasive, and in order to decrease a leak risk from the radiation field. And then also the ease of the operation is much better, or easier, not always, but sometimes without radiation. So there is some push in multiple centers now that we're moving towards minimally invasive resection to try to avoid radiation. And that kind of correlated with this ESOBEC trial coming out. So for us, I will say, I think it does make the operation easier without radiation, and it makes our ability to do a minimally invasive resection more easy as well. So that's the one surgical standpoint with outside of PCR discussion.
I completely agree with what Dr. Brandt has just said. For the gastric cancer specifically, radiation doesn't, in the pre-op setting, is not even something we talk about for the right reasons, because it just doesn't cover the field unless we know that we will not be able to do the surgery. But for the G-junction tumors, I think one of the complications nobody wants for any of their patients is a leak. And that is what Dr. Brandt is referring to, especially when she says it's easier. It's easier not just for us, it's easier on you to not have that complication and recover and go back to your treatment. I've noticed that chemotherapy is typically pretty well tolerated. And I actually, nationally, the trend is now moving towards the TNT approach. Previously, we used to do half chemo before, half after. But after a procedure like total gastrectomy, there's quite a bit of adjustment to your new lifestyle on how to eat and portion size, water, and all of those things. Everything is completely different than what you used to do before. So for my own patients, I have noticed that it's well tolerated when you have your stomach and the luxury to eat whatever you want when you're getting through all the chemo. So unless you have side effects where we have to really stop the chemo, preferentially finish everything beforehand and then come for your surgery. So after the surgical resection, all you have to worry about is getting used to the new lifestyle of eating.
So this kind of highlights what Dr. Pani has talked about, and Dr. Grierson really highlighted this. So this is from that ESOPEC trial, but basically 35, almost 36% of patients on the back end weren't able to start that postoperative chemotherapy because of various complications, or just the patients didn't want to. Dr. Grierson, do you have anything to add to your experiences with perioperative FLOT or FLOT durvalumab?
No, nothing too.
Yeah.
Nothing too notable. No, I think that moving towards the kind of all front or total neoadjuvant approach is probably the best, right? You have a better rate of getting all the treatment done beforehand, less need to do it afterwards when you're dealing with other challenges. And adding the immunotherapy, I think, is clearly the way to go. The outcomes are unanimously better that way.
I think one final point, we're running really, really short on time, is kind of patterns of failure. So, how do these two regimens, when they do fail, how do they fail? So we can look at the FLOT regimen here, and this is heavy chemotherapy. So most of the patients who fail are going to have kind of, when compared to chemoradiation, they're going to fail locally. So they're going to fail kind of where that primary tumor is. It's going to grow back. But so that's where kind of the strength of chemoradiation, it does probably a better control of local control. But where, that cross or chemoradiation really fails is kind of when it does fail, most of the failures are distal. So that chemotherapy given with that radiation is less strong. So those patients kind of have metastatic disease on failure. So I think I'm going to just kind of close here with a final slide. As Dr. Grierson kind of mentioned, addition of immunotherapy. We talked about kind of the safety side effects. And I think the important thing is, we can't treat this as kind of absolutes. It's great. We have to individualize these treatments for the patient, and we have to have discussions, multidisciplinary with the surgeons, with the radiation oncologists, and with medical oncologists. So thank you. Lunch will be served. Oh, please join us. We're going to have some posters up from our basic science labs, mine, Dr. Sands, and Dr. Brown's. Please come talk with us. And we'll be back here at 1. Hopefully all go peacefully for sick. Yes.
Sorry, wait a minute, I'm gonna start right now. What? All right, I think people are filing in. We'll get started with the kind of afternoon session here. So the first speaker for the afternoon session is an honor to have them here with us. It's Pat Jochum, the head coach for the WashU boys basketball team.
Sure. Well, absolute pleasure to be here. And I want to thank Siteman, Dr. Jin, everyone who was involved with pulling this together. As the men's basketball coach at the university, it is my life and experience has intersected with what you all do through a young man by the name of Justin Hardy, who played for us at WashU, developed stage 4 gastric diffuse stomach cancer in spring of 2021, and had kind of a remarkable story. Unfortunately passed away in May of 2022. And I believe we have a video kind of to introduce, and then I'll have some remarks after that. So let you see the video.
In every basketball game I've ever played, right? I'm not sure I've ever stepped on the court where I thought I was going to lose. This was a game I was getting into that I didn't think I could win. But I think my definition of win was a little skewed. The first scar I got was from the perforated ulcer I had back in April.
You cannot be average today, and you should be bloody. You should be scraped up, okay? You should have holes in your jersey like Hardy does. Puts holes in every jersey that he has. You should just lay it on the line.
Second thing I got was this Metaport here. What is my story? Where do you even begin with that?
In 2018, Justin Hardy arrived at Washington University in St. Louis, a perennial Division III basketball power.
This is a 215-pound machine. And when I watch video of our team from 2 years ago, he just stands out.
He was the rookie of the year. He played like one of the best players in the country, and he was for sure going to be an All-American, no doubt about it in my mind.
But during Hardy's sophomore year in 2020, Washington's season was cut short by COVID. Then his junior season was canceled altogether. Last April, in the best shape of his life, he awoke to a searing pain in his stomach. Doctors discovered a perforated ulcer, performed surgery, and then discovered something else.
They felt very strong that they had observed signs of cancer. I was sure they were wrong. It just couldn't, I just figured they made a mistake and pathology would show that it was something different.
Doctor came in and she goes, I got the pathology results back. You do in fact have cancer. I'm sorry, this is probably the worst day of your life. there is no cure for stage 4 stomach cancer right now. And I'm being put into this game that I've, in theory, 0 chance of winning. Yeah, give me 1 second.
The initial prognosis that he received was likelihood of 12 to 18 months after diagnosis for survivorship.
Beginning last June, Hardy underwent a grueling protocol of radiation and chemo treatments to battle the stage 4 cancer. In only a few months, those treatments had reduced the once 215-pound basketball machine to as little as 165 pounds.
He looked like a shell of himself. He couldn't move. He was weak. His voice was weak, and it just wasn't the same Justin.
We're our best version of ourselves when he's with us. Our hope is that he could just be here physically for his senior year. I didn't think there was a basketball future for him.
Hardy had other ideas. By October of last year, he was practicing with the team. By November, he was in the starting lineup.
We're gonna wait for Hardy. It's up and good. Justin Hardy.
By December, he was dunking.
Hardy down the lane strong. Jams it home from the free throw line.
And only a few weeks ago, he tied a career high of 28 points.
And it's made. Justin Hardy. What can't Justin Hardy do? Might take a while to figure that one out.
He played like the best player in the country. Yeah, I just smile because I'm like, I know what I'm witnessing right now is something that's probably never happened and probably won't ever happen again.
There was no piece of me that was going to half-ass this. If I was going to do this, I was going to do this.
Memory's playing some good defense here in the first half. Hardy, though, finds some room from distance, and he splashes one home.
With his family watching from the stands, the 22-year-old Hardy struggled to get through a recent game. His condition worsens each day, a byproduct of an unrelenting cancer that recently spread to the lining of his colon.
It's pills every day. It's treatment usually every other week, where he can't really feel his feet or his hands. He has other things that pop up that he won't even tell you about because that's just Justin, but it is every day for him, every single day.
I can't control the spread of the cancer inside of me, and that portion is going to do what it does, and it might be further away than I think it is, but it's definitely closer than I want it to be. This is beating it. This is me living my life regardless of the circumstances. If this isn't beating it, I don't know what is.
Standing of this remarkable young man in Justin, and I'm here representing his family, his parents, Bob and Karen, his siblings, Jackie and Nathan, along with the foundation, the Hardy Strong Foundation that was founded after his passing. He accomplished so many remarkable things in his life, but his story truly is about how he consciously chose to live with cancer. A couple things once he got the diagnosis and once he grasped and processed it, he was intentional about a couple things. Number one, he gave up the idea of perfection. He was no longer afraid of failure. And he said, even if I'm perfect, the world around me is not. Even if I don't reach perfection, it's worth striving for. The second conscious decision he made was to eliminate negativity from his life. He chose to be, I'd never heard this before he said it, relentlessly positive. He chose to be relentlessly positive. Negativity could not consume his thoughts. He looked at all circumstances with an optimistic viewpoint. He set out a couple goals after his diagnosis. One was to graduate from WashU's Olin Business School. When he was diagnosed, it was in his junior year. He did that. He came back. He graduated a semester early. with high academic honors. He had just secured an internship with McKinsey, and his goal was to complete the He completed the internship of McKinsey while he was undergoing treatment and got the return offer, which is amazing. And then his third is to continue doing what he loved to do. And as you can see in that video, it was to play basketball at WashU. You saw that, the effect of his treatments. We never would have fathomed, like, as I said on there, like, I just hoped that he could come back to school and be with us. Never did I think that he would actually play again. And the fact that he not only played, but he played really well, I think it should be a movie, quite honestly. There were some times where he'd have treatment, like he'd be here in Siteman on a Monday and Tuesday getting chemo treatment. He'd come to practice and observe on Wednesday. He'd participate on Thursday, and then he'd play in a college basketball game on Friday, and he'd play really well. And it's still astounding even to say it. His story became a national story. That piece certainly helped get it out to the world. He started interacting with some of the biggest names in sports who were inspired by his courageousness and his positivity. And the national recognition he received allowed him to share his story and positively impact countless others. I do have a story about his time getting treatment here at Siteman. He developed a close relationship with his oncologist, Dr. Haesong Park. Dr. Park had never been to a basketball game. I don't think she knew what basketball really was, but she was so intrigued by what this guy was doing that she came to watch him. And I think she brought an assistant with who knew a little bit something about basketball, who could kind of like interpret what was happening. But she was, I think, dumbfounded what he was doing while in the shape and going through the treatments that he was going through. But that personal touch, I know it meant so much. And just talking to his parents, Justin's parents here recently, again, they brought up that story, how much that he was cared for as a patient. He was more than a patient. And that really, really, really was meaningful for that family, for the Hardy family. After we lost our final game, so we lost in the NCAA tournament in March, and those are somber situations, right? Your season's ended. We had a bunch of seniors, their career's over. Justin's career was over. I always allow each of the seniors to say kind of what's ever on their heart. And Justin went last, and he thanked his teammates, and he proceeded to say the following, and it's incredible. He said, guys, this was my favorite year of my life. And it changed the whole environment from this sad to, wow, talk about putting it in perspective. And he said, the reason I got up every day was to come to be with you guys and to do this. And it was really something also that he became extremely others focused. He poured into other relationships, old ones, new ones, people we weren't even aware that he was interacting with in a time where he should have been so selfish. He was concerned about everybody else, which is just truly remarkable. And he uses this phrase that he chose to write his story from the front cover to the very last page. After Justin's passing, his legacy continues to evolve, and the impact grows daily. The Hardy Strong Foundation was started in 2023 with a three-part mission. The first, to increase the awareness and support of hereditary diffuse gastric cancer. And I can say, just having the chance to interact with Dr. Guilford, thank you. Thank to all of you that are part of this, tackling this and attacking this on the front lines, but to have a chance to meet Dr. Guilford, know that the foundation is very supportive of his work and will continue to be. Second, to provide resources, improve access to genetic testing for cancer risk. And finally, to honor the legacy of Justin through scholarships for exemplary scholar athletes. In less than 3 years, the foundation has awarded numerous scholarships to graduating high school students, has supported researchers in the front line of stomach cancer research, and has begun partnering with companies involved with genetic testing. While we are all devastated by his loss, his impact is evolving and undeniable. Thank you for the opportunity to share his story, to share his legacy on behalf of his family and in the foundation. And just know that we're humbled and we are excited about the future and supporting the great work that's being done. So thank you.
It's difficult to follow that up. Of course, that's very impactful. We cannot thank you enough, Coach. And of course, to Justin's family, it means a tremendous amount to everybody. So no more comments. The next up we have is Julie Richardson, a social worker, who will kind of go into some of the details of that aspect of cancer care for our patients and their families. And Barb, of course. Sorry about that. And Barb.
Boy, that's going to be tough to follow. What a story about courage. And I had heard his story before I started working at WashU, and it gives me the goosebumps every time I hear it. So thank you so much for that. Barb and I are here today to talk a little bit about some social work resources that are available to our cancer patients. We work in the satellite offices of Siteman. You know, as you guys all know, there's the main building, and then there's West County where Barb works. I work in the Illinois side, so I work over in Shiloh. So there's a vast difference between Illinois and Missouri, which we'll see a little bit getting into some of these slides. But what we're going to talk about today is just some of the services that we have available. There we go. One of our main roles is to help, the patients, families, and caregivers to cope with the distress, the challenges, a lot of things that come up with cancer diagnosis and treatment. You first hear that word cancer, it's pretty overwhelming. I can't tell you how many times we get patients that come in, and it's like they had a biopsy. Well, they found a tumor, they had a biopsy, they went for a CAT scan, they had a PET scan, they're meeting with an oncologist. All of a sudden, the oncologist wants them to meet with a surgeon. They're meeting with a surgeon, they're having treatments. So we get them when they're at their most vulnerable. So what we try to do is we try to help remove some of the barriers to the treatment, and to provide them with a lot of not only emotional support, but also some emotional transportation, just a lot of different support that they need. And during the visit at Siteman, you can ask your doctor, nurse, any care member to contact a social worker for you. And we have social workers available on site every day. Now, like today, Barb and I are both here, so we both have somebody covering remotely for us. So if we're not on site, we always have somebody available, Monday through Friday, or, during regular business hours. And next. Okay, you did that. Oh, there we go. One of the biggest parts of the social work concept is to get to know our patients by a psychosocial assessment. The assessment was kind of hard to put on the screen because we tried to fit it into one page. But when we're typing, this is almost 5 or 6, 7, 8 pages long. So what we did is I developed this thing where it's almost verbatim of what the assessment looks like. It goes anywhere. We want to know their name, their MRN number, because, sometimes we don't put their name, but we'll put their MRN number for privacy. What is their diagnosis? Who is their doctor? Just real quick things that we can take a quick look at. Are they alert and oriented? do they have a power of attorney? That's a very important thing, you know, because as they go through their journey, we want to make sure who can we contact if there's somebody if they're not alert and oriented. Do we have any concerns about abuse? You know, it could be physical, emotional, neglect, anything like that. You know, are we concerned about domestic violence? If so, what kind of services did we refer them to? Did we refer them to, like in Illinois, they have the domestic violence center. Missouri also has some services. Who do they live with? Do they live by themselves? Do they live, you know, with their spouse? Is their spouse supportive, not supportive? You know, what are their barriers? A lot of people don't come to treatment. Why? We want to know why aren't they coming? Is it distance? We all know that people are traveling not just a half an hour, but 2, 3, 4 hours for treatment. And if if they can't find a ride, that's a big barrier. So what can we do to help some of those barriers? Who are their support systems? How are they getting the help that they need? Insurance is a big one. Are they Medicare, commercial insurance, Medicaid? Medicaid is a little iffy nowadays. Do they have the managed care insurance through Medicare? Those are even getting difficult. We found out some Medicare, like Aetna is a perfect example. They used to provide 24 round trip rides for patients. We heard a rumor that effective January 1st, they're going to do away with all the rides for their patients. So what does that do? That's going to provide another barrier. And so how do we, as social workers, help bridge that barrier? And feel free to jump in anytime, Barb. I feel like I'm monopolizing here. Do they have problems getting their medications? Some of the medications are $42,000 a piece, and that's for the oral drug. That doesn't include the chemo. My husband happens to have head and neck cancer, and he is getting Keytruda. His Keytruda treatments are $44,000 per treatment. Luckily, we're poor enough to fall within the criteria of getting some financial assistance for the medications. So medications are a big thing. If they can't afford their medications, they're not going to take it. And so we work with trying to help bridge the gap for some medications. Eliquis is a big one for some cancer patients. Employment status. We just like to know, are you employed? Are you working during your treatment? Are you unemployed? A lot of people are employed full-time but can't work during their treatment. So what do we do then? So we try to problem solve with them. And we'll get into that real quickly in a minute. Are they able to meet their financial needs? Are they independent in their ADLs? Do they use a cane, walker, wheelchair? Sometimes that's important because not every place is handicap accessible. So we want to make sure that they have what they need. The biggest question I love to ask, because not everybody is forthcoming, but at the very bottom it says, what do I need to know to take better care of you? And that statement, to me, it's an open-ended question. Some people may say, I don't have any needs. But then there are others that says, you know what? I have a 5-year-old at home. I have grandkids. I don't know how to talk to them. I don't know what to say. I'm really struggling emotionally and I need help. Well, luckily, we have some services that are able to, that we're able to refer them to. And one of those services that we have is we do have support groups. And I was going to bring a list of all our support groups and I forgot them. But Illinois has a support group the third Monday of the month. It's for patients and their caregivers. What we do is it's for all cancers. It doesn't matter if you have breast cancer, colon cancer, if you have brain tumors. What we do is we have an educational component at the beginning, where we have speakers come in. And then after about 40 minutes, we break up. The caregivers go with me. The patients go with our nurse practitioner. So, because I don't know about you, but a lot of caregivers don't necessarily feel comfortable talking about their loved one in front of them. And a lot of patients don't feel comfortable talking about the frustrations of, well, the caregiver's pushing me to do this, and she's pushing me to try this, and she's making me eat, and I don't feel like eating. So we separate. So I take the caregivers and she takes the patients, and it's worked out really well. So that they can, it's kind of a safe haven for both entities. And so we meet together, have our educational component, and then we split up. And then we'll,
Get this.
oh,
You
it's
had a
not.
touch.
Here we go.
Looking.
Oh,
You have to use the mouse.
Ah, there we go.
the mouse.
There we go.
The handy dandy mouse. That's
You.
what we got it.
Wonderful.
We broke it.
Just say
Okay.
next slide and I'll advance.
Oh, okay. Well, next slide.
Thank you.
This is why you always bring an extra copy. We also refer to our psychology department for the psychosocial. They offer for the cancer patients 8 free sessions, where they can talk with them about how they're coping, with their diagnosis. We have the support groups. We also have the cancer community support group, which is they just moved. So they're in
They're,
Westport now. I think?
Maryland, yeah, Maryland Heights. So it's a pretty good central location. And they do so many wellness type of groups, as well as diagnosis related coping strategies. They do individual as well as group counseling. So it's nice because the patients have options. I often find I come up with a packet for people when they're looking for what support is out there, and I'll just kind of get to know them, where they live. They're looking for in-person or telehealth type of counseling. And usually I'll have about 4 or 5 options, which is great. And they're, free. And I think, as we know with social media, that's been quite helpful for a lot of our patients, because Facebook will have a lot of good support groups as well. So we try to make sure we give them those sites and that information that's easy for them to access.
And a lot of our patients prefer the Zoom meetings also, because they don't have to travel and it's easier for them, just to get on a computer, and they don't have to be quite as talkative if they don't want to be. So we found that the cancer community, the support community, has been really good, because they do a lot of Zoom and in-person meetings.
Stress management. That's something that we do, I think, in the moment with our patients. I know where I work, my office is in a very convenient location. There's the waiting area. The doctor's offices are right behind me. And I may have someone they're just waiting to get called by their doctor, or they just got their scan and they're waiting to talk to their doctor about the results. And they may come in my office. We just do some good deep breathing, reassuring self-talk. And a lot of times just helping them, cope in the moment. Family members also come in sometimes and talk to us social workers. They may not have that other person to talk to, and they just want to vent, and we're here for them for that too. So advanced directives, like Julie mentioned, I think that's something that a lot of the nurses look at as well on the chart. They'll see do they have one or do they not? If they don't, we have paperwork for them to complete that it's, foreign Jewish washing paperwork. And we explain what do those terms mean, help them in completing the forms, and then, have them added to their chart. And then we've got coping with return of cancer. This, I think, happens quite a bit. So we see a lot of new treatments that are effective in helping people. They, kind of go on about and return to their daily lives, and then they get a scan that leads them back to treatment. So we kind of help with that frustration or that fear that comes with that.
Food outreach is a big one. A lot of food insecurities now because the cost of groceries have gone up and the cost of everybody's social security and things and income has gone down. So we do reach out with the food outreach in St. Louis. They have a food pantry, and then they also will provide meals for patients that are currently undergoing treatment. And then they have kind of, like a food bank, a food pantry that they allow patients to go to. It's based out of St. Louis, but they also have an office in Illinois, which really helps for the Illinois. Next slide.
Next slide, please. Thank you. Yeah, this is a big one that I think it can be a really big barrier for treatment is the lodging. People drive from very far away to come to Siteman. So we try to help them with lodging. Some people may have a 7 a.m. appointment. And then they have scans, their doctor appointment, and then treatment. So they want to come the night before, get a good night's sleep, and then be, kind of fresh. So, so the Hope Lodge is a wonderful resource that is a free stay for a patient. They also need a caregiver with them to stay. So we provide the referrals for that. And Haven House they moved this year, so they're now located a little further east of Hope Lodge. So it's kind of in the Midtown area, but they are a wonderful place. The social worker does referral to stay there.
And unfortunately, they're like $50 a night, where Hope Lodge is free, but at Hope Lodge, you have to have a caregiver. Haven House, you do not.
We also we look at the Barnes Lodge, and then really a lot of the local hotels, because some people I know, if they're coming to the county for treatment, they don't want to have to stay in the city and drive. So, we try to connect them with reasonable hotels in the area. And then transportation, another big one, like Julie mentioned, we first look at their insurance, like what does their insurance cover it? And then help sometimes make those calls that can be time consuming to get those rides set up. American Cancer Society Road to Recovery is volunteer led. So those are volunteer drivers that will pick people up at their homes, take them to their appointments, and then take them home. The person, the patient does have to be ambulatory, but if they use a walker or cane, and can, manage that, they can be eligible. And then Peregrine Society is available for people that live in St. Louis City or county. They provide transportation through Yellow Cab or St. Louis Cab for up to about $600 per year. So that is a matter of, we get the patients, a referral to them, and then the staff there set up the cab service for the patient. Okay, next slide, please. Okay. So on to more of the financial needs. This is why one whole slide is for this. It's in this world we live in now, finances are tight. So we do use the Elevate team. They assist people with Medicaid and Social Security applications. That is a free service for our patients. And I'll let you speak on this part.
Which one? The elevator?
Short-term.
The short.
Yep.
Yeah, we do discuss short-term and long-term disability with the patients. A lot of times short-term disability, they may have it through their job. Other times they don't. So then we just try to we try to work with companies that may help them You know, like LSUP is a corporation in Illinois that's nationwide. They can help with disability if the patient's going to be out more than 12 months, and if they're under the age of 62, we'll you know, help them apply for disability if it's going to be more than 12 months that they're disabled. Unfortunately, if they don't have a short-term policy through their work, it's really hard to find a short-term disability. So we have limited funds available that sometimes we may be able to help them with an electric bill, with their rent. We unfortunately did not get the grant this year from the Cancer Society to provide gas cards for patients. So that has been one of our struggles, you know, because some people they can get the treatment if they can afford it, but they can't afford the gas. So, you know, so we're struggling in some ways to try to find disability for some patients. And we do help them with public aid assistance. We do refer them to like the Patient Advocate Now foundations. You know, and we have a resources on the last page, which is coming up next. We do help them apply for the BJC and the Washington University financial assistance programs, because sometimes if you're on insurance, they may only cover 80%, 70%, 60%, and the patient can't afford their $44,000 treatment. So we do make referrals, and it's based on a sliding scale fee for the financial assistance. The patient care fund is the limited funds that we do have available to help them. And then we also help with prescription drug referrals. We refer them to our patient authorization team. They design that team from the social workers who we were inundated every year with reapplications of, you know, medications. So WashU developed a brand new prior authorization team that strictly covers the injectable medications, the oral medications. So if they're on a medication every month, they can get them covered for a year as long as they meet the financial criteria. And that has been a lifesaver for us because it allows us to focus more on their psychosocial needs and the issues that they may have. Last slide. These are just resources available that we do make a lot of referrals to triage cancer and careers. Those are the two big ones for patients that are working, that if they triage cancer is good for if they're going to have a disability and they need accommodations. You know, they are excellent for telling them this is the accommodation you are going to need when you return back to work. Make sure you talk to your human resource department about this or about that. And the same thing with cancer and careers. The Cancer Society, the Cancer Support Community, the Cancer Institute, that's always the government, it's a good one. However, they're currently closed due to the federal shutdown. So their website even says, we are closed. So the information is not up to date. And then the Patient Access Network Foundation, we use them a lot for grants for some medications that we may need. And if anybody, you guys have a copy of our slides. So if anybody wants any of this information, you could probably get them, a copy. But I'm sorry, we went over time, but we just feel that it's very passionate to us, and we want to make sure that our patients get taken care of, because there are a lot of people that do fall through the cracks, especially the middle class income, because they make too much money to apply for Medicaid, and they're not rich enough to be able to afford every single treatment that they need. So that's why we are here to, try to help anybody that comes through our desk or through our office. And we all have open door policies. So if our door is open and we're in there, we love to have the patients come in and to help them as much as we can. Does anybody have any questions? And I'm sorry we went over.
Well, thank you very much. Clearly what they do is invaluable, incredibly helpful. So next is Maya Patel. We have a registered dietitian who will speak on nutritional support, which is very, very critical in these patients all around their treatment journey.
Hi, everyone. I'm Maya. I'm one of the dietitians over at Siteman Cancer Center. I am one of 4 dietitians within the downtown Siteman location that works with our patients and helps manage their nutrition and diet during treatment. We also have Siteman satellites around the St. Louis area and also located in Illinois, where we also have dietitians that help with our patients and managing their nutrition during treatment. Okay, maybe it'll stick. Okay, so as a dietitian, we monitor our patients through assessments. We get referrals from our doctors, nurses, social workers, and even our inpatient dietitians that work within the main campus. Dietitians are super helpful in terms of assessing where the patients have nutrition-related risks, whether it's tumor-induced, treatment-related, or something they've been dealing with for a while prior to even being diagnosed with their cancers. So we basically get referrals from the team and meet with our patients the day of or at their next appointment or even over the phone at times to discuss what issues in particular they're having, whether it's poor intake, appetite changes, any symptoms that they're having, whether it's GI related or just like mental symptoms they're having, their medical lifestyle factors that might be impacting their nutrition and their nutritional status during treatment or may cause an impact to their nutritional status during treatment. And we also help them connect with our social workers, refer them over to speech language pathologists, and also just help provide handouts and recipes and ideas to kind of help them maximize their intake during treatment. So like I said, weight loss is one of the most common side effects that we experience with our cancer patients, whether it's weight loss prior to treatment or after treatment has begun. Most of the times it's appetite loss because a lot of the chemos can have that as a side effect, as well as where the tumor is located can also play a role. And if they're having any other symptoms like nausea, abdominal bloating, gas, any diarrhea or constipation, edema, ascites, which can also reduce their appetite, and then chewing and swallowing difficulties that again can be present due to the tumor location or also just be induced with chemotherapy or radiation. And a lot of our patients also experience some taste changes, which does not help if they're having some appetite issues because they're not going to want to eat food if they can't taste their food. So our patients also will experience cancer-related cachexia as well. And sometimes they're not able to meet their full needs with the diet that they're currently following. So we do help them manage their intake a little bit more to help them meet their calorie and their protein needs, as during treatment, we recommend a high calorie, high protein diet in order for them to maintain their weight and also maintain their muscle mass as well. And sometimes if they're unable to meet those needs, because a lot of the times our patients are larger bodied or taller and they're not able to consume 3,000, 4,000 calories in a day to maintain their current weight, we'll need to start tube feedings or enteral nutrition. So like I said, we do recommend like a high calorie, high protein diet during treatment. And a lot of the times it's not an easy switch for our patients, especially people that are used to only eating one meal a day as their baseline or are more of like snackers and don't really eat meals at all. So really encouraging them to consume more calories, whether it's adding smaller, more frequent meals throughout the day or adding more calorically dense ingredients into their meals, such as butter, avocado, nut butters like peanut butter, almond butter, heavy cream, olive oil, things that are super calorie dense. They can sneak into something as simple as like soup if that's the only thing they're willing to eat, or their yogurt. We do have patients that are doing well nutritionally and just have diet related questions. So we do encourage them to follow a relatively healthy diet that's full of whole grains, healthy fats, lean proteins, fruits and vegetables, and also encourage them to kind of reduce their intake of carcinogenic foods like charred meats, red meats, and also kind of help them moderate their sugar intake as well, especially if they do have a history of type 2 diabetes or they are on dexamethasone during treatment, which can impact their blood sugar levels as well and lead to the development of diabetes over time. We also want them to stay hydrated. A lot of our patients experience side effects like dry mouth, constipation, and just like skin dryness. So we really do try to get them to drink as much fluid as possible. We recommend about 64 ounces. If they're having any other symptoms that might be dehydrating them further, we try to get them to drink more, whether it's through water, juices, milk, or electrolyte beverages. We also discuss food safety with our patients. A lot of the times our patients aren't aware that eating raw or undercooked foods, like having a steak cooked medium rare, can put them at risk, or having food at a buffet can put them at risk of developing foodborne illnesses. So we always encourage them to wash their hands, make sure that their foods are cooked well, or at least medium if they're doing a steak, and make sure that they're checking temperatures on any food that might induce any foodborne illnesses, and then trying to get them to not consume as many raw foods like sushi or raw eggs or raw milk or anything like that. One of the biggest things that we do at Siteman Cancer Center that really does benefit our patients a lot is providing oral nutrition supplements such as Ensure or Boost. Siteman does have a program called the Ensure program, in which we provide our patients with free Ensure throughout their treatment. So if we do an assessment and find that they would really benefit from getting additional calories and protein from supplements, we do provide them with Ensure. We give up to 6 cases, each case containing 24 cartons of Ensure to our patients every 3 months. If they are not tolerating Ensure, or if they need more supplements than just the 6 cases that we give every 3 months, we do have the Peregrine Society that we often place referrals for our patients there. They provide Boost for our patients for free as well. And they do Boost Plus, regular Boost, and Boost Glucose Control, which is especially helpful for our patients within St. Louis that are diabetic and can't do the Ensure Pluses. So yeah, like I just mentioned, we have the Ensure program and the Peregrine Society. The Ensure program is coming to an end at the end of this year, which has been a bit of conflict for our patients, but we are working pretty hard to come up with another method of supplementation for our patients. We just partnered with UHSP with their public health school to try to find a grant to help with funding and keep the Ensure program going for our more high-risk patients that are consuming up to 4 to 6 Ensures or more a day. And also getting our patients enrolled in the Peregrine Society if they just need a few bottles every single day, or as needed to kind of help them maintain their weight and lean body mass. We also encourage those calorically dense foods, and also discuss altered consistency diets, which we work a lot with our speech language pathologists to help develop good recipes and good meal ideas to kind of help make sure that even if our patients do need a pureed or mechanically altered diet, they are still able to meet their calorie and protein needs. And we also help them find smoothie and shake recipes and kind of set up like a meal program for them to make sure that they're able to not get sick of all the foods that they're eating. If they're only drinking Ensure, what can we do to make those Ensures taste different and not be the same thing every single day? And also give them a little bit more savory options, because not everyone can drink Ensure and ice cream and smoothies every single day and not get sick of it. So we try to make sure that we're teaching them how to bulk up their soups and bulk up like baby food, and try to make it easier for them to consume food that way. And then we also have a lot of patients that are older or just have a lot of fatigue during treatment. So we really try our best to encourage them to pick frozen meals or pre-prepared meals, and keep snacks at their bedside tables or in their living room on the by the couch, so they don't have to get up or work too hard to prepare those meals for themselves every single day. We also work with our social workers within Siteman to help them get referred over to food outreach, like was mentioned previously, as well as pink ribbon meals, mom's meals, meals on wheels, just trying to make it easy for them to obtain food, and also discuss grocery delivery with them to just, again, make it easier for them to have food and that not be a barrier during their treatment. A lot of our patients, especially our GI cancer patients, develop mouth sores during radiation or even during chemotherapy. So we work a lot with our nurses and doctors to kind of set up interventions for them. We'll recommend like magic mouthwash, baking soda rinses. For the mouth sore specifically, we work with our speech language pathologist to help identify swallowing difficulties and help them just like figure out what consistency diet would work well for them and how to purchase foods and prepare meals that are going to be manageable for them with that altered consistency. We also help put in enteral nutrition orders, as well as recommending like G tubes versus GJ tubes, and the tube feed regimen that they would be placed on after those tubes are placed in patient. We also help manage taste changes, which again is a big barrier when we're trying to get them to eat well. If food isn't tasting good, bland, if it's metallic or just bitter tasting, we help a lot with managing that, whether it's through improving oral hygiene, doing those baking soda rinses, or encouraging them to sip on cranberry juice in between their meals to kind of help refresh their taste buds. Dry mouth is another big one that we experience. So we recommend mouth coat, the Biotine. Sour candy has been really helpful for a lot of our patients to help stimulate more saliva production. And then just making sure they know not to do too much alcohol or caffeinated drinks, and trying to help manage their hydration again with adequate fluid intake, or even adding like citrus to kind of help stimulate that saliva production again. More symptoms, we always go into our assessments asking if our patients are experiencing any nausea, vomiting, gas, bloating, constipation, diarrhea, or even just the consistency of their stool to identify if they might need pancreatic enzymes to kind of help absorb that those fat-soluble vitamins, and also not have that malabsorption that's pretty common with some of our GI patients. We have a whole bunch of interventions that we discuss with our patients in terms of nausea. We partner and request samples from a lot of small companies. For example, we've been getting samples from the Gingin company to help with nausea management through their ginger chews and ginger lozenges, which a lot of our patients have benefited from. We recommend bland diets if they're experiencing nausea or diarrhea. We help a lot with the gas and bloating side effects, and just try to coach them diet-wise to make sure that their diet isn't contributing further to any of those symptoms that they're experiencing. And also work with our pharmacy team to kind of identify which dosage of pancreatic enzymes would be suitable for them, and also work with our social work team to kind of help cover the costs of some of those pancreatic enzymes, because they do get pretty pricey, as well as refer our patients over to Nestle if they are able to help with the cost of the pancreatic enzymes as well. And again, we do have a lot of patients that are unable to meet their nutrition needs through their oral intake, whether it's because of dysphagia, the cachexia, like I mentioned, causing their needs to be quite high to the point where they're unable to meet it through oral intake. If they have been diagnosed with malnutrition again and are unable to meet their needs through oral intake, we recommend enteral nutrition. A lot of our patients will undergo an esophagectomy or gastrectomy at some point, or have dysphagia caused by radiation treatment. So we do keep an eye on them and encourage enteral nutrition to be initiated if the patient is agreeable and we think it would be beneficial for them. In some cases, we do have patients that need TPN or PPN for a short amount of time. So we work a lot with our home health dietitians as well to help manage their TPN. And if they start to wean off of them, we help in managing that and make sure they're still able to meet their needs and maintain their weight while they're weaning off that TPN. And that's it. Thank you. Any questions for me at all? Thank you.
All right, next up, we have Anna Bruce, who will provide some very nice expert perspectives on nursing support and the role of nursing. Anna?
Hello, my name is Anna Bruce, and I'm oncology nurse coordinator. I work with Dr. Jin, and I also work with Dr. Andriatos, who's here today as well. I work with the doctors to manage about 200 patients and family members and act as their first point of contact for their doctor. A little bit about me. I've been a nurse for 8 years and have been in this current role for 4 years. So a little bit about what I do. Like I said, I serve as the first point of contact for both patients and any family members or friends with whom the patient authorizes me to speak. As my role suggests, I help coordinate with other departments on patients' behalf. I schedule scans and office visits with Dr. Jin, which are scheduled same day. I also reach out to other providers on the treatment team, such as Dr. Pani and Dr. Brandt and Dr. Kushner, who all spoke earlier today. I help arrange biopsies and endoscopies, both of which have their own departments. So it requires a bit of more communication between departments and patients. And all endoscopy and biopsy requests, the reason it takes a while is because it must be approved by radiology and GI respectively before either can be scheduled for a patient. Clinical trials, you heard a lot about clinical trials today. Each clinical trial has its own clinical trial coordinator. So the clinical trial coordinator and I join forces to get appropriate screening, labs, scans, biopsies, etc., scheduled for the patient. Throughout the patient's experience on the clinical trial, the trial coordinator and I continue to collaborate to ensure that all study requirements are met. I also collaborate with palliative care. Palliative care is a service that focuses on symptom management while a patient is undergoing chemotherapy or a clinical trial. Most often, this involves pain management, but also includes appetite stimulation and even includes discussing how the patient is handling their diagnosis and treatment. I've found that at different institutions, there are different definitions of what palliative care means. At some institutions, it is synonymous with comfort care or hospice. So sometimes patients I found get scared when they hear the words palliative care. So every time I discuss palliative care, I make sure to underscore the fact that at Siteman, palliative care is for patients who are living with cancer and that hospice is a separate service. Sometimes patients get admitted to the hospital. Sometimes there are complications. But when a patient is admitted to the hospital, Dr. Jin and I are frequently in contact with the inpatient hospital team. Dr. Jin and I collaborate on patient care, and while the inpatient hospital team manages the patient's care while they're in the hospital, Dr. Jin and I are always aware of the inpatient team's recommendation and the patient's progress. The general flow of a treatment day for a patient, from a patient's perspective, always starts with a lab appointment. We need to have the most current labs for each patient so we can determine whether or not it's safe to give the patient chemotherapy that day. Next, the patient will have an appointment with their doctor, and the doctor will assess how well the patient is doing, how they're feeling. We'll go over patient's lab results and scan results if they have scans available, and we'll listen to the patient's heart and lungs. After the patient is finished with the doctor, assuming that they're okay to receive their cycle of chemotherapy, the patient will go over to the infusion center to receive their infusion. When we introduce a new chemotherapy, I go over the chemotherapy with the patient. I always tell the patients that the most important thing to remember is that if they develop a temperature of 100.4 degrees or higher, that they call me immediately if it's during business hours, or call the after hours exchange immediately if it's on a night, weekend, or holiday. Those of you in the room that have met with me have probably heard me give this speech before. I also ask that patients get a digital thermometer that goes under their tongue and is easy to read to check their temperature at home. A phrase that we use commonly in the GI oncology world is the term chemotherapy cycle. It can be a confusing term, so I'll explain what it refers to. If patient's chemotherapy is every 2 weeks, for example, then your chemotherapy cycle will be 14 days long. If you receive chemotherapy every 3 weeks, then your chemotherapy cycle is always 21 days long. The day that you receive your chemotherapy infusion is always day 1 of your cycle. It's important to know which day of your chemotherapy cycle is day 1, because oftentimes patients are prescribed dexamethasone. Maya touched on this briefly in her discussion. It's a steroid to take on certain days of your chemotherapy cycle. The dexamethasone helps to prevent nausea and helps to prevent fluid retention in patients who receive docetaxel, one of the chemo drugs given in the acronym FLOT, which is a common chemotherapy given for esophageal cancer. Something that patients often worry about when anticipating receiving chemotherapy is nausea and vomiting. This is completely understandable, especially given how chemotherapy is portrayed in the movies and on TV. At Siteman, we help prevent nausea in several ways. We give anti-nausea medication through the port before the chemotherapy is infused. These anti-nausea medications work over a long period of time and often stay in the patient's system for about 2 to 3 days after infusion. We prescribe 2 oral anti-nausea medications that patients take home, prochlorperazine or compazine, and ondansetron or Zofran. These medications are available to the patient, and we encourage patients to take the medication even if they're feeling just a little bit nauseated. Some patients even take the compazine and Zofran around the clock to prevent nausea from coming on to begin with. Something that can be confusing, and it is worth mentioning, is that both compazine and Zofran can be in the patient system at the same time. So I suggest that patients take one. Some patients prefer to start with Zofran. Some patients prefer to start with compazine. Wait for 45 minutes, and if the patient's still feeling nauseated, to then take the other anti-nausea medication. You just have to keep track of when they take each medication, because the compazine can be taken every 6 hours and the Zofran can be taken every 8. I mentioned port earlier. I wanted to touch on what those are. Patients who start IV chemotherapy will need to have a port placed. A port is a circular, penny-sized rubber hub that is placed under the skin on the right side of the chest wall and has a long tube attached to it. The end of that tube goes into the superior vena cava, a large vein that takes blood back to the heart. When the patient gets chemo, a needle is inserted into that hub under the skin, and the medication goes into the catheter that is located in the superior vena cava. Then the heart pumps the chemotherapy throughout the body. Once the chemotherapy is finished infusing, the needle is removed from the hub of the port. There's nothing that sticks out of the chest, so patients can shower, swim, and take baths as they normally would. Additionally, the ports that are placed at BJC are called power ports, meaning that when the patient has a CT to check their progress, the chemotherapy port can be used to inject the IV contrast, so the patient doesn't require a second IV to be placed. These port placements are done outpatient. The patient is put under mild anesthesia, and they can go home afterwards, but they'll need a driver. The most important role that I have in my job is triaging patients who call with symptoms. If a patient has concerning symptoms, the patient starts with calling me. I ask a series of questions to get a better idea of the whole picture. And then depending on the symptoms and the severity, I will recommend next steps with Dr. Jin's help. I make sure that the patient is not experiencing emergent symptoms such as chest pain or shortness of breath or a fever. Sometimes, when appropriate, I will refer the patient to the cancer care clinic. The Cancer Care Clinic, I'm sure some of you have been there. It is a nurse practitioner run clinic for cancer patients located in the lobby of the Center for Advanced Medicine, or the CAM, as we call it. It's kind of like an urgent care for cancer patients. It is a fantastic resource. Patients need to have appointments, which have to be made by us, the nurse coordinators. So unfortunately, it's not a walk-in clinic. We call it the CCC for short. So the CCC can do all diagnostics, including urgent CTs. However, the CCC is for stable patients only, and patients who are unstable will have to go to the emergency room. The CCC is open 24 hours a day, 7 days a week, including holidays. So patients who need an infusion, fluids, an injection, or chemo pump disconnect on a weekend or holiday will have those done at the Cancer Care Clinic. It's important for patients to know that evaluations done in the cancer care clinic can take a few hours, and I always remind patients to bring some personal belongings to the cancer care clinic in the event that the patient is admitted to the hospital from the cancer care clinic. The nurse practitioners who do the evaluations are in contact with Dr. Jin and myself, so not only are we aware of what's happening with the patient, we also have input. And the last thing I wanted to bring up is the little bit about why I do the job that I do. I've had patients ask me before how I can do this every day because sometimes it can be sad. The reason is I get to meet patients at one of the most, if not the most challenging parts of their lives. And those of you who are here have let me into your lives, and some of you have even let me into your families. And in my opinion, to be able to help someone through that part of their life is an honor. So I want to thank you for letting me do my job. Thank you.
All right, so then I will introduce our next speaker, Dr. Amaris Tippy, and she's going to talk to us about Siteman Psychology Service and the great work that she does with our patients.
Good afternoon. Thanks for hanging out to hear me talk. I know it's been a long day, exciting. Each patient with cancer and their caregiver has a story, an experience. And while a lot of today has been regarding treatments and tests and logistics and resources and things like that, we want to also think about the people inside those stories, right? You. And the emotions that can come with facing cancer. When someone is diagnosed with cancer, it doesn't just affect the body. It comes in and touches every part of life to some degree. Your thoughts, relationships, sense of control. Feelings like fear, sadness, anxiety, or even anger are not signs of weakness. They're normal human reactions to a challenging situation for both patients and their loved ones, including caregivers. We call this cancer-related distress, and it's something nearly everyone goes through at some point when cancer has impacted your life. So here at Siteman, we have an oncology service that is absolutely free to every patient. We do have groups for cancer caregivers as well. We work hand in hand with the medical team to help you cope and find strength and even approach end of life if that is occurring. Our goal is to make sure that emotions are felt, seen, and validated in regard to your cancer care. Adjustment to cancer is just not a unitary single event, but rather a series of ongoing coping responses to multiple tasks associated with living with cancer. Those can be different for everyone, but you can see here that there are common periods of distress and significant challenges. And waves of distress are not uncommon. So what we typically see is that patients kind of have like a roller coaster of distress. So there's periods where maybe distress is lower, and then especially kind of transitioning to any one of these periods, like a new treatment, or even survivorship if your cancer is controlled, can bring on some of these emotional responses. Here you can see some of the psychological impacts of cancer on our patients and caregivers to some degree. Some of them are relevant, others not, but the National Cancer Institute describes distress as an extending along a continuum ranging from common normal feelings of vulnerability and sadness to problems that can be disabling, such as depression, anxiety, panic, social isolation, loneliness, and maybe even spiritual crisis. So while not everyone develops a clinical diagnosis like major depressive disorder, generalized anxiety disorder, or post-traumatic stress disorder, most patients are impacted on some level to some degree by cancer-related distress, at least intermittently. So what I'd like to do is just look a little bit closer at depression and anxiety. Depression is not only simply a feeling of sadness or tearfulness. It's a disorder with specific symptoms that can be diagnosed and treated. And for patients with gastric cancer, we anticipate about 3 out of every 10 patients to be diagnosed with major depressive disorder. That does not include patients who don't meet the criteria for depression, but have underlying feelings similar, but might not meet criteria. Numbers for men and women are about equal. And here we see some of the other symptoms of depression, because many times we'll hear, oh, they are sad, right, in general, but there are cognitive, behavioral, and somatic symptoms of depression. So you can see here kind of the cognitive criteria for depression: trouble focusing, difficulty making decisions, memory problems, sometimes suicidal ideation or thoughts about wanting to end one's own life. And while it might seem ironic when many patients are undergoing treatment for cancer, sometimes they simultaneously have thoughts about wanting to end their lives. And that's not uncommon, and it can be very confusing for patients. Behavioral symptoms: loss of motivation to do daily activities, loss of interest, withdrawal or isolation, frequent crying, anger. This is one that's not necessarily known in kind of the lay population that doesn't do this work on the daily, but anger is often a symptom of depression in women and especially in men. So increased irritability and anger. Finally, there's somatic symptoms you can see there: fatigue, appetite loss, things that kind of affect your body. Sexual problems. Sexual problems are not often talked about by providers, or not often brought up by patients, right? But it's a common concern that often leads to distress in cancer. So you'll say, well, my treatment might cause some of those, right? Like trouble focusing, or memory or fatigue, appetite loss. So we take that into consideration when we're talking with our patients. A next big player is anxiety. Anxiety occurs in varying degrees in patients with cancer, including gastric cancer. Investigators have found that 44% of patients with cancer reported some anxiety, and around a quarter of patients reported significant anxiety. Anxiety, in a sense, is often exacerbated or made worse by uncertainty and loss of control, and may also be secondary to other aspects of your medical condition. So for example, uncontrolled pain, nausea, medicine side effects. There's a number of reasons that it can come up. All patients, all providers, me, experience normal worry, okay? But I'd like to contrast normal worry with some serious symptoms of anxiety that may occur. So normal worry kind of comes and goes, may have some difficulty concentrating, but you're able to kind of turn off those thoughts, okay? You may have some kind of sense of crying spells or fear, but if we look at the more serious symptoms of anxiety, that worry seems constant. You're unable to concentrate. You're not able to turn off your thoughts. You might have difficulty sleeping. Fear and apprehension are just kind of always present. Can have many physical side effects. So panic attacks, racing heart, dry mouth, restlessness, shaky hands, fidgety, feeling keyed up, just not able to sit still. And you don't really have the ability to reduce those feelings very easily. This side of the continuum, right, like that we're looking at, is fairly common in cancer in general. This side is when we get more serious. And I don't know if you guys are provided these slides, but you can have that to look over too. So why is psycho-oncology important to oncology patients? It's a growing area of oncology over the past 30, 40 years that focuses on the psychological, social, and emotional impact of cancer on patients and caregivers. We address psychological issues affecting patient and caregiver quality of life. We work to empower patients to take a positive and active role in their cancer care. We help with communication, and we try to help patients and families adjust to a difficult disease and a difficult disease process. Psychologists often practice in individual and group settings. An extensive body of literature supports efficacy of psychosocial interventions for patients with cancer. You can see some of them here. Psychological and social interventions have generally been identified as non-pharmacological, right? So if you come to our service, we're not going to immediately try to give you medicine to take care of the situation. We're going to sit, listen, provide support, kind of get an idea of what your experience has been like, and then provide recommendations we can find helpful. We often pull from a number of these interventions instead of sit down and do an entire like protocol, kind of manualized situation. We don't do that unless it's really needed. So here's a list of some of the evidence-based strategies. One of the ones that I want to highlight is problem-solving interventions versus emotion-focused coping strategies. I think this is the one that I see most significantly. Probably for almost all of you, you're probably pretty decent problem solvers. If I put a problem in front of you, you can find some kind of solution. But if there's a problem that doesn't have an accessible solution, like feelings of emotion and all of that, we need these emotion-focused coping strategies. And including myself, probably most of us in this room are lower on that continuum, and that's where we can bolster you up to help feel those feelings, learn how to sit with them, and allow you to navigate your life forward. We know therapy groups have similar effectiveness in many patients and individual therapy, and also have the extra component of normalization, validation, and reducing feelings of isolation and loneliness. That may, if there are patients with us, be one of the reasons why you came today, maybe to be with other people that can understand your experience somewhat. Our current groups at Siteman Psychological Services include a newly diagnosed group, which is diagnosed within the 6 months. Metastatic cancer group. I run a young adult metastatic cancer group for people under the age of 45. We have a survivorship group that are people who are in remission or on long-term maintenance therapies. And we have a group for caregivers. And I also run a mindfulness and stress management drop-in class. I can see some people like shudder at the thought of groups, but what I will say is if I can convince a patient to join a group, it is so powerful and they're so thankful. So if you're kind of on the fence, interested, join us once, see what you think. So we're lucky that Siteman values this aspect of our patient care. We have 7 licensed clinical psychologists and often 1 to 5 trainees, including postdoctoral fellows, interns, and residents, and doctoral students. We see patients from diagnosis through survivorship. Unfortunately, we're unable to see patients for grief therapy, but we do have great referrals for that. We see individuals with cancer and caregivers. Currently, many of our caregivers are actually seen through our cancer group because we have to prioritize the influx of patients that we get. We do have individual referrals for caregivers as well. All of these services are free, but it is brief, so it's limited to 10 sessions, and it's not on the slide, but it's all telehealth. So it's either on the phone or Zoom per patient preference. And it's all cancer related. So if there's not a cancer related portion to your distress or concern that you're bringing forward, we would refer that out. And while I briefly discussed a list of interventions and strategies, when psychologists choose an intervention, it's never just about treating symptoms. It's about connecting with what truly matters to the person in front of us and using some of those evidence-based strategies in reducing symptoms, improving their quality of life. So I'm hoping now we can hear from a few patients going forward. So thank you for your time. If you have questions, happy to answer them later. And for a referral, the oncologist can place a referral, or you can call and self-refer.
Thank you, Dr. Tippy. And now I'd like to introduce our first patient perspective, Sydney Raskin. No Stomach for Cancer representative here. So he would like to talk about his experience, gastric cancer.
Hey, that's me. It's a very big me. Hello, everybody. My name is Sydney Raskind, aka Sydney Raz, all over the internet. Like that slide says that I made in the back while everyone else was showcasing that they already had prepared slides. I do have about 8 million followers across the internet. I got well known for posting about life hacks, tips and tricks. And my tagline is things I wish I knew before I was in my 30s. Became popular around the same time everyone else did, but with COVID, everyone being at home, that kind of thing. So that's kind of how I got my following. Starting with that, it has lasted for about 4 years full time, which is my dream come true. And then in March of 2025, I was diagnosed with stomach cancer, stage T1A. So just want to say thank you for inviting me to this. Thank you for being in the room. It feels very nice to not be the only guy with cancer in the room, to just be around people that, you know, I can look at and go, no, you have chemo. I'm not. I just had my stomach removed. I'm not a big deal. No, thank you. Because when I say I have cancer, everybody wants to know who, what, when, where, why, you know. How did you find out? Why did you take your stomach out? Can you burp? Things like that, right? So again, just thank you to John. Thank you to everyone in this room. But let's go to my story, kind of going over it a little bit. Basically, in March of 2025, I got a upper endoscopy because there was a chance that I had stomach cancer, hereditary diffused, because I found out that I had a gene deletion, ctNNA1, which is the cooler version of CDH1 in my opinion, because I'm nothing if not a hipster in all things, even cancer. So I got that phone call that I had the gene deletion in 2024, October 2024. And then I wait a little bit, decided to get the upper endoscopy done. And then, of course, I come out of the upper endoscopy at City of Hope in Duarte, very close to me, in Los Angeles, and everything looks good, right? Oh, man, your stomach looks great, bud. Yeah, don't worry about it. And about a week later, sorry to tell you, you have stomach cancer. What do you mean, right? What does that even feel like? The presenter right before me talked about anxiety, depression, bouts of fear, uncontrollable sadness. I had it all, right? And meanwhile, I have a toddler in the other room, just being a toddler. Very difficult for anyone who doesn't have a toddler. So then we go in, we find the 1.7 millimeter cancer in my stomach, and we have a choice. Either you take out your stomach or you're surveilled. So my wife and I decided to take out the stomach. And I can't tell you how sort of relieving it was for the doctor when Dr. Yang-Hee Wu walked into the room after reading a chart of a 36-year-old seemingly healthy male, no underlying conditions, maybe could lose a few pounds. But that was her words, by the way, not mine. And how relieving it must have been for her. For me, after getting this diagnosis and having it explained to me and looking at her and going, no, you don't need to convince me to get the stomach out. It's good. Take it out. because I didn't want cancer. Everything else doesn't matter, right? Oh, well, you're gonna have to change your diet. Oh, well, all of these things. But for me, the cancer issue was the big thing because I had already lost my mom to cancer, lobular breast cancer, which ironically enough is caused by CTNNA1. But nobody knew that at the time. So I wasn't going to leave my wife. I wasn't going to leave my daughter. I wasn't going to leave anybody behind, especially at 36. I mean, look at me. I'm gorgeous. So basically, that was a big swing. I appreciate that. Thank you. Basically, we didn't really have a choice. It was take out the stomach, right? So then I posted about it on the internet because I got a lot of followers. And then I found this incredible community. And then John calls me and goes, whoa, 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 whoa. Maybe you don't need to take it out like tomorrow. You can wait a sec. And I went, nah, come on. Cancer bad, out good. But then I talked to other doctors in the community. I talked to other people in the community, Dr. Jeremy Davis, and got more testing, and endoscopic ultrasound came back positively. And I decided to wait a few months and just grieve the loss of my stomach while I had it in the best way I can by eating everything, gaining more weight, because obviously I'm going to do that, and going to Vegas. That was probably the best decision I've ever had. It was my first time and last time with my stomach in Vegas. And I will be going back without a stomach. And I just had fun. I just had a fun 3 months. I vlogged it. I posted about it, raised money, and tried to understand this new existence that I'm living in now. And then July 3rd of this year, I got to celebrate Independence Day from the British and cancer. So that's when I had my total gastrectomy. And it has been a steep learning curve. It has been not as difficult as it could have been. I think I was already sort of becoming more connected to my religion and Judaism before this. And then once I found out that you can get a genetic test done that connects an entire generation and generations to come and generations before, I thought, okay, I'm good. I'll go to temple more, that kind of thing. But since July 3rd, it's been difficult, but also worth it, because now I don't have stomach cancer. And I've been really happy to meet all these people, and it's been incredible. A big part of that story is the genetic testing, right? Why did I get that genetic testing? Well, the reason for that genetic testing was because in August of 2024, I lost my second daughter to holoprosencephaly, which is a genetic or a birthing defect, which basically my second daughter wasn't growing a brain. So we lost the pregnancy, and we wanted to find out why. So we sent out some of her DNA after she was delivered, after holding her, after going through that process. And when we sent out some of her DNA, she came back with the marker. She came back with the CTNNA explanation for my mother passing away and for me almost passing away. So Delphina Joe is the reason why I'm here. And she's the reason why now I can tell my living daughter, my cousins, my aunts, everybody to go get genetic tested. This is CTNNA1. Hey, if you have it, you might got to get your stomach out, but at least you don't have cancer. So I always get to say something where it's like, well, if you really want to be depressed, let me tell you how I found out. That's depressing. And since it's so depressing, let's go into questions that I get asked from the internet about not having a stomach, because they're way funnier than the story I just told you. How did you recover so quickly? My best friend and basically my sister-in-law, Lindsay, asked me. Well, I had to tell her this, and since this is being recorded, I will say it again, because you helped me. And my friends and family matter a lot. So thank you, Lindsay. Thank you. Can you eat any foods, or are there any foods you cannot eat? I get very lucky to answer this question, right? Because, nah, dude, I'm eating everything. Maybe a little bit slower, maybe a little bit less when I take the big bite and have to think about it all the time. That's been pretty annoying over the last 3 months. Because before I had my stomach, oh boy, I was gross. What's been the most challenging part about this change? My blood sugar levels, I would have to say. I recently started taking ADHD medication. I don't know if you could tell, but my blood sugar spikes have been crazy. My weight loss recently has kind of not been alarming, but it's like, oh, I look like I was 21 again. That's not good. Or is it? But the blood sugar thing has been hard, right? So constantly having to snack, constantly having to like make sure that I'm not angry for no reason, right? Because there's no stomach stopping me from getting to the angry for no reason part of eating. So I think that's been the most challenging thing for me. Do you always feel hungry? No, because I never feel satisfied. So it's like this weird thing where I'm basically just a luggage carousel for food, where I just eat, wait 30 minutes, it goes down, wait 30 minutes, maybe have something else, and then it just keeps going. So if I never feel satisfied, I never feel hungry. And if anyone has seen The Curse of the Black Pearl, when Captain Jack talks about this, or not Captain Jack, Captain Barbossa, the bad guy, it's basically like that, except not in a terrible, ghoulish way. So no, I don't always feel hunger, but I also never feel satisfied. It's really, really weird. Does food taste different? This is something that I thought would happen. No, food does not taste different. It still rips. It's awesome. Probably even a little bit better now because I'm so grateful that I can still eat it. My food intolerance isn't there, so it's been amazing. Who or what has been your best resource? Shout out John. Right? Shout out Hope for Stomach Cancer. Shout out No Stomach for Cancer. Shout out so many incredible people. All of you in this room. Incredible resource. And of course, since this is being recorded, my wife, obviously. Only my wife. Because without her, I would not be here. I cannot stress that enough. She has saved me so many times. Was there a point when you thought you weren't going to make it? Absolutely. There was a point in those first few weeks where I didn't know what kind of cancer I had, how much, where it spreads. And I thought, that's not good. I'm going to be as coherent as possible through this process, but until we know that I'm not going to die, yeah, I thought I was going to die. But since I had been through it so many times, one of the biggest things that was pulling me through the grief process and knowing that I had to just kind of like keep my head on was knowing that I didn't want to leave my wife and daughter, was knowing that I had access to therapy. I had 100 milligrams of Zoloft already pumping through me because PTSD, dog. So I was okay. But yes, I was scared. But then I got more information and I wasn't as scared. The mental health piece must be a huge part of this recovery. What steps did you take? I encourage anyone who has not been to therapy to go to therapy. It's really helpful, especially when you think everything's ending and you can't stop crying like we just heard about. And for so many other reasons, therapy has been so helpful. My wife and I are in collectively 3 therapy sessions a week. Personal, couple, me, her solo, us together. I would say that I think I gain more benefits from the couples therapy. But that's just me. So go to therapy, y'all. Even if you don't have cancer, go to therapy. Have you eaten in any restaurants yet? Yeah, and it was scary. One of the things that I was really not looking forward to was being stared at while I was eating. Everyone in my circle knows me. Everyone in my circle knows how hard it is to exist already. So to have something like, hey, that guy's got no stomach, this is going to be cool, right? Terrifying. What's also really, really, really inconvenient and rude of a lot of people in restaurants is they still have stomachs. Not cool, guys. Not cool. I would appreciate it if you did not shove that in my face all the time. But it isn't. Everyone's there just eating at a restaurant. I can order the same food. I don't have to be scared. Nobody thinks about it that much. If anything, my close friends and family, we all just enjoy the experience of me being there a little bit more now. And yeah, I eat slower and I'll eat some of it later. But yeah, restaurants were scary, but I go to them a lot. And I feel kind of vindicated too, to be like, yeah, I'll get that spicy thing. Oh, cake? Gimme. Not too fast, but gimme. Is there anything you can't eat anymore? I already answered that. People really like to ask this question. This is the big one. It's like, what can you not eat? How are you managing getting enough calories? This is something that I'm still learning. Since my surgery, my total gastrectomy was only in July, I'm kind of learning how to eat again. My body is learning how to balance everything out, right? It's difficult. But my mother-in-law, when my father-in-law was passing away from cancer, gave him Benacalorie. So much to the chagrin of me having to say that my mother-in-law is right. For any of you in here with son-in-laws that also have that problem, I apologize. We're doing our best. I have Benacalorie now in my bag, right? Just in case I need it. I still eat the same amount of meals. I still eat generally the same amount of food my wife does, the same amount that I was when I was a stomach person. Now that I'm a stomachless person, I feel like I am still eating, but I'm still losing weight. So I'm still balancing all of that out. Is it a multivitamin? Is it a different type of high calorie food? We were really, really, really diligent at the beginning of getting enough calories. But as Dr. Yang Hee Woo mentioned, you breathe and you lose 1,500 calories. That's all day, right? So if I have to get 2,100 or, maybe even 3,000, that's kind of difficult because I wake up and I need to start eating butter. Like, I don't know what do you do? The answer is yes, it's butter. Just add butter to everything. Mayonnaise, it's pretty good too. This is a question that I would actually like to talk about with people after this session today is done, but the process is similar, but a partial stomach removal is more connected to a gastric sleeve, right? Gastric bypass. So since there's food somewhere to catch and that bowl is still there to like muddle things up, I do obviously connect with this as, yes, stomach cancer marker for your husband, partial stomach removal. But in my experience, some people that I've talked to that have gotten the partial stomach removal have just done the total gastrectomy later, right? So to me, I'm like, yeah, it's pretty much the same, except I don't have a stomach. You will still have a stomach. So I don't know. It's like a toss-up, right? It's like, I really hope my answer for the internet was, I'm so sorry about your husband. That's terrible. Obviously, this is very similar to mine, but definitely look up the symptoms and care for someone with a gastric sleeve. That's usually that's what I would tell people. I always have to preface all my videos with, hey, I'm just a guy. I'm not a doctor. Please don't listen to me as much as you could to like a real doctor. This is one that I mentioned earlier. Has your perspective on life changed at all? I'm a little less annoyed with my toddler. I'm a little less annoyed when she screams at me because I just want to brush her teeth. Or if my wife and I get into an argument, I'm a little bit more aware of the fact that I could have not been here if we had waited 3 years. Obviously, my connection to my spirituality helps a lot with that. My perception of what matters kind of changed a little bit, but I think that's evening out. So I think I'm getting back to my old grumpy self. So that's good. Bioreflux is something that people ask me about a lot. I was scared of bioreflux so much in a hospital that I did not lay down straight for 7 days. I couldn't do it. I was scared. I don't recommend it. It was awful. My back still hurts. But the way that I mitigated this was just by having a wedge pillow. Wedge pillows are fantastic. They're very cheap. They're very comfortable. Couldn't cuddle my wife as much, but not having bioreflux was totally worth it. Now I'm okay. About 3 months out, I don't really have that issue anymore. Actually, yesterday in the hotel room was the first time where I ever got to a bed and laid on my back without even thinking about it. And I just stared at the ceiling and I thought, nothing. Whoa. I never thought I'd be able to do that again. So bioreflux is a big one, but it's not as bad as I thought. Has my recovery been better or worse than I expected? Much better. Much better. And I chalk this up to being young and healthy. 36, all of my other organs working. Didn't ever really have the best relationship with my stomach before. Had really bad heartburn, not because of cancer, but because of a hernia on my esophagus? Question mark, doctors? Yeah, that sounds right? That one guy's nodding? Okay, cool. So they took that out. That was pretty cool while they were in there. But yeah, so now I just feel like my intestines have been doing a lot of the work anyway. So now I think my body overall is just very supportive, more so than I think a lot of people have it. How do you stay hydrated? By drinking water. It's pretty cool. Drinking water is something that I didn't think I would be able to do, and I thought I would lose it completely. So I'm kind of thanking God every day that I can still drink water and enjoy water. Maybe one day I'll have to go into liquid IV or something, but right now I just drink slower. I kind of like it actually, because now I know the true volume of how much space I have. 2 big gulps instead of a minute and a half of gulping. So yeah, I still stay hydrated the same way. It just very similar to eating. You just take it slow. This is a weird one because no, I don't get food stuck in my esophagus, but this is how I feel full. Because food, if it gets stuck in your esophagus, you are in a way worse shape than you think. You're gonna choke to death. So no, I don't feel this. I chew a lot. I chew so much that I think I'm getting strained. The next one coming up is one that I get a lot. Yes. And it's bad. I don't recommend it. Just to go back to this one really quick. I'm so sorry to my wife. We got an air purifier just sitting in our room, always on, always plugged in, just in case. So it's a very big deal. And it was one of the things that I did not expect. How are you navigating chewing and swallowing? I do it a lot. It's probably one of the biggest mental hurdles I face every single time I take a bite. Dr. Davis was the first one to tell me about that, but I didn't expect it to actually make me sad every time. I didn't expect to struggle to not swallow as much as I want to, right? So now I'm just still getting used to it. But yeah, chewing and swallowing, it's just a lot more work. What do I miss the most about pre-op days? Drinking water for a minute and a half. I made videos, I vlogged, and one of the things that I knew I wasn't going to ever be able to do again was really just like just go to town on some water. Just demolish a whole bottle, right? And feel that encompassing relief of coolness in your stomach. That's the thing I miss the most. Yeah, that's the thing I miss the most. But again, very lucky that I still get to do this, right? I still get to drink water as much as I can. So in conclusion, as people do when they're presenting, talk about fundraising really quick. With that larger audience, I decided to raise some money. I decided to take the power back a little bit. So in between the 3 months of me finding out I had stomach cancer and me having my total gastrectomy, I decided to raise some money, and we raised $75,000. Yeah, that was pretty cool to be able to do that, to be able to donate that to the various organizations in this community. And it was really, really cool. So I just want to say, again, thank you so much for everyone that has helped me through this. Thank you for everyone in this room. And I hope this has been eye-opening to some of you from what a patient's perspective is, the questions that he or they will get asked on the internet. It can be fun. And John wants me to talk about how there is a mixer after this at the hotel, the Elemental Hotel. Yeah. And then tomorrow morning, there you go. Make sure to tip your waitresses. And thank you so much.
Thank you, Sydney. And our next and last talk is Mr. Scott Brown. He's going to give another patient perspective. And please, everybody, let's give a warm round of applause, Mr. Brown here.
Sydney, you can add a +1 to your 8 million followers. At least a 1 + 1. My name is Scott Brown, and I am a father of 3 daughters. One is 10 years. 2 others are turning 12 and 14 next month. I'm married to an amazing woman who battled breast cancer 4 years ago and is now cancer-free. So I have been both a caregiver and someone with cancer. I was diagnosed exactly 6 months ago with an adenocarcinoma in my esophagus that it had been found that it had been spread to my liver as well. Not a good day. Not a good day. It was a friend of mine actually that did the endoscopy, and she took 30 minutes to come back to tell me. And I knew during those 30 minutes that the news was not going to be good. And I started to pray. And then she just laid it on me and said, no, I know what this is. And as luck would have it, within 2 weeks, I had started chemotherapy. I'm wearing a chemo pump right now. And so if some stuff I say doesn't make sense, then we can blame it on that. First off, I want to thank all of those on my treatment team and those who hand me pagers during chemo, those who make a poke in the arm and a poke in my port a little bit easier, and who just offer a smile. All of them are outstanding individuals, but as a team, they're amazing. And you know who you are here in this audience. Early on in this disease, and this is all within the past 6 months, I decided I would try to learn what I could from this experience and to extract as much wisdom for my mind, my heart, and my soul that I can. One lesson I learned the hard way was I went on a family vacation exactly 2 months after the diagnosis. We landed in Phoenix and it was 111 degrees Fahrenheit, and I was wearing a chemo pump. And at 10 p.m. that night, I was sitting by the pool wearing that pump, and it was still 104 degrees. In hindsight, that was a bit of an overdue. I will not fly with a chemo pump again and land in the hottest city in America in the middle of June. But in full disclosure, we were headed to Northern Arizona where it was cooler. So you don't think I'm completely insane for being in Phoenix in the middle of June. But I do have to say a few words about my oncologist. The first day I met him, he told me things I mostly did not want to hear. But the thing that he said that stuck with me was he said that he would treat me like his brother. And that stuck with me. And every time I see him, I think about that statement. Now, immediately after he first told me that, I thought, boy, I really hope he likes his brother. But I know he does. But I have hardly seen a human being, and much less a doctor, with such expertise and so humble. And my doctor is Dr. Jen. The poet Mary Oliver wrote in her poem, Summer Day, "Tell me what it is that you plan to do with your one wild and precious life." Well, now I know one additional thing that I'll be doing with my wild and precious life, and that is dealing with the big C, or cancer. I call it the big C because my cousin was diagnosed with cholangiocarcinoma 10 years ago. She's still thriving. And she called it that. She's like, "Oh, you got the big C, huh?" So that was my first conversation with her when I was diagnosed. But I also have to kind of, there is some dark comedy, I guess, with cancer. And that is that both of my parents suffer from dementia. My stepfather suffers really badly. And at the beginning, it was exhausting for me to tell my story. I could tell about one person a day about my diagnosis. And I didn't want to end up being the counselor. People would cry and weep and had all sorts of questions that I really couldn't answer. But my stepfather would come every day, and he could remember there was a problem, but he couldn't remember what it was. So I got to practice on him. I told him sometimes a dozen times in every conversation that I had esophageal cancer, and that practice allowed me to discuss it easier with others. So his disease helped me in describing my own disease. So I am very thankful to him for that. Cancer to me is not just a fight. There's a lot of kind of this ethos of fighting cancer. And certainly I have had my days of fighting it. But fighting for me is exhausting. I spend a lot of time just dealing with it without, in my mind, thinking of that I'm fighting it. Sometimes I do fight, but other times I just try to sit back and enjoy the moment that I am in, and sometimes just pray, and sometimes get to work and occasionally push out of my active consciousness that I have the big C at all. But I do not forget. The disease of cancer is an ordeal. In the first months of the diagnosis, I felt like I was confronted with this terrible choice. I could either accept what was happening or I could reject it. And when I say reject it, I don't mean that I would refuse treatment or anything that I would just be mentally rejecting the reality of what was happening to me. In other words, you wouldn't be able to see the difference of me accepting or rejecting it. I would go through all the motions. In the first several weeks after the diagnosis, I would wake up in the morning and it seemed like all was good. And then I would remember that I had cancer. And I would literally remember it like it was this brutal experience that I had to relive when I remembered it. But once I accepted the disease, then the path forward became easier. And I cannot articulate why, but my mind and my heart were more at ease once I had accepted it. I am an N of one. And what that means in scientific terms is that if you know one person's path with the big C, then you really only know that one person. And even if the diagnosis is exactly the same, what that person brings to that disease from all of their hopes and dreams and experience, that helps to inform how that disease affects that person moving forward. My days are probably more full than they were prior to cancer. I wake up before 5 a.m. I got up at 4:45 this morning, start the medication regimen. I pray to the Almighty with all my heart, all my soul, and all my strength every day. And I work to treat my neighbor as myself. I'll just say anecdotally that what Maya said is that diet is very important. I believe that food is medicine. Nutrition plays a big part in how I feel. I chose to go to a strict keto diet. That is because my wife decided that that was the best course for me, and she is back there in the back of the audience. I absolutely could not have done this without her. And I don't think I was the caregiver for her that she was and is for me, but I am just so grateful that she is in my life. There's a lot of ups and downs on this path. I've had like a Charles Dickens story, it's been the best of times and the worst of times. I've had the best of news and I've had the worst of news and everything in between. I do my best not to get offended at anything anyone says about my diagnosis. I really don't think I have been offended, but I've had some people say some strange things like, you know, because my wife also had cancer, they asked if we lived under a nuclear reactor. And, you know, who knows, maybe there was one that back there and they got rid of it. But I don't have time to be offended, and I don't want to get all spooled up about anything anyone says, because most people, if they say something awkward or strange, is because they just don't know what to say. The Almighty gives each of us grace every moment of our lives, and as parents, we give grace to our children. So why can't we give grace to each other? And lastly, I cannot emphasize too much how prayer is vital for my life. It always has been, but now I pray differently. And now sometimes prayer is just a single sigh. If you want to hear about my faith path, I'd be happy to share that with you, but that will take a far longer time than I've been given today. So I will just wrap up with a thank you. So thank you.
Thank you, Mr. Brown. Thank you, Sydney. In the last couple of minutes, I'd like to make some closing remarks. So first of all, I'd like to thank all of our speakers, moderators, committee helping me organize this, sponsors, and of course, everybody in attendance, and in person and virtually. So I'm a physician scientist. Fortunately, I didn't get to talk about any research. So as I said at the very beginning, I want this symposium to have kind of a vision of hope. Okay, so very quickly, talk a little bit of science on a higher level. And this is my kind of vision for the future and how we can cure this disease. Okay, and it basically boils down to 5 important points here. Okay, so number 1 is we need a better understanding of this cancer. And classically, we've thought about cancers as a tumor. We call it bulk. But what we know is that cancer cells are eachly unique, okay? And those unique properties of each cancer cells determine what treatments are going to be effective or not. And fortunately, in 2025, we now have technologies to understand these cancers at single cell resolution. Okay, so that's going to be critically important. Number 2, we need to have better predictive and prognostic biomarkers. I talked a little bit about this in my talk, but those treatments, 50% do worse than those curves, 50% do better. We don't know why. And we need better markers to figure out which patients will benefit. Number 3, we need to come up with new, what I call tumor intrinsic vulnerabilities. Basically, how can we target the cancer without making the rest of the body sick? And these are some new pathways. We won't go into the details. Number 4 is we know that especially for some of these stage 4 treatments and kind of chemotherapy, they stop working. We don't know why. And what are those resistance mechanisms and how do we overcome them is critical. And number 5, and this is something near and dear to my heart, is we don't understand how these gastroesophageal cancers develop. If we did, some of those early talks, then we can truly prevent this disease from occurring, okay? So to kind of talk about the vision and kind of close off, here at WashU and Siteman, we are really trying to start a foregut oncology research center of excellence. This is the mission that we have, and the vision is to kind of develop new cutting-edge treatments for patients with gastroesophageal cancers. It's founded on 3 core principles, essentially what we call multidisciplinary crosstalk, in which oncologists like myself work with gastroenterologists, surgeons, radiation oncologists, and we all work together. Number 2 is we personalize medicine. We know that everybody's cancer is unique, so we need to treat those cancers as unique diseases rather than just one big group. And then 3, and most important, we need to take what we learned in the lab back to the bench side. And we need to do this in a timely fashion. And these are the 3 most important cores. So I want to close by saying that all the talks that we've heard today are steps towards a future in which gastroesophageal cancers are diagnosed earlier, we treat them more effectively and safer, and patients dealing with the disease, we can support them with more compassion. So I want all of us together to take that trip and make those steps and take that journey together, okay? So thank everybody for coming, and safe travels. Thank you.